Welcome to this free Unreal Engine Beginners course. This is a fully comprehensive 6-hour tutorial where you will be learning all the tools and basics. If you would like to learn everything there is to know about using Unreal Engine like a pro, check us out on skillademia.com and get access to the full course. Now, let's get started.
Hello everyone, my name is Giuseppe Luigi Alfieri and I'll be your tutor throughout this course. This course will focus on Unreal Engine and specifically all the coding perspective of it, as well as we will look into a little bit of design. I'll talk a little bit about myself now. I am a game designer graduate from Falmouth University. I have done a game called Psycho in Unreal Engine, and this game has received a lot of praise for overall its look and all the different puzzles that are present within the game itself. If you want to check out the game, you can feel free to do so by itch.io/psycho. And this project gave me enough experience to feel comfortable enough to be able to teach Unreal Engine, as you will see later down the line in this course. And for what we are going to be developing, so my idea is to have a game based around colors, where what you're going to be doing is picking up colors, putting them in places, and this is going to unlock things within the world. I'm also going to have an extra video at the end of this course that is going to show you a little bit more in depth what potentially you can do with this idea of the colors, so that I can lend you a project that you can feel free to expand upon by your choice. This is a little bit of what the end game of this project will look like. So you will have a little bit of a gun, a score point on the top left. You will have the possibility to pick up colors, to shoot them. You're gonna have sounds as well. And overall, we are going to be working on all these different systems in order to show you what Unreal is capable of doing, as well as giving you enough of a different type of structures to be tried in order for you to improve. And we are going to pretty much have this little gameplay loop going on. So I'll see you in the next video that will start the course itself, where I'll show you how to install Unreal Engine through the Epic Games Store launcher. So have a good one. Okay, so once you opened up your project, you will see these two chairs, the table and a glass statue. The way you see these is thanks to the scene window, which shows you what objects are inside your game engine, your level specifically. The way you would move within this scene is through your mouse. Right-clicking and holding the right mouse button and moving your mouse will give you the possibility to rotate around, while holding right-click mouse button and pressing A, S, T, or W will give you the possibility to literally move around the scene. If you want to move up or down, you will simply press Q or E. The scene window is where most of our game will actually be in. This is visually speaking what there is in our game, and this is where we would usually add things to our game. We can see all the things that we added within this scene view thanks to the word outliner, which is here on the top right. The word outliner is simply a list of all the objects and actors that are present within our scene window. You can access each one of these objects by simply left-clicking on them or also pressing onto them through the word outliner. The way you order and organize objects within the word outliner is, as you can see, through folders. So let's say that I want to add another folder and call this folder objects. I would simply press on the right, on the top right little folder icon here, and in this way I would create a simple folder. Which will give me the possibility to organize better every single element present in my scene. Anytime I press on an object, the detail panel will show me each property and values that object has. For example, here, by pressing on this table, I can actually see his transform, his static mesh, his materials, and everything that that object contains. These parameters are usually values that you can actually change within the editor. I will be going through some of what these are later down the line, so don't be scared if you don't know, for example, what a static mesh is. It will eventually be more clear once we go further in the course. And this is mainly it for when it comes down to accessing things within our scene. The way we would add more content or more material to play with in our engine is through the content browser. The content browser in itself is a visual representation of the Unreal folder present on our computer. So just to show you better what I mean, if you press on this show or hide the source panel button, it will give you the possibility to access a little bit more, all the folders present within our engine. If we press on content, right click and press on show in Explorer, you can actually see that we are accessing the folder present in our Unreal Engine course folder on our computer. Here we are within content, as you can see on top of here, we are within the content folder, and it's in here that we can add more objects and materials to our game. But usually this is mainly used for exporting and importing stuff. The way you would normally add things to our project is simply by going into the content browser and by clicking with the right click in anywhere in a blank space. Here this little tab will open up, and this tab will actually pretty much give you the possibility to create a bunch of stuff related to Unreal. So you can see animation, artificial intelligence, blendables, and a lot of different things. This is also how we would create our blueprints or how we would create our levels. I give you a quick demonstration of how this works by creating a level, but I will be going through this specific process much more in detail in the BSP geometry session, where we will create our first level in Unreal together. So pressing on level, I'll simply create a test level. And by double clicking on it and saving it, I can access it. The level in itself, everything is black. This is why in our word outliner and in our game, there is nothing, literally nothing that the engine can show us. Even if I drag down a cube, I cannot really see it because there is no light. There is nothing that can actually make me see it. So this is, let's say, the worst way of creating a level per se. If you try to delete this level right now, I will tell you that you're unable to delete it. The way you would actually delete a level is by simply going into, let's go back to our folder, to our level where we were before with these chairs. We will simply right click, press on delete, and delete it. This way we don't have that level anymore. So how you would normally create a level is usually by pressing on file, new level, and it will let us choose from a template that already contains most of the elements, as you can see here in the top right, that are used to create a level. Of course, these are things that we will be going through much more in depth in the future. So let's go back to our level, the level where we created before. So we can also change, having talked about word outliner and detailed panels, content browser, I'll quickly mention the place actor. So as you can actually guess from the name, the place actor gives you an access to a lot of different actors that Unreal has created for us, and we can access these actors and move them within our scene to play around with them. So I'll simply show you this by creating this cube. So I'll hold down my left click mouse button and drag the element within my scene. In this way, I've just created a cube. The way I would then modify this cube is through the detail panel or with the widgets that are present within the cube. So as you saw, I actually moved this cube a little bit up. This was done through accessing the location axes of the cube that are inherent properties of the cube itself. So as you can see from the X, Y, and Z, there are different values that the cube has. I can change these values by either holding down on each one of these axes and, dragging up and down my mouse button, or by simply changing the value in here. So I will put a value, for example, of 10. And in this way, I'm changing its position on the z-axis by setting it up with 10. that represents the units. And in this way, I can move around things within my scene. So I'll show you a little bit more things that you can do with moving things around. So let's take this cube again in example. You can move it up and down by using axes. I want to quickly mention that the place actors, there is nothing else really to the place actors. There is a lot of actors that you can specifically access, but most of these are things that we won't be using in the course. The only thing that we will be actually be using is the geometry section, which let us create BSP brushes that are going to be used for creating levels. But that is a question for another video. For now, once we have created the actor that we wanted to create, this cube, the way we would modify all these different values is by using W, E, or R, which let us get access to his location, rotation, and scale. So as I've shown you before, you can hold down on any of these axes to move the object around, but the same applies for rotation, which I can hold on any of these axes with my mouse and simply drag the mouse left or right, and also for scale. For scale specifically, I can of course change the scale of the actor using these specific axes, but I can also switch things up. So if I want to change the axes, the scale of this actor through two axes, for example, I can actually hold down my left click mouse button while pointing the mouse between these two axes, and in this way I will change it. I will change two axes instead of one, which will give me a little bit more control on the scale of the object that I want to have. So as you can see over here, I can make the object from just changing one direction, I can change multiple. To change all three, you will need to simply aim the mouse towards the white cube present in the center of this widget, and you will simply drag your mouse left or right, and it will change the scale of everything, as it is shown here as well. 3.25, 4.25, and 1.75. Let's put back everything to 1. You can see that sometimes when your things move around, it feels like it is napping, like it is some kind of lagging. In reality, what it is doing is that it is napping it to a grid. The grid is usually really useful if you want to have very predetermined position. So let's say that I'll duplicate another cube, so dragging another cube within the scene. So this cube is going to be snapped to the grid itself that I was mentioning. So if we want to have very precise positions, thanks to the grid, I can actually place another random cube in the scene and then simply move these one close to each other, and they pretty much become a single one to the eye. There is no little fissure, there is nothing. Without a grid, I wouldn't be able to do so. I would always see that the object is a little bit offset. Sometimes it is useful to actually remove the grid from some of these objects. The way I would do so is simply by aiming my mouse on top of here and clicking this little tab, making sure that it is not orange anymore. So in this way, I've changed the moving settings to not snap to the grid anymore, and now I can move this object pretty much freely. So the freedom of movement is usually really nice because it lets you place the object exactly where you want. But again, if you're looking for very precise positions, it's usually very advised to turn your grid back on, so that you wouldn't have issues like this where some objects are slightly up or slightly down than others. You can do the same for the scale and for the rotation. So if you press on here and you change the rotation to not snap to a specific degree anymore, I have free and complete control of the rotation of the object, as well as the scale. If I want to turn back, I simply press back again. And whenever I have any of these enabled, I can also change the settings of their specific grid. So let's say that, let me reset this really quickly. So to reset usually to reset them, you would put them everything to 0. But there is also, sorry, apart from the scale, which is 1, usually a default number. But the other way you could actually do that is if I changed the rotation of something, and I want to reset specifically all the rotation values, I would simply press this little yellow arrow here, which will reset everything to his default values. Within the grid, if I want to have different values applied to the grid, what I would do is I would change the degrees over here to another number. So let's say 5. And this way, every time the cube moves, it snaps to a degree that it's always a multiple of 5, pretty much. As you can see here, 180, 185, 190, and so on. You can also change this value for the scale and for the position as well. So you can see the position at the moment is 10. So it is snapping the object on a grid made by 10 for each unit. So you can see here on the location 192. I'm going to change his x-axis, and 202, which is exactly plus 10. The next one is going to be 212, 222, and so on. If I want to change these values, I can change here to, for example, 50. And now from 182, I will go all the way to 232. And this is how you will pretty much organize things, set specific positions and specific grid positions for your objects. So what I would like you to do now, since everything is much more clear about how to specifically change objects within the scene, I would like you to create some type of scenery within this level that you're currently in. Feel free to play around with the objects that are present within the scene, and I'll actually add a little bit more extras to make sure that you can create something nice. So you can actually duplicate objects within the Unreal Engine as well. The way you will do this is by either pressing Ctrl W, which will duplicate the object, and then you will then have selected the object and you will be able to move it around. Or a nice way to do this when you have to create a scene, it's usually by holding down Alt and pressing on any of these axes and moving them. This will automatically duplicate the object and already give you the possibility to move it. In this way, you can be much more precise instead of simply having to both duplicate and then move the object. It saves time as well. And with these tools in mind, I would like you to create a scene of something that you find interesting or maybe even funny. So right here, I'm just creating something of my own. You can feel free to actually replicate what I'm doing. So I'll simply pick up these chairs. I'll hold Alt. I'll move them around. I'll click hold these two. So to select multiple objects, you will actually press on one, hold down Control, press on another one, and bam, you are selecting more of them, as you can also see here in the world outliner. So you can do this as much as you want. Be careful, if you don't hold Control anymore and you press somewhere else, you will lose all the selected objects. Unreal gives you the possibility to press Ctrl Z to go back to your previous action, and in this way you are actually now able to have the selected object that you've selected before still selected, which sometimes it saves you from a misclick that you have done, and that made you lose the selection of multiple objects. And I will copy these here. And one more thing, if I press on any object and I want to either move on them or just simply move faster, I want to have them in my view, what I would do, I would select an object and then press F, and this will teleport the camera, move very quickly, not teleport, the camera to the object by centering it in the center of the camera itself. It's a nice way, using F is usually a nice way to move around. So imagine I'm really far from an object, I can simply click on that object, press F, and it will transport me very quickly over there. I can also use F to change the rotation of my camera. So let's say that I want to quickly rotate the camera, but rotating it with my mouse and then moving it all the way here would be too much, it would take too much time. What I can simply do, I can click on any object, look on the right, and then press F, and it would literally move my camera so that I can much quickly rotate it around. It's a simple trick. Sometimes it is very useful. When you start to apply these things into practice, you will actually find these little tips very useful. And yeah, let me see what you can actually do. And I'll see you back once you've finished playing around with the scene. So, now that you have a scene done, I would suppose that you want to save your changes. The way you will do so is using this toolbar over here in the top. The toolbar in itself is just a way to access different things that the engine gives you the possibility to access to. There are a lot of these things that we are normally are not going to use, or we are going to be using through different methods. So I will skip some of these, but basically, if you want to save your changes for the current level you're in, you will press on Save Current. The engine will do a little loading bar, and now everything is changed. So if I close the project and I open it up again, this scene will have all the changes you have done completely saved. Let's go quickly over every single element present within the toolbar. Source control is something I won't be talking about in this course, but as a quick way to explain what it is a way to actually save progress online of your content. So if you have a project over here, Unreal. Let me just give me a second. Okay, so we have our project over here, which is Unreal Engine course. Imagine that you have to change computer, or you don't want to have this project currently on your computer. Source control gives you the possibility to save all the files online and give you access to those files and download them again on your computer. And you can actually work in real time on your project without the need to constantly have your project present on your computer. So in case, for example, you want to change computers, you can easily use source control to do so. There is, of course, more than that to it. It is usually used as a way to work in team on a single project. But again, it's a subject in itself. It needs a lot of study to completely understand. So I would advise you to, if you want to look further into source control, I would advise you to either find a course that explains what source control is and how to use it, or simply use YouTube to just have a quick idea of exactly what source control is. Modes is just a way to access different modes within our level that gives you the possibility to, for example, create landscapes, or put foliage within our scene. But we won't be using these modes simply because this course is not specifically for art related tools. What we will be using though is the brush editing mode, which will give us the possibility to change and modify the brushes that we are going to be using for creating our levels. This is within the BSP geometry brush section, so we will be not discussing about this so far. Content and marketplace. Content just gives you, if you close the content browser, content just opens it up again, so it's literally that simple. Marketplace gives you access to the marketplace that you usually would use to buy or acquire different type of assets that then you can use it within your project. Of course, we are not going to be talking about that in this course because everything will be done within the engine itself. If I will be using any assets, I will give you a download link within the video itself. Settings is just a quick way to access different settings within our engine. What we usually really care about is the world settings and the project settings. World settings, it's actually already over here in the defaults. Sorry, close to the detail panel. While project settings is going to be talked about a lot later down the line. For now, you can either access it by going into the settings, project settings, or even going by edit project settings. So it's just a quick way of accessing them. Blueprints and cinematics, we will be covering these later down the line. Mainly blueprints, cinematics, I will briefly mention what they are. Build and launch are not going to be used for now. Build will give us the possibility to build our game, which I will explain what that is later down the line. Launch is similar to build in that regard, so I won't be covering these. It's not important for now. Playing, on the other end, gives you the possibility to actually access the game being played within our scene. So you see here, I'm currently in the level editor where I can click on things, I can move things around, and I can change parameters in the detail panel and so on. And doing this, I can do so because I'm currently in the engine editor mode. But if I want to see how this game actually plays out, how a normal user would actually experience my game, I would actually use the play button to emulate what the user will actually be able to experience. I'll click play, but I'm going to advise you, there are some sounds within this scene, so it's going to be a little bit loud. So I'll press play, I won't talk, I will just move around a little bit and then I'll exit back. So as you briefly saw, I could move around and I could hear sounds, and that it was a representation of what the game would actually be played from a user standpoint. You saw that I could actually move around in the same way I'm doing here right now, but that's because the character that we were controlling in our game was actually a floating camera. We are going to be changing that in the blueprint section to a first-person character, which will be able to move and walk around. So you won't be needing to worry about that too much for now. One thing a very important note, if you press play and then you create any changes within your level, those changes won't be saved. You will not be able to save while you're playing the game. So be mindful of that, because sometimes it actually happens that you press play, you do some changes, and then by exiting back out from play, you will actually lose those changes, which can be pretty disheartening at times. And one thing I actually wanted to quickly mention was the possibility to actually change the movement velocity of our camera. I've showed you before that you can press F to move from object to object. One thing that I did not mention was the possibility to move and change the speed of our camera by using the mouse scroll wheel. So by holding down the right click mouse button and by scrolling up the wheel, where I can change the velocity of the camera to be very fast, as you can see. Or if I hold down the right click mouse button and I scroll down the wheel, the velocity of my camera will get much slower. This will give me the possibility to quickly analyze some objects or move from one place to another with a quick camera. So this is a very brief introduction to the most elements that you have in front of you. Next up, I will cover what exactly we can create within our engine, and I will start to show you a little bit of more tools available for you within the Unreal Engine. So see you in the next section. Okay, so last time we left off, we created a little level setup, I would say. It's not necessarily an actual level within Unreal. We have understood the meaning of each of these tabs present within the engine. And overall, we have also looked at how to move things around the scenery. For today's lesson, I'm actually going to talk to you about specifically how to set up a level so that we can actually use this for our blueprint section. So without further ado, let's go through to create a new level. We'll do so by, first of all, let's just order things a bit. I'll create a new folder. I'll call it maps. And within here, I'll create our new level. So if you remember, I've showed you how to do this before. We are not going to create a level simply from here because that will load us a blank level. Instead, what we are going to be doing is we go in File on the top left, click on New Level, and we use the template, the default template. This will open up a new template for us, a new level. To make sure that this is saved within the project, because right now this thing is just loaded within the engine but is not saved anywhere, we go on Save Current, we go in Maps, and we call this our test level. In here, we can notice some little elements. So here we have the player start, which this is where our player is going to be starting. We remember this from the other level as well. And we also have a bunch more things that we are not really going to be covering up because these are mainly used to achieve the visual effects that we can see around. So first things first, we want to set up this level so that we can start to use our blueprints and we can start our journey in the programming in Unreal. So to do so, we are going to be creating something that is called a game mode. The game mode, basically what it is that it is a blueprint class, which gives us the possibility to access different variables and set up different variables to change the rules within a specific level. So I've created already one over here. I'm just gonna delete this to show you better how to, to show you better how to actually create a new one. So just waiting for this to be deleted. Okay, so right click in an empty space in the content browser, new folder. Let's call this blueprints. We go in blueprint class and we create a game mode base. We call this GM, that stands for game mode, test game mode. I'm going to be calling everything with tests in this course. I'm just gonna save up everything. We'll open it up and we are presented with this little tab that I'm just gonna stick on top of here for ease, which has a viewport similar to the one that we have in the main engine tab, and a bunch of different tabs that I'm going to be covering up more when we start the blueprint section. But for now, what we care about is over here. This lets us decide the different variables that I was talking beforehand. So what we are interested right now in this is the default pawn, which we are going to be changing. For now, I'm just gonna go back to this. To associate a game mode to our specific level, what we are going to be doing is we go in blueprints, we go in project settings, game mode base. We go on select and we choose our game mode that we have just created. In this way, now the game mode we have created is associated with the level present in our scene. The difference between these two, as you can see there are two calls to game mode, is that we can set up a game mode to be associated to every single new level that we create. So right now, by changing the project setting game mode, this means that when I create a new level, the game mode that will be associated to that new level will be the one that we have decided over here, which is GM test game mode. If we want to change the game mode of the current level without changing the game mode that is associated to each level we create, we simply go into blueprints and we go on world override, and here we select the game mode that we want to override with the game mode that present in our current level. So just as a small test, so if right now I have edit GM test game mode as the main one, if I go in world override and I select, for example, the game mode base, which was the one that was selected beforehand before I changed it, now the game mode present in our level will be the game mode base. In this way, it pretty much gives you the possibility to be very flexible with how you want to set up each one of your own levels. I'm now going to be changing the game mode back to this test game mode, simply because this is where we are going to be doing things. And in test game mode, I'm going to be changing the default pawn class to something different that I'm going to be creating right now. So again, into blueprint folder, right click, blueprint class, and we are going to be creating a character. I'm going to be calling this BP, that stands for blueprint, player character. Not gonna use this for this one. And now what will happen is I'm going to be going to test game mode, change the default pawn class to the BP player character, and this will mean that now whenever I press play, the objects, or rather the actor that gets created inside this little capsule that we see over here, is going to be the BP player character, which will look something like this. So if I press play, as you can see, I cannot move, I cannot do anything, because we haven't really touched upon anything yet in terms of creating a character. But what is happening is that it is positioning to this position this character, as you can see over here. If I change back to default pawn, as it was before, and I press play, now from the start, as you can see, I can move around, I can press WASD. It has spawned a default pawn with which I can move around with. So this is kind of like a little bit of an understanding of what game modes give you the possibility to do. We can also create things within the game mode based on some specific events, or just literally just program within here. I won't be going over this right now. This will be covered, of course, in the blueprint section. But keep in mind always that the game mode gives you the possibility to change different rules within your game. So right now we're changing the rule specific to what player class needs to spawn at the start of the game. Okay, now that we have a little bit of a setup of our current scene, so we have a what I would call floor, or a little bit of a level. I'm just gonna expand upon this briefly, just to have a little bit of a more room to work with. So just pressing Alt, just holding Alt and moving with my mouse on the left and on the right to duplicate those objects. Just gonna do this as well. Pressing F. Just gonna show you a little bit of a trick. So whenever you select objects, the Gizmo, which is the widget here, is going to be showing on the last selected object. So if I am in this situation where I want to have the Gizmo over here while moving every single one of these, what I can do is that I can choose this one as the last one, so that now I have it over here, and it's going to be moving all three of them simultaneously. Which is kind of handy whenever you want to select multiple objects. So right now we have this little level selected. I'm going to be going through the character creation. It's not going to entail blueprints yet. I'm just going to introduce you to them. But what we're going to be doing now is going into the BP player character, which I'm going to let you remember that it is the object that gets spawned at the start of the game. And let's give this guy a little bit of things. So here on the top left, we have the add component function. By clicking here, we can add a bunch of components to our actor. Right now, you can see that there is a capsule component, an arrow component, and a mesh component. The capsule component is exactly what you think it is. It is a component which shows this capsule over here. And by clicking on it, we can change all of its parameters here on the right. As of now, we don't really want to change anything yet. Maybe we want to play around with the height. Maybe we want to play around with the capsule radius. But everything else is not going to be interesting for us. What I actually want to do over here is just give this guy a little bit of, let's say, a body. So if we want to hide something within these components that we see here, we just go in add component, we write down static mesh, and press enter. A static mesh will be created. I'm just going to call this body. And as you can see over here, we have a bunch of different parameters for the body. So let's give this guy some physicality. So in static mesh, I'm going to be choosing the cube static mesh, which will literally be represented with this cube. I'm going to be changing its size a little bit, so just shrinking it down like this, making it a little bit more big. And this is a representation of how our character is going to be looking in game. I'll show you this in a second. For now, let's click compile. Let's press save. What compile does, it simply compiles the blueprints and the links that we have done within the event graph. Usually you use it to, not just for this, but also for every single element that we decided to create within the components tab. But basically it's just a way to make sure that the engine makes sure that everything is alright and there are no issues. So for example, if I create something that creates issues, how do I make this have issues? I'll probably show you later how this works. For now, I cannot find a way to just make this break. But just remember that compile is a way to make it so that the engine is sure that everything is working. So we gave this guy a body. I'm going to be changing some parameters over here. In collision, press down on this little arrow thing, and then press on collision presets. Sorry, the arrow was not needed. Press on collision presets and go on block dynamic, the little tab on the right. Go on custom so that we have full control every single one of these presets, and press on ignore for everything. So what am I doing here? Collision is, simply put, the collision of our object. This is actually based on what our object can collide with. This specific schematic is what my object collides with. The collision system is a little bit hard to understand, but basically what you have to keep in mind is that if the collision responses of any of these objects is set to block, then collision will happen and the object that is colliding with the object will block itself from moving. This collision based around an object type. So right now the object type of the cube is world dynamic. So this means that if this object collides with anything that, for example, has an object type of world static, it will ignore it, meaning that it will go through it. This happens for world dynamic as well, pawn as well, physics of body as well, vehicle and destructible. We do this because we do not want this static mesh to be colliding with anything, because we want our colliding to be happening through the capsule component. The capsule component, this means that this current body is going to basically pass through anything, but instead the capsule component is going to block all collision. Therefore, if I just move this guy in here, so you see over here this our player. So this means that whenever this thing will move towards an object, it will stop itself in its track thanks to the capsule collision, but this static mesh won't be giving off any collision at all with this object. This object, if we want to check really quickly what this object type is, we just simply go here on the right in details, and we check collision, and we scroll here, and over here there is the collision preset, which is set to false. To default. If we go in custom, we have the same exact tab that we had in the other one. And in here you can see that his object type is world static. This means that if my object right now, so the static mesh body, will be going to touch a world static, it will simply ignore the collision with it, as you can see over here. So it's usually, if you manage to understand which object type are which, it's usually really understand to also how to make them collide with anything. One important note is that if world static has as collision response block, but our world dynamic object has world static as ignore, it will give priority to ignore. Therefore, this object will ignore the collision with this. If both of them had block, they would have both blocked each other. If any of them have ignore, any of them will ignore the other one. Very simple. So let's remove this guy. If I press play now, you can see that I'm just gonna put this right in front of the player. So if I press play, nothing will happen. I still cannot. Oh, sorry. There needs to be a little bit of a change done towards the game mode. So what happens? I press play. Right now, what the object that has spawned currently is the pawn default, which is not our player character. So to change this, I simply go in game mode. I go into the GM test game mode, and I change the default pawn class to BP player character. Compile, save. Pressing play now will make it so that I cannot move, I cannot walk around. If I press Shift F1 to pop out my mouse button and press eject, I can now check to see within my playing scene that the object that I have spawned is the one that we have set up in BP player character. So, okay, nice. In this way, we have created a player character. We have added some components to it, and we have it made spawn within our scene thanks to our test game mode. One small thing I'm going to be doing is set up a camera for this guy as well. Right now, there is no camera actually present within this object, which means that we cannot change the camera parameters nor its position if we want to. So I'm going to be fixing this by creating the camera. And the camera now, I want to position it. I'll hold down and press it over and hold it. Sorry, and release it over the capture component, so that it now is not a parent of the body. But in reality, what we want to do is actually make it so that the camera is its own parent. Why? How does the parenting works? I'm just fixing the scale here because for some reason it was 0.5. You usually want the camera scale to be 1. So what is this parenting and the hierarchy that is present over here? So hierarchy is something that is actually applied in here as well. And what it means is that it's kind of a way to either organize your objects, but also to much more easily control multiple instances of objects. So imagine that you have a lot of cubes. Okay, I'm just gonna stick with 3, like this. So imagine that we have 3 of these cubes, and I want all of these cubes to be linked together. So let's put the second cube as their parent. What I want to do is that I want to click on this one, hold Control and click on both of them, and then hold down the left click and release it when I am looking at cube 2. In this way, now, these 2 objects are a child of this object that now is called a parent. In this way, if I move the parent, all the child are going to be following the parent, as you can see over here. But if I move a child, is not going to move anyone else but himself. In this way, you can simply link different objects together so that you can simply control the parent and make sure that the child follow. But you can also, in here, make it so that the camera in this way is its own thing. So what do I mean by this? If I made it so that the camera is the child of the body that we created beforehand, this means that every time the body moves, the camera will do so as well. We do not want the body to be moving the camera or to be controlling the position of the camera. Actually, what we want to do is the opposite. We want the body to be moved based on the camera position. When I say body, I actually do mean the head, because if I make it so that the body actually is if I make it so that the position of the body is controlled by the camera, this means that if the camera moves up, so if you look up, the entire body will follow through, and that will be kind of weird. So instead of doing this, we are going to be creating a head for our body. We are going to make sure that the body is not a child of the camera. We are making sure that the body is its own thing. We shrink down the body a little bit so that there is a little bit more of room for the head. And then we move the head up here and we give it a static mesh of, let's say, a sphere actually. Why not? Let's see. Sphere. Okay, I'm going to be changing the scale of this sphere to 1, 1, 1. And then I'm going to shrink it down from the center. So, let's shrink it down slightly more. I'm going to remove the snap to the grid function. And then I'm going to shrink it down like this. Beautiful. So in this way, now we have the head, which is going to be moving based on the camera position as well. And the body, which is not going to be moving at all, actually. Apart from when everything else moves. So because everything here is a child of capsule component, this means that if capsule component moves, everything else will follow. Meaning that in this way, if I want to move the entirety of this character, all I need to do is simply move capsule component and everything else will move alongside with it. I'm just gonna change slightly the position of the camera without the head. So to do so, I simply unplug, or I unparent the head from the camera. I change the position of the camera to where I want it to be. And then I can put the head back here again. I'm actually thinking about this. So if we make it so that the camera moves, if the head is the child of the camera, as you can see, there will be this slightly change in movement that happens, which is not necessarily what we want. So to fix this, I'm actually going to make it so that the camera is going to have the same exact position as the head. In this way, when the head is parented to the camera, if I move the camera, because they both have the same origin position, when I rotate one, it will only rotate the other one rotation without changing its position. So as you can see, we actually have a very realistic movement of the head. Awesome. Now we have a little bit of a character going on, character guy. If we press play, I press shift and F1 again to pop out my mouse. I press eject. So we can see this is our character. Of course, he cannot move yet. I also want to fix this little floating issue that we are going to be doing right now. The guy cannot move yet, but we are going to make it move very soon. I'll stop the play mode for now. I'll go back in BP character. So what's happening here is that it is colliding with the floor before making sure that this guy is showing up. So we are going to push this guy a little bit down and then scale it up a bit. Let's make sure it's slightly aligned so that it's not necessarily too bad of a position. So like this, we align it going a little bit down so that it touches the edge. And awesome, everything seems to be put in a good position. We save everything. We make it so that yeah, the body, everything here, the camera is perfect. We don't need these to be parented to anything else. Now pressing play, shift F1. Oh, sorry. So one thing, if you press play while you're not in the editor tab, it will actually pop up a play scene. But in this scene, you don't really have access to all these different features within this tab. So simply put it, we stop the play mode and we click play from here, which will give us the possibility to Shift F1 and click on eject. There is also a shortcut for eject, which is F8 that we can simply use. But I'm usually more used to just pop out my mouse. But feel free to simply press on F8, possess on unpossess a pawn. We can see our character right now. We can see that it is slightly not touching the ground, but that's fine. We can see his head over here. Now we have covered the concept of parenting. We have covered the concept of creating component, a touching component, as well as creating a blueprint class within our engine. Now the only thing we really need this guy to do is literally look around and move around. I'm going to be covering this in the blueprint section, which is actually going to be happening soon after this section. So I'll salute you for now. I'll leave you with this little level over here. You can actually feel free to populate as you wish. I'm going to be saving everything, and I'll see you in the next video tutorial. Welcome everyone to this new video. So within here, we have the project that we last left off in the last video. And as you can see, if I press play, I can move around, I can look, I can explore around a bit, but there isn't a lot to do. Today we are going to be discussing a little bit how to create more colors within our level, so that there is a little bit of a diversification in colors. And afterwards I'll show you how to change those colors and modify them using blueprints. So let's start off with colors. So usually whenever we have anything within Unreal, so as you can see, anything that we can see, so for example this little chess like structure of the texture of this object, which is called default material, these cubes which are white, so in themselves have that specific color. And even our little player, which has a similar structure as the one that the floor has, because we are using the same, let's call it color for now. So how do you change these things within Unreal? This coloration, these textures that we see, are usually changed through something that it's called materials, as you can see here on the top, in the bottom right. Whenever we press on any object that has any sort of texture, something that we can see of it, usually has a texture and a material, and we can modify it as it kind of is a blueprint in itself. So I'll show you how to do this. Let's create another folder. Let's call this folder materials. Within here we right click and we go into the material basic asset. And we'll call this M that stands for material underscore, let's call it red for now, which arguably represent the color red. If we double click on it, it will open up a new tab. This tab has a very similar architecture to the one that Blueprint class has. We have here on the right a lot of different variables and methods that we can use. On the left, we have the detail panel, which shows everything we click on. And here we have the parameter value as well, which is used, that you can guess, to change parameters. And here we have kind of like similar to the scene tab, something that shows us the final color of our current material. So for now, I'll stick to very simple things. I won't be going over all of this because these are actually more of an artistic focus lecture rather than a technical one. For now, if we want to change the color, all we'll need to know is that the base color is the one we're looking for. If you're interested in knowing about more, you can simply play around with things, or you can actually look around for some courses based on specifically material, because materials, kind of like blueprints, have their own specific things that needs to be learned, and these things are not going to be shown here in this tutorial. We are just going to be using blueprints to change materials. So base color, what I have done here, apologies, is right click, promote to parameter. In this way, I create a new parameter, which is gonna be called base color, And in here, by clicking on it and going into the details panel, I can actually see the different variables I can change. For now, we are going to change the parameter name as red, because it's just simpler. And we are going to be changing the default value here to red, and we amp up this little tab over here to make sure that this value is not going to be 0, therefore black. This is kind of like choosing shades, and this one chooses the color between the color itself and the black color. So we want this to be like this. Let's set this one to 1. The alpha is the transparency of the color itself. So if it's 0, of course, it's going to be transparent and it's not going to be shown. And now by pressing OK and waiting it for it to load, it should appear red within this screen. Just give it a couple of seconds in order for it to compute. I'm just going to save everything as well. Working in Material is usually a little bit slower than working with the blueprints. Anytime you even have to make a small change, like changing the color to red, it's still going to be taking up a bit of time. So as you can see now, we have changed the color to red. Awesome, this is what we wanted. Now, for our next thing, we are going to be going back to test level. Just a second for it to load. Apologies. Okay. I go in here. I right click on the MRed blueprint, and I click on create material instance. I'll just press enter because I'm fine with that name. So what am I doing here? In here there is the color red in itself, which we can arguably just put on any type of color, on any type of object, and it will change their color. But the material instance is used as a way to better organize and change the materials in our game. So let's say that we have different parameters on the red. So let's say that we have the base color, and then we have, let's see, let's give him an emission color that is going to have a little bit of an impact on the color. So if I click save and apply, let me see what happens. It should, like, the emissive color is specifically something that if we change it, it changes the overall glow of our object. So now nothing has changed because I've put this to complete black. Let's try to put it a little bit more up. Let's see if there are any changes. Arguably, I can actually show you what material instances do with the red parameter. If this doesn't work for now, I don't want to go too much into this for now, because it's a very simple. Okay, awesome. It actually changed it. Okay, so I'll press save. I'll press apply just to make sure that all the changes that we have done are saved. And now let's say that I do want to change. So as you can see, first of all, the material red has changed and its instance has changed as well. Now, if we double click on instance, we can see in here there are two parameters, the emissive color and the red color. If we tick both of them, we now have access to their different variables, and we can change them as we please. So if I, for example, say that the emissive color here is 0, meaning that, oh, I've changed the red to blue. It's fine. If I change the red to 0, it actually gives us a little bit of a blue hue on the object. In this way, I can change this parameter in here, and as you can see here, it's actually not super visible. Let me see if I can make it a little bit more understandable. So there are changes, it's just not very visible. I'm just gonna go back to this and just gonna put the alpha to 0. And this way, it should, theoretically speaking, block the transparency. Okay, this is fine as well. The alpha in itself controls the opacity of the object. For now, it's not changing it because of the type of the object, but again, I'm gonna cover this much further down the line when we get to play with these. For now, okay, so we have the material red instance completely purple-ish, but the material is still red. So what's happening here? So the parent red, it's in itself what is controlling the parameters that each one of these child will have. Let's give him the purple as well, just as an example. So as I've explained before with the parent and the child concept, in here there is a similar application. So imagine the red material as the parent of each one of his single instances. This means that whenever any parameter that the red has, each one of his single instances will inherit and will have its own parameters that then it can change. Meaning that if I want to, I can create two instances. Let's create an instance from here. I can create two instances, apply each one of these instances to each one of these guys, and then I'll change the red instance 1 to be something else. Let's do 5, 5, and 5. Let's see what happens. Actually, I like that color. Yeah, nice. This is cool. Okay, so as you can see here, again, all of these are deriving from this. They're changing values that are already present within the parent. But because they're changing it on their own, it's not affecting anybody else of the instances. If I change values within the red material, so this guy, it's actually going to change every single one of these. If I literally just remove from here this, and I press apply, you can try to guess, everything will become red again. Red, but based on their parameters. So again, let me just save everything first. Okay, so if I see the material instance red here, I can only change this parameter here, and I can only change this parameter here. As you can see, they become red again as their parent, but they can still change the parameter that they have, that the parent gave them. So again, if I just go all the way to 0 here and I save, so we have material red instance, which is the one on the right. As you can see here, it becomes blue. Awesome. So in this way, we can have a very much organized and structuralized way of assigning colors to our objects and possibly give them parameters that we can change. This is going to be really useful whenever we are going to be doing changes within blueprints. Okay, so now that we have a little bit of an understanding of what colors are, let's do something cool with our little player. So you remember this guy is a little bit, let's say, colorless. Very dull, very boring. Let's go within blueprints, BP player character, and let's assign him some colors. So to assign colors to anything that, again, can be seen. So static meshes are a type of actor that can, of course, have materials because they are usually used to show a specific type of model, 3D model. If there is a 3D model, of course, there is a texture, and if there is a texture, of course, there is a material that we can assign and change. Therefore, here in materials, let's assign this guy the material red. Let me find it better. Red. Awesome. And let's give him an instance. So let's give him the red instance over here. And for now it's gonna be blue, but we're gonna change it. And let's give the head another different instance. So here we could, theoretically speaking, give the head the same instance, meaning that if I change the material instance that is on the body, it's going to change the head as well. But of course, we want a little bit more of control of our character. Therefore, I'll suggest simply going here and giving him the other instance, which is going to be red instance 1. Awesome. Now, if you press play and we shift F1 and eject, oh, sorry, shift F1 and eject, we can see that our player is a little bit more colorful. Now, let's change that parameter that I've showed you before, the emissive color. So let's go back to the parent, not the instances, the parent. We give him back the emissive color, which again, the emissive color is what gives objects their glow. And we don't mind what this parameter looks like. Again, these are all parameters that the child will change. So by saving everything and applying, okay, we see we have the emissive color over here changing everything about our object. So let's see how it actually looks like in game, just to see if I simply like it. Okay, this looks cool actually. It reminds me of an E of some type of supermarket. Okay, awesome. We can stop the play. So in this way we have colored our player. So we have a little bit of a level going on over here that is still a little bit dull. Let's create another material instance. So just to organize our code better, let's call this M and let's call it player materials. In this way, any other instances of this player materials is going to be something that it's related to the player. It's just a way to divide it conceptually for us so that we can easily navigate each one of our materials. So in this way, the M player materials is going to be each one of the player's materials, and each one of their instances is going to represent something. So we know that the blue is the body, so I'm just gonna call this M underscore player materials because it derives from that underscore body. I'm gonna do the same for the red instance. Just pressing on the blueprint actor, I'm gonna click F2 so that I can rename it, and then I can simply I've copied with Ctrl C here, and I'll Ctrl V here, and I'll call this one head. Awesome. So in this way we have a little bit of more organized structure to our materials. I'm gonna do something a little bit even more organized. I'll create a folder and I'll call it player materials. I'll select each one of these with Ctrl and left click, and I'll drag all of them here and press move here. So in this way we know that every single material in here is going to be a material that is going to be used and applied for the player. Let's create another folder and let's call this level material. In here I'm going to double click, right click, and then I'm going to be creating a material parent. I'm going to be calling this level materials, of course. We are just going to be assigning to this a base color, right click, promote to parameter. We are not going to be changing this because, as you saw, we don't mind what values these are. We mind what the child values are. We just want to make sure that we can access these values. I'm going to give it a base color and possibly an emissive color as well. Is there anything else that we may need? I don't think so. Anything else over here is just some of these are very simple to explain. So for example, opacity, as you can actually guess, it's how opaque our object is. But stuff like normal or metallic or specular are used much more for textures. So they usually represent the bumps. So if you imagine an object, if for example the texture of a mountain, you know how mountains usually have bumps. So what 3D modelers usually do, instead of literally just modeling those bumps in, making the model overall more hefty, they instead make the plane completely plain. Sorry for the joke on words. And instead of trying to create any bumps themselves, they usually use a texture that fakes and simulate those bumps. Those bumps usually are represented within the normals of the object, and in themselves are also used as a way to fake lighting. But again, these are concepts that should be taught you by an actual artist. I just have a gist of what all of these are myself. Because I'm not an artist. So, okay, awesome. We save everything. As soon as it's saved, we go back to test level. And in here, we create some instances. Let's call this... So imagine that we have trees, for example. We want all our trees to have the same materials, because of course we want the trees to be the same color. So right click, create material instance, and we call this M underscore level materials underscore tree. We now go in here and we'll create a very, very simple tree. I'm just gonna do everything within the editor. So here I'm just gonna create a folder. I'm just gonna call this folder trees. I'm gonna cover this things much better down the line, because what we actually will be doing is in the BSP section, we're actually going to be creating things like these that we can actually completely manipulate the geometry of. For now, I'm just gonna stick with something very simple, because I'm just gonna showcase materials in the section, so I don't want to go too far. So let's create something extremely amazing and beautiful. I've just noticed I don't have snapping enabled. I'm just gonna redo this really quickly so they snap well together. Okay, awesome. Another one. Perfect. And let's give him some what we would call leaves or branches, maybe. Okay, there we go. Awesome. So now we have a beautiful tree. So how are we going to assign these materials to it in an organized fashion? Because again, this is the tree materials, and if we apply it to them, imagine this is the color of the tree. It's only one color, so as you can see here, the trunk is going to be the same exact color of the branches and leaves, and that's not really what we want. So we can create instances of our instance. In this way, I'm gonna right click, create a material instance. Let's say that this is the normal material tree. Then from the tree, we are going to derive the trunk, and the leaves. So let's first of all, let's do some changes over here, because everything is black and it's really hard to organize in this. So let's go on base color, and let's actually click on here. So we have the color picker. We don't need to input any weird values to try and get the color we want. Let's try to find a little bit of a brownish texture, which is arguably very hard to find in here. Let's go for something weird. I'm just gonna go like this, orange, why not? Okay, I'll save. This is the this is the leaves. No. Okay, so an interesting thing we can do here is we can copy the hex linear, sorry, the X RGB. These are the values that the engine uses to assign colors to our materials. So imagine that we pick up the value within here, within this little circle sphere-ish thing, and the engine converts these colors into numbers that then it can feed into the engine so that we can show us off this beautiful color. So as you can see here, I've done the mistake of changing the color orange, which is supposed to be the color of the trunk, into the leaves material. So to change this, I'm just going to be doing a copy of the RGB hex here. I'm going to be going into the tree trunk material instance. I'm going to tick the base color, and I'm going to click on the color picker, and I'm going to be changing these values to the one I've copied from the other one. I'll press OK, and bam, the same exact color as appeared here. This way we can simply, save our changes and, save our little mistakes from happening without wasting too much time. So the tree trunk, I like this color. For the leaves, you're just going to be going for a really cool green. So I like this green. I'm just gonna press OK. I'm gonna save both of these. I'm going to save materials. I'm going to save everything actually. Let him just do his thing really quickly. Awesome. I'm just gonna press on save all. Awesome. So I'm just gonna assign, again, this is the main parent. I'm gonna assign 3 leaves to this, this, and arguably this. And for to be honest, it's actually really cool with black. This one is fine as well. I'm gonna assign the tree trunk to these 2 little cubes. And now we have this little tree over here, which we can move around. To move this around with much more ease, what we can do is create something. So I'm just gonna create an empty sort of actor. This is called target. You usually use this just to create an instance of an actor within our scene that can give us what transformation, rotation, and scale parameters. But what we are going to be using this for is, as I'll show you now, we're going to be using this as the parent of our little cubes. So I'll select each one of these and I'll try to move them over to target point, but it is giving me an error. It says cannot attach multiple objects to target point. Why is this happening? It's very simple. Right now, our static mesh is set to static. Static means that this object is not supposed to be moving when it is within our game. So whenever we press play, the game kind of knows that this object should not move ever. So because we are setting it to static, the engine can do things with it that normally it couldn't do with mobile or stationary objects. One thing, for example, so if you recall, I talked about lighting and how lighting was faked within our textures. One thing the engine actually does to save up on performance is actually make it so that if an object is static, it actually bakes, it's the term used for faking lighting on an object, it bakes the lighting of said object on any static object. Why? Because we know this object will never move. We know that every single time we look at this object, it will look like, the light will look like this. Therefore, the engine just builds it in for ourselves whenever we press this on static. So why am I telling you all of this? This object instead is a movable object. So this is supposed to move within our engine and within our scene. But if we try to parent an object that should not move to an object that generally should move, again, the engine doesn't let you do that. If I change this to static, of course, the problem is not going to be there anymore. I can simply just parent everything. And as you can see, I can move them around while I'm in the engine. Again, only when I'm playing, this object will not be able to move. And awesome, but I really want this object to be able to move because, again, if we want to do some little funny things with it, we are not capable of doing so if the tree cannot move. Therefore, I'm just gonna press this on movable, and as you can see, there is no errors, and you will be like, why has this happened? Because it's actually an error. It should change everything here because. Let me see, actually, if I press play, there are no errors, but this one is movable and this one are not. Interesting, so the engine should change every single one of these to movable. It did not. Be careful of this. It could cause you some trouble if you are doing something more serious in the future. Let's change this all to movable. Let's save. And let's change, so as you can see the pivot here, we're changing it from here to move everything else. Let's put it over here. So I'm just gonna deparent every single one of these. I'm gonna pick up my target point. I'm gonna move it all the way over here. I'm gonna move it up. I'm just gonna do a little trick actually. I'm gonna parent the target point, this cube. So it was cube 6. Why is it changing? This is a little bit of a weird issue. So I can parent this to this, but I cannot parent this to this. Oh, I can. Okay, so the engine is actually acting a little bit weird now. Let's just ignore the issues he's having. So, again, I'm going to be parenting the target point to cube 6. No, it doesn't let me do that. It's fine. I'll just move it myself. Engines sometimes do be acting weird, so let's just try to deal with their things. Okay, so this looks like a good position. I'm just gonna select every single one of these. Shift. I'm going holding Shift clicking the last one, and it selects every single one of them after before him. and I'm just gonna drag them over here. Now I have control of my little tree over here, using the target point that I have created. And this way I can with much more ease control the position of this tree and move it around where I please. Awesome. Now let's do something a little bit more fun. I'm just gonna move this tree all over a little bit over here. So let's first of all create a bunch of these little different trees over here. So I'm just gonna do this and this to give a little bit more to create a little bit of a more lovely scene. As you can see, stuff is more colorful and kind of nice now. So let's do something a little bit more fun. Let's try to change colors of the things around us by using the player. So the idea here is that we want to shoot each one of these trees and we want to change their colors to something different so that we can color them differently as we please. Okay, so to do so, we are going to go within our BP player character and we are going to create an event that basically, so let's try to analyze the logic here. I want something where every time I aim towards a specific object and I press left click, I want that color of the thing that I'm looking at to change. So that can be anything and anything in the level. To do so, we want, first of all, an event that gets called every time I press my left click mouse button. So let's create that first. I go into project settings, I go into inputs, and then I press on action mappings. So the difference between action mapping and axis mapping, which is the one we used last time, is that axis mapping actually uses a scale, as you can see over here, that specifically refers to the possible scale of the input we are giving to the engine. So with the mouse, you cannot simply have an action of mouse movement. Instead, the way the engine set this up is that you have a variable that becomes positive or negative based on where you're moving your mouse, which is much more simpler and a reliable way of doing it. Instead, whenever we want to have a specific action, for in this case a left click, we are going to be using action mapping. So let's press on the plus button, let's go here and let's call this shoot. Let's find here the left mouse button. So every time I press the left mouse button, it will call an action. It will give us the possibility to create logic within that action. So let's right click in the BP player character blueprint tab and let's find the shoot event function, the one that we have just created. Here we have pin for pressed, pin for the released, and the key variable. So the pressed and released, as you can guess, are if I am pressing the left click, this will be called. If I release the left click, this one will be called instead. The key is simply to say which one are currently calling this. So as of now, we only have the left mouse button, but we could add more of these. And each one, anytime that specific key gets pressed, shoot will happen. So we can have shoot happening not simply from the left click mouse button, but also from, for example, the control key on the keyboard, which is a way to just make stuff more, flexible if we need it to be. For now, we don't need it. We just want the left click mouse button. So input action shoot again. Let's remember what we wanted to do. We wanted to aim towards something. We press left click mouse button and that something changes color. So we have the action. We now need the thing that searches for what we are looking at. To use such a method, Unreal has actually created something that is called a line trace. A line trace, or in other engines, or actually usually in programming called ray tracing, is a let me just find it super quickly. Line trace by channel. Okay, awesome. So this pretty much what it does is that it spawns a line from the starting position to the ending position that gives us any sort of object that gets hit by the specific line that has spawned. This line is usually invisible. It's not something the user will see. It's something that we can set ourselves to be seen using the debug type. And in general, this is one of the best ways and most efficient ways of gathering info about our surrounding objects within our level in programming. So I'm just gonna link the pressed pin to our line trace. This means that every time I press the left click mouse button, this method will be called. This is the outputs. These are the outputs. One of these tells you if it has hit anything. This one is a boolean. A boolean is a variable that is usually only true or false. So if this variable is true, that means it has hit something. If it is not true, then that means it did not hit anything. The houthit is simply a variable that tells us, that gives us a bunch of different parameters based on the object that we have hit. To see this one better, we can actually pull it out here and press and write break and click on break hit result. We put this very close to here and then we just press the arrow, and these are all the possible variables that we can gather from the object that we have hit. These are going to be very useful if we want to change things about that object that we have hit. So now, let's create the start and end vectors in order to cast this line. So we want the line to be cast from the camera because that's the thing that moves around, and that's the thing that we want to use in order to gather information around the world. So what I do here, I drag in here camera, which gives me access to any sort of variable related to camera itself. I drag out the pin, and then I write something called get world position. Location, it's the same thing. Get world location, what it does, it's simply a function, a method that similar to these, that literally only gathers the vector of the camera, the position of the camera within our world. So if I have to symbolize this in visually, you see the arrow, the white dot in the center, that's the vector position. And the vector position is represented in here by the X, the Y, and the Z. So what we are doing here right now, we are accessing the camera position at this current frame. And we are going to be feeding this all to the way to start, because we want the line trace to be starting from the camera. After having done this, we want to have the end vector instead to be different from the start, of course, and we want it to be based around the camera position and rotation. So if we imagine this end line as another point here in the... I'll actually show you. I'm creating a scene. A scene is simply an empty component. It doesn't have anything apart from a transform and some other little variables we can change. So if we imagine this to be the ending position and this to be the starting position, try to imagine literally drawing a line between these two. We want this line to change based on the camera. Can I click on the camera? Oh yes, nice. Based on the camera rotation. So as you can see here, because the scene is a child of the camera, we can see it changing based on the camera rotation. So just to show you this off to you. As you can see here, it changes based on the camera rotation. So we want to achieve this exact effect, but within blueprints. To do so, we can use the forward vector of the camera, which is this one, and simply adding this to our starting position, plus multiplied by a scale factor that simply makes this vector bigger, which is going to be actually the range at which we can see things further from us. So let's put this to the test. In the camera, we pick up the get forward vector. This is not needed. We pick up the get forward vector, so we are picking up the vector that comes from forward of the camera. This one will pick up on the rotation as well. and we multiply this by a set amount. Let's use a int in this way, and let's press the right click and promote to variable. So what I'm doing here, I'm creating actually our first variable, which is an integer. An integer is simply a full number. It doesn't have any comma. It's simply an integer value. So 1, 2, 3, 4, 5. A float instead would be a number that actually can have a comma. So 1.2 would be a float, and 1 would be an integer. You can have 1 as a float if we want to do so, but that's beside the point. Okay, so we are multiplying this by this. We are going to be calling the integer, let's call it range, because that's kind of what it represents. And we'll then add the starting position to the vector that we have just created. So simply pressing plus and doing a vector plus vector. I'm just gonna pin this all the way here. If you hold Alt and you press on any pins, it just unplugs them. It's a very handy way of doing things. We then add these two vectors together. So again, we are adding the get forward vector with the get world location of the camera, meaning that the result of this is going to be a vector that is going to represent the ending position of our line trace. So again, the scene, this little thing is what is going to be happening behind the scene. So we are going to create this position. Let me delete it. Okay. And we'll connect this to end. Now, how do we know that we have done everything good? Well, it's very simple. Over here, we have different options that the line trace gives us the possibility to access. I'll just click on the line over here. And so we have visibility, which is something we don't really mind. Visibility is usually the default. We'll just stick with it for now. Trace complex, again, we don't really mind this. This is mainly to, I mean, as you can actually read as well. True to test against complex collision, false to test against simplified collision. The complex collision is something related to objects. This box over here has a simple collision because the collision it is using is the default one of a cube. But if something has a much more complex collision, so let's pick up this tree, for example. Right now, this tree, everything here is simple collision because it is created of objects that are of a simpler collision. But if we are creating one collision for this entire object, then you'll see that the collision will actually change to a shape that does not represent a cube anymore. And because it does not represent a cube anymore, it won't be a simple collision anymore. And this false, this boolean actually tells us if we want to ignore more complex objects or not. We don't mind this too much for now. So I'm just gonna leave it at false. But of course, later down the line, when we will have more complex objects in the scene, I'll show you how this can be used. So false. Actors to ignore. This one we'll skip for now, but basically it's just a way to tell him to ignore, so that the line, when passing through things, it will just ignore some actors, literally. The draw debug type, it's what we are actually looking for. Here I'm going to click on for duration. So the way this works is pretty much we have these three options for one frame, for duration, and persistent. For one frame, it literally means that the line that we are going to be creating to visually is going to last only for the duration which is shown over here. For one frame means that it will only last for one frame, and persistent means it will last forever. So I'm just gonna stick with for duration for now, just to show you off. Ignore self, always yes. This usually means that it's just ignoring itself. It's not counting itself as a hit, which you usually don't want that to happen. This is the color. Let's leave them at this for now. I'll press save. I'll press play. And now, every time I press left click, something should happen. Nothing is happening, which is weird. Let's go check what's the issue. So if we don't know if this event is happening, we're simply going to use a print string to make sure that this event is happening. I'm just gonna unplug everything else. Compile, save. So the idea here is that maybe what's not working is the line trace itself. I'm going to use a print string, meaning that if I press left click and it says hello, that means the input action is working, so the problem should be in here. So, okay, seems that this one is working. Whoops, I just pressed a button, don't mind that too much. I just pressed F1, so if this happens to you as well, F1 just shows you the collision of each object, the vertices and their specific meshes. If you press F2, F3, F4, they change in different things. What you want to have is F3, which is the usual one we are always using, the one that we currently use. If you do a mistake like that, don't panic, just press F3 and you're good to go. Or you can simply close and open up the play again. So I press F1. Oh no, I don't know what's happening. I press ESC, I press play, and everything is back to normal. Okay, so the problem is not in input action, so the problem must be within the line trace itself. Let's see what we did wrong. So we know this one is working. Let's try to put the duration to persistent. And let's put the trace to... No, these are fine. These are not going to cause issues. Okay, let's see what's the issue here. Okay, it's not showing anywhere. There could be some reasons for this to happen. Let's check a little bit the positions that we are giving him. Actually. So I'm gonna do something to test this out a little bit. I'm going to use another method. I'm going to spawn actor from class. Okay, so I'm going to be spawning an actor on the position that is shown at the end and at the start. So in this way, what of our line trace. So in this way, what I'm doing is I'll spawn a random object at the start position of the camera so that I can see where the starting position is happening and if there are any errors. If the object spawns right where we are, then everything on the start side is working as it's intended. If it's not, then there is something wrong and we need to fix it. So as of now, I am going to give him a class. So let's choose something random. Let's see, maybe I can create myself something random. I'll go in blueprints, I'll go in blueprint class, I'll go in actor, I'll create something random just to test this out. I'll give him a static mesh. And I'll change his static mesh to a cube. Okay, awesome. In this way, whenever I press the left click, it should do a line trace, and then I should spawn an actor to the position that I'm going to be giving him. So you see here, it is asking for a spawn transform. Usually, spawn transform is, as you can see over here, is the unification of location, rotation, and scale. Of course, we can simply go in here, and we can right click, press on split struct pin, and now we can see each one of these that it is going to spawn us. So the rotation we don't care, as well as the scale we don't care. We only care about the position because that's the one we are using here. So if I just copy these and pull them over here, and I'll plug them in here, I'll compile, I'll save. It is giving me error. Oh, I forgot to choose the class. Something random. Awesome. So if I now press play, and here you go, you can actually see within the game, I clicked left click, and it exactly spawned a cube right where my head is. So if I click on the cube, the widget is exactly in my head, which awesome. That means everything is working correctly over there. Let me see the ending position instead. So let's spawn. Oh, wait. I'll keep doing this and then I have just realized what's the issue. You probably have realized as well because I actually showed it. But let's keep doing with this because it's really good to just debug stuff and know how to debug stuff. So within our code. So I'm going to be copying the entirety of this other operation that we are doing. So the output is this one. I am going to pick this up, put it in the spawn transform, press compile, press save. Now I'm pressing play. If I press left click, oh, would you look at it? The thing, oh, no, sorry. I press play. So the object has spawned exactly where our head is, which is weird. We did not want it to spawn here. We wanted it to spawn something a little bit further from us. So something like here. This is happening because we are actually not giving him a range. Meaning that this range right now equals to 0. And because as it's a multiplication, it is completely nullifying this forward vector. Meaning that the only thing that this addition is going to give to the end position is the starting position. Meaning that doing this with this value of 0, it's the same exact thing and simply doing this. So giving the end the same exact location as the start. So how do we fix this? Very simple. We have the range over here already. We simply just need to change its value. So let's give him a value of 1000 as an example. We can now, I'm just gonna unplug this. So in case there are any other errors, we can actually use this still, because I haven't deleted it. So right now, everything should work fine. I press play. I press left click, and here you can see the line is very thin, but we can see that it is casting from our head all the way to the center of our camera, and it is eating the first thing he sees. The color green that we see here is the line that tells us, hey, look, I have hit something. So, as you can see, it is telling us that it is hitting this cube. If I do it over here, same things applies. And if I do it over here, same thing applies. Awesome. So the line trace is working. I can now delete this because I don't need it anymore. I have debugged my code and I have successfully found the error. And now we have the shooting. We have the line trace. Now what we want to do is we want to change the material of the object that we hit. So to access the object that we have hit, we can simply use this variable over here. That is the hit actor. The hit actor is a reference to the actor that we have hit through the line channel. So before we do this, let's actually create a branch. Let's make sure that we have hit something first. So I'm going to be holding down B and pressing left click. This creates a branches. This is a quick way of doing it. The way normally you do it is you go in here, you just write down branch. But a quicker way of doing it is simply holding down B and pressing left click mouse button. So what is a branch? A branch is something extremely simple yet extremely powerful. The branch is an if statement which asks you a condition with which if this condition is true, it splits up into true or false. So if the condition we give him is true, the code is going to go in this way and it is going to ignore anything else that it's here. If it's false, of course, it's going to ignore everything within the true pins and just execute the one in the false pins. So the condition we're giving him is asking him if we have hit anything. So if we have hit anything, then do the true. If we have not hit anything, then do the false. Of course, we can just keep these completely blank, like we don't need to plug anything here. If it's false and then there's nothing plugged here, the code would just stop and we'll cycle back to the next frame without any issues. Okay, so now we know possibly if we hit something, we need to access the actor that we have hit and we need to change its material. So in the case we hit something, we are going to use a method called setMaterial, which is a method that, as you can guess, sets the material of something. and we are going to give him as the target the hit actor. So the problem here is that it's asking for a component. We don't want a component, we want an actor. So there are different methods for each object. There is a method for actor, there are methods for actors, there are methods for components. Sometimes, to understand why stuff is not linking well together, the only thing you need to do is literally hover down with your mouse over here and check what it is asking us to do. So right now, we see that it wants a component, not an actor. And if we don't fully understand what the component is, we can simply promote this to a variable. And here you can see the thing it is asking us. It's literally something similar to our head, our body, or our camera, which are components of an actor, not the actor itself. To fix this, let's first of all delete the variable that we have just created. Let's delete this method and let's drag all the way from hit actor and let's write down set material. If we don't find it, we remove the context sensitive and we check for the set material in here. And there it is. Again, it is giving us issues. So I suppose there is not a method for changing the material of a specific actor. There is only a method to change the material of specific components, which is just a case of not having that said method. But sometimes some methods are different based on if they are trying to go for actors or if they're trying to go for components. We don't mind too much the fact that it is asking us for a component. We'll just give him the component because we don't really mind. Again, when I press on the cube, the only component of the cube, as you can guess, it's the static mesh component. So whenever I shoot and I hit the static mesh component, I am accessing his material and I'm changing the material. And because it's only one thing I am hitting, that is perfect because it won't give us any issues. So this method will do just fine for us. Okay, so we are linking this, giving him the target of what he needs to change the material of as our component that we have hit with our line trace. We give him the element index is simply, so if you have different materials for one single component, all you need to do to access each one of these materials singularly is give the method set material the index element shown in here. So you see this is the element 0, therefore we are feeding him the element index 0. If there were more materials or elements rather, we would give him the specific number of that material. And then we select the material that we want to change the material of, that we want to swap it with. So the material is going to be, this means that every time we hit something, we are going to change the material of that something to the material that we are going to be deciding and choosing in here. Let me see. So let's create a material. Let's just give him for now, for testing, the M level materials 3 leaves. So I'm just gonna F2, copy the name, go into the BP player character. I'm just gonna close these guys out because they are annoying me a little bit. Bring down the tab over here, and I'm just gonna search for the M level materials 3 leaves. Compile, save. Now, let's recap really quickly, and then let's see if it works. So we are casting a line coming from the camera all the way to the end of our vector that we have decided through this operation over here. We are creating this line, and anything this line hits is going to change the material of that thing. Specifically, if it hits something, it's going to change something. If it doesn't hit anything, it's not going to change anything. Okay, awesome. Now I'm going to be going to the test level. I'm gonna press play. I'm gonna aim my camera towards this object. I'm gonna press the left click, and here you go. It is changing its material. to the one that of the leaves. So I can now go around and literally just color the entire area. These are already leaves, so it's not doing anything. And as you can see, everything is working as intended. If we are too far away, yeah, I can use the floor actually. If you are too far away, it won't work because we have set up his range to be 1000 units. So eventually, as soon as I manage to get into range and I press the left click mouse button, there you go, it's changing its color as well. We can change the color of pretty much anything with this. Apart for this for some reasons, which it's weird. But yeah, awesome. And this way, we can color up the entire zone of green because we managed to set up these little code things within our project. So, what are we going to be doing next? In the next video, I'll show you how to... we are actually going to be creating a little bit more gameplay. Right now we can color things, that's for sure. But still, there isn't really a game here. We can just color stuff and nothing really happens apart from this. So in the next video, I'm going to do something a little bit more fun. I'm going to be doing something where you can pick up the color of something that you hit with, for example, the right click of the mouse button. And then you can put that color on somewhere else. And in this way, if you, for example, make it so that the color of this tree is the same color of this tree, a door will open and you can continue. And in this way, we'll have a little bit of gameplay and a little bit of goals for the player to try and achieve. And I'll also show you how to create a little level using the BSP geometry tools that Unreal give us the access to. And in this way, we'll start to create our very first video game in Unreal. So thank you for tuning in, and I'll see you in the next video. Okay, welcome everyone to our new video. So just as a small recap, in this video, what we are going to be doing is we are going to create a little bit of gameplay. To do this, we are going to be changing some elements that we have in our current scene so that they are more accessible blueprint-wise. And overall, we're just aiming to have a little bit of a gameplay loop set up so that our game actually feels like it can be played from a start to an end. Let's first analyze what we have so far in front of us. If I press play, I can click on things. Because I've set up the material color of what I want to color with the material of the leaves, every time I click on something that is not leaves, they are going to be changing their color to the leaves color. And in this way, I can color the scene of any color I want. But in this way, there isn't really a specific goal for the player apart from coloring everything to green. What we want to change here in this level is the possibility to not simply color everything green, but also pick up the color of specific objects, as well as the possibility to, for example, open a door once the condition for said door to open are met. So, for example, coloring both of these trees of their specific color. We also do want to change a little bit of the structure of things. So I'll show you here. We have these trees right now that are set up within the scene as cubes that they don't really represent a tree from the Unreal perspective. These are just a lot of cubes put together. What we want to do now is, first of all, change these trees into an actor, then that we can access through our player and change the colors of his components. So let's start from this. To create an actor in Unreal, we go within, first of all, the folder blueprint, because this is where we usually put our things. I right click, I go into blueprint class, I press on actor, and I call this BP underscore tree. I'll double click on it, and in here we see in the add component tab, here is where I will be adding the tree physicality. So to make sure that everything is more understandable, you see here right now the trunk is composed of two cubes we don't really want that. We want the trunk to be conceptually only one cube. So we are going to be doing this. So I'll control click on every single one of these cubes. I'll control C and I'll control V all of them in here. So in this way, it should appear within here. Sometimes it's bugged, so if it's not appearing, do not worry. We are going to be doing this manually. As you can see, it's not appearing because the static mesh of every single one of these is not there. So if I just simply write down cube and I press here, let's see, okay, so the material is not presenting to us. So with this method, we simply cannot create the tree that we have in the scene. So let's just delete everything and let's start from the scratch. Let's create a static mesh component. Let's call this trunk. So we are dividing the tree in different pieces. So we have the trunk, and the leaves. We usually want the trunk to be the parent of the leaves, so that if the trunk moves, the leaves moves as well. It's not really too much of a difference if leaves or trunk is the parent of each other. We just simply want to have a specific order in which they exist. So for now, we'll say trunk is the parent. I'll give to the trunk the cube static mesh. And I'll give him the trunk material, which I do not recall the name. I suppose I called it trunk. Nice. And now we do the same for the leaves. So we do cube material. Sorry, static mesh. Let's use this. I'll put this up a little bit more, and then I'll change this to leaves. Okay, awesome. So of course, as you can see, we don't really have the tree that we wanted to have. So to quickly solve this, we are going to just size this up, and let's move this up a bit. So we know that this is formed by two cubes. So to simply change that, we will amp up the Z scale of this object. Let's first unparent the leaves, otherwise the leaves will get the modification as well, and we don't want that for now. So the Z is going to be 2, which represents the tree trunk with 2 units instead of 1. A quick way of moving it is simply by moving with the its axis, sorry. And now we are going to, we want the leaves to be their own thing. So to do this, we are going to be moving the leaves like this. So 3 over here. And okay, so for now, let's make it so that the leaves are going to be created as separate objects. We will change this soon enough. For now, let's just make it so that there is one object. Sorry, 2 objects that represent the leaves. Oh, made the rotation of this. Yep, it's not specifically 90. Okay, awesome. So in this way, we kind of recreated pretty much the tree we have in the scene. I'll put this here and I'll show you pretty much we have the same exact object. But the difference between these two trees is that this one derives from a BP actor. In this way, it's much more easier to modify such a class within our blueprints, while this is simply something we have created out of different cubes that doesn't really have any specific links to blueprints. It's not really an actor. Each one of these is in itself an actor because they derive from the actor class in themselves, but they are not a one single actor, which is something we actually want, so that there is a much more it's much more feasible from the blueprint side. So there is something really cool in Unreal, which I do not know if it works with multiple objects. Well, we'll check that out right now. So if I select each one of these and I'll right click on them and I'll click on replace selected actor with BP3. So yeah, as I expected. So if you have an actor in your scene, I'm just gonna delete that. and you want to replace, let's say that you have created this cube just as a testing. As you can see, if I just select this one single cube and I right click and replace actor and use selection, it will replace the actor I was selecting with the actor I have just created, which makes iterating on levels very fast. I can simply place cubes around. So the way we would have done this normally is I would have placed cubes all over the place, and I will say that those cubes would have represented those trees. So I'll just put them like randomly over here. I'll just put this one a little bit over here just for visuals purposes, so it's better to be seen. So I would have placed, instead of these huge things, I would have instead placed a single cube. I would have told myself, all right, cool, this is going to be the tree thing that I'm going to be, this is where the trees are going to be going. And then they would already work with the script. I'll go to them, I'll left click and they would color, and I'm like, okay, cool, you can change things. And then once I create the actual actor, maybe with the scripts and everything we need in it, I simply right click, replace actor, BP3, and bam. Of course, the actor is going to follow the same exact sides, rotation and location parameters of the actor we are replacing it with. Meaning that if I had a scale of 6, the actor that I'm going to be replacing it with is going to have the scale of 6 as well. To simply overcome this, we just put 1 back again. We scale it down a little bit further down, so it's actually on the floor, and there you go. But yeah, so I'm just gonna very quickly replace all of these trees with the blueprint ones. So I'm just gonna do this and this. And now let's see how the script works. If I click on the trunk, you can see it colors the entire trunk. But we don't know if the clicking of the trunk actually affects the leaves as well. To test this out really quickly, I'm just gonna change the color of the leaves to something different. So I'm just gonna click something completely random. So let's just use the texture of the lamps that were in the first level that we did a lot of time ago. Okay, cool. And now, as you can see, the changes I've done to one tree are brought to all the trees, because this is how Actor works. They are some type of prefab that literally lets you change one of them and all of them change, which is awesome, exactly what we want. It makes it much more feasible to do changes in our level without issues. So again, I pressed on the trunk and the only thing that is changing is the trunk. So awesome, we know that the script is working as it's intended to be working, because what could have happened was that instead of simply changing the tree trunk, it would have changed the leaves as well. Because it is accessing the entire actor and it could have changed every single part of the actor. Of course, that's not really possible, and we would have already known this, because by going into the BPL character, we can see within the align trace that the component we are hitting and we are changing the material of is the hit component, not the hit actor. So that means that the component that gets hit, and remember, these are all components of this actor, are going to be changing their material to this. Okay. Now that we have a little bit of a setup much better done, we can now start with the idea of changing, picking up color and then assigning that color to something else. So let's have a little bit of a think on exactly how this mechanic will work. Because if I have a scene with different trees around, and let's say I pick up the green from here, and I place it here on the brown, and then I'll go all over the place, placing it on all the browns. If the door asked you to have a tree that is colored of brown and green, the brown would not be present anymore in the scene. Therefore, it wouldn't be possible to complete the level. Of course, we can overcome this type of design issue by simply making a button that resets the level so that we can try again. But let's try to think of a solution that doesn't require the complete reset of the level. This is what I've come up with in terms of design. You can feel free to change it based on your own personal design ideas, but this is what I'm going to be following. So I was imagining that it would be really interesting if anything around would be white, and there would be only two colors, completely random. Maybe let's say that there is a random cube over here. Just gonna do something a little bit scuffed in terms of the showing of this cube, but let's stick with it for now. We are going to be polishing everything up later down the line. So let's say there is a complete random cube over here. Everything here is white. And what's going to happen is that the only thing that is going to have color in here is going to be this cube. So I'll pick up the color from the cube. The cube still retains its color, or maybe we let it remove. So I'm just thinking about design here. We are working with resources at the moment. We want to make sure that the resources that are present within the level do not get down to 0, let's say, so that it is not possible to gather those resources again. The resources in question are the colors. So again, there is one color in the scene. The cube has it. If I pick up this color, so let's say that I pick it up and now the cube is completely white, I can then go another object and put that color over there, and now the resource has moved and is not being replaced in any sort of way. So we are resolving the issue of completely going out of a color, because we are not replacing the resource with something else. We are simply moving it from one place to another. And by moving it in specific places that are right for their resources to be, we are going to be unlocking things. So in this case, we are just going to open a door. So let's make it so that everything is white. I am going to be creating a white color within materials, and these are going to be within level materials. So again, we are going to right click material. I'm going to call this m underscore level materials underscore white. So you usually do not want to have materials that are named red, yellow, white, because most of the time you can simply change these parameters within the material instances of a specific object, meaning that you're just going to have a very cluttered folder with all these different colors within it, and it's not really going to be working towards having an organized structure. For now though, the reason we are doing this material white is because this material white is a very fundamental part of the core concept of the design of this game, because the white resembles the absence of color. We are going to treat it as a non-colored surface. So because this assumes a very fundamental concept within our game, we are going to create a material specific to this in order to not confuse it with anything else within the scene. So I'm just gonna open it up, and very simply, I'm just gonna right click, promote the parameter, the base color. Just gonna call this literally white. And I'm going to, the default value, again, we don't really mind because we are going always to use the material instances. There are a lot of things the material instances actually do. Another thing that came to my mind, just as a bit of a heads up, is the fact that you can change dynamically material instances within your level. With the material, it becomes much harder to do. You can still do it, but you won't have that much freedom, because material instances gives you access to the parameter within the editor itself, while for the material instances, for the normal material, you actually have to go within the blueprint, change this, save, apply, and then it will show. So it's a little bit easier to iterate on things. So we have the material level materials white, and I'm going to right click, create a material instance. I'll just simply leave that let that be. And I'm going to click this so I can change it, and I'm going to change this color to white. Bam. Okay, awesome. So first thing we're going to be doing is the color picker. So again, we can follow a very simple, much similar process to our input action shoot. Because again, we want to right click, so we want to create an input event that then traces a line to an object, and it's going to set its material to white because we are going to be picking its color, and then afterwards we are going to be storing that color. So there is an extra process that I'm going to be showing you, but everything else is pretty much a very similar process we have done within the input action event. So as you can guess, we go within the edit project setting. We wait for it to open up. We go into input, and we go into action mapping. Press on this, and we will literally call this color picker action. Awesome. I'm going to default this one to the right mouse button because it sounds very intuitive. To me at least. And I'll go within the BP player character. I'll create a new event, and I'll find the color picker. There we go. Action event. Okay, so pretty much the script is going to be literally the same. So I'm just gonna copy paste this. Usually when you program in Unreal, or actually when you generally program, you want to remove redundancies as much as possible to make the code more efficient and feasible. So we see over here, this is already a method that we are copying around. So this is completely fine to just constantly use around because it is designed to do so. But this specific operation is very lengthy, and in general, it doesn't really, we don't really want to change any parameter within this because we have the range itself, which that dictates the range of the entire thing, and these are simply mathematical operations. So what I'm going to be doing is create a function out of this, and I'll show you a little bit of a new concept called a pure function, which we already know what they are. I haven't simply point out who they are. So let's first create a function out of these. Let me see if, okay, yep. So right click whenever you're selecting all of them and click collapse to function. As you can see, it creates a function, and this function, in order to work, we will actually need to connect it to this and then to this if we want this function to work. Let's call this first of all line trace from camera, because that's literally what it is. So of course this is kind of working, like this wouldn't cause any issues, but putting this as a method function is a little bit of a mistake, because if we want to do some mathematical operations and we don't really have the possibility to access an input, because usually you don't really want to be going to an event input, you just would want it to be within to be calculated within another method. So because of this, I am going to change this method from a simple method that can be called through event graphs to a pure function. So to do this, I'm going to be clicking here. I'm going to click on pure, and as you can see from its visual aspect, it is something that we have actually met around. Something over here, for example, with the get right vector or get forward vector. You can guess from here what type of method this is. So a pure function is used specifically as a way, usually, to calculate things. As you can see over here, this is getting a right vector. That in itself, it does not really require an event input, because really we are just getting some information out of the engine itself. So instead of creating an action or doing a specific method that creates a specific logic, we are simply creating an operation. And operations usually work, you usually want to put them within a pure method so that they are processed within other methods. So after having created our pure function, we are going to be clicking in it. We can actually double click just to show you this is how it looks like within. It's literally the same as a normal method. It just returns only values. It does not return an event input. This is just a way to connect them. It does not actually have an event input, as you can see over here. And within here, we don't really want to change anything. I'm just gonna reorder them a little bit better. And we just want to change the return values names, which we can done here as well for simple ease. This is going to be called start, and this is going to be called end. They are much more understandable now. You can literally just plug them in because they're called the same, but the name in itself just simply represents the start of the line trace that it's happening, the start, which is the start of the camera, and the end, which is the ending vector that it's created thanks to this operation. Awesome. So after having done this operation, let's now go within our color picker action. Let's copy this. Let's actually copy all of this, which again, as I said earlier, we literally need a very similar script. Oh, what's the issue here? Maybe, oh, I haven't compiled. Okay, my bad. So right now it is, so this error pretty much is saying that I'm connecting them to something that does not exist, because instead these values are called return value 1 and return value 2, which is the values that they had before. But this is because I have not compiled it. So if I just remove it and I pick it up again from here, there we go, start and end. We just plug these in, we connect this to this. So what's going to happen is that we're going to have a line trace, which is going to ask within this branch if it hit anything, and then if it did, it will change the component of that thing to a material that it's called level material leaves. We want, instead of doing this, let's unplug this first. So we want to first store the material that we pick the color of. So in this, to do this, we are going to be creating a material variable that we are going to be using to store the material that we're picking up. To create a material variable, you can simply go within variables and search within here material, but for simple ease of creating one and to make sure that is actually the right one as well, I'm going to instead simply go within here, press on promote to variable, and now we have a material variable. I'm just gonna delete this one because that's not something I want to input in here. But now we have this volatile material variable that can contain any material. So the process with which I've created it does not link it to this. Remember this. I have just created a variable, but that now this variable can be used anywhere. If I plug it within here, it will now be used here, but if I unplug it, this remains a material variable. So don't get confused with having created a variable from within here. The two things are not correlated because I've unplugged them. So we want to set this material variable to the color of the material that we have hit. First of all, I'll show you something super quickly. Whenever you are hovering a variable within the project Unreal, you can drag it within the blueprints and release the left click, and we'll give you an option to either get the variable or set the variable. Set, as you can guess, sets the variable values, gets them. Now, to simply overcome this process of getting and setting, you can actually hold down some keys. So if you want to get something, you can hold down Control while dragging out. You don't have all the time. Yeah, I'm dragging it right now. I'm not holding Control. Before I release, I hold Control and then I release the variable, and bam, I'm getting the variable now. For setting, you want to hold Alt. So I'm not holding Alt. I'll just move it around. I want to set the variable over here. I'm going to hold Alt, release, and now it is in setting it. So setting a variable, as you can see, requires an input from an event and from an execution pin. Let's call these execution pins because not all the time these are going to be coming from an event. They can also come from a method. So this is not an event, this is a method, and these are called execution pins. So this has execution pins because anytime I connect an execution pin to this is going to set the range value to 0. We are currently using the range value within our line trace from camera here. So what is happening here? Sorry, I just moved a little bit the event graph too much. So what is happening here is that if, for example, if I right click and I have the color picker go through this entire function, so line tracing and all of that, if I hit anything, it will change the range to 0, meaning that our next cast of the ray is going to have range 0, therefore it's never going to be casted again, pretty much, because it will never hit anything. But of course we don't want this. This was just an example. I was just explaining some logic. Oh, I need to compile. It was not deleting. Okay. So we want to set the material of this variable to the material of the thing that we have just picked up. To do this, we want to access the component that we have hit, and we want to get his material. So let's see if there is a function. Of course there is. There is a function called getMaterial within Unreal, that what it does is that it's a pure one. So as you can remember, they are simply doing some type of calculation. They don't require execution pin to work. So we are giving as a target the hit component target, meaning that anything that we hit is going to be the target of this. The element index is 0. As you recall, the element index is simply the element here that represents the specific material. So if something has multiple materials on a single object, those multiple materials are going to be defined by their index. So 0 for the first one, 1 for the second one, and so on. And the return value is going to be the material, the reference to that material of the object that we have hit. So we want to store this within new var 0, which we are going to be calling color picked. So we want to store this within the color picked. And in this way, we have literally just stored the color that we have hit. Now, after having stored the color, we want to change the material of that color to white. Awesome. So let's see if this is working. Okay, so to test out that everything is working, I am going to be going to the test level. But first, let's change color picked to a public variable. To do this, we go on color picked. We press on the little closed eye on the right. And by pressing on it with left click, it simply opens up. Public variables are just a way to show a variable within our inspector and change it from within our inspector itself. So as an example, also I've colored everything white to better show you the color things we are creating. I thought that it was probably a little bit more confusing if everything was of a color, of different colors. In this way we can better understand the changes. But anyways, so a public variable is where did their father go? I killed him. Okay, doesn't matter. Let's remove these cubes. It has been time for them to die. Okay, so a public variable is, as you can see over here, all these variables that I can access within the blueprints are actually public variables. What I've done here, I've changed this private variable color picked to a public one, meaning that, as you can actually, by hovering on here as well, variable is public and is settable on each instance of this blueprint. I can now access this variable within the editor. How do I do this? Well, I should be clicking on because it's the BP player character that has such a variable. I should be clicking on it and be able to see exactly what the variable is within the editor. But there is no BP player character in here. Well, because we know that it spawns whenever I press play, I'll press play, I'll shift F1, I'll eject, I'll press on it, and now I can see clearly here that I have a default tab and the color picked is within here. The color that we have picked is leaf material 3 leaves. So this means that anytime so first of all, if I want to see changes happening within my code within the expector, I search for the BP player character and I simply check here. So anytime I press the left click mouse button, I'm going to color things based on my color picked. So if I change the color pick to, let's say, the tree trunk instance, as you can see, I'm now coloring everything of orange instead. This is how we are going to be changing the color of things based on the things we pick. So, awesome. This now means that if I press right click, so I'm just gonna click on the BP player again. If I press right click on the white material, I have now picked the white material, meaning that anytime I press, for example, another material, which is green in here, I color everything back again of white. Of course, because everything is now white, I don't really have any other color I can pick because white is the only color in the scene. So we're kind of encountering an issue here, the issue of resources. So what we are actually going to be doing, because we don't want two things to be happening. The first one is to override a color, meaning that if I have a 2 color in the scene, so let's say that I have, I actually deleted those 2 cubes. Let's do this very simply actually. I have 2 cubes. I have this cube of green and this other cube of orange. So if I go to these cubes and I'll go to this and I'll simply left click, now there is no orange in the scene. Imagine that I actually had to color this tree and this tree to open a door. Now I cannot simply do it anymore. And the way we would normally fix this, if we wanted our gameplay to actually be like this, is we would simply create a reset button or a way to reset the level. So for example, if I just jump off, it resets the level as a way to reset it. And in that way, everything resets and this becomes orange again. And I can try to create the level, to redo the level again, the puzzle, and try to solve the puzzle itself. But what if we don't really want to go into this direction? Well, that means that we need to set up some conditions for picking up a color and setting up the color of something. So let's start with picking up a color. So we want to pick up a color only if our hands are, let's say, not full. Because what can happen is that I can pick up this color. Okay, awesome. Now this has become white because I have picked up its color. Then I go over here. I pick up its color. Well, I have set up everything to white. That doesn't really help us out because now there is no color. I can really, I cannot color these trees. I can color them of brown, but that's the only color I have because I have overwritten the green color by picking up the brown color. So if I am not holding any color, or I'm holding the color white, that means I can pick up a color because my hands, let's imagine it has hands, my hands are completely empty. But because I have a color, that means my color picker variable is not empty. And if I'm holding a color that is not white, that means my hands are full and I cannot pick any other color, meaning I won't be able to override the green that I have just picked up with another color I may pick up. Because right now I am holding the green color, meaning that I literally cannot pick up any other color unless I put green down. So with these conditions, I can now set up the right click action so that there is not an overriding of colors. So let's do this first, and then we'll move on to the left click. So in BP player character, I'll go within the color picker action. So as I said before, we want this is the color we are holding. I want this color to not be equal to nothing. So equal to nothing means that it's like this. There is no color within it. To check if something has a variable within it, we simply use the isValid method. So this returns true if there is something within here, and return false if there is nothing. So we want to check if this is if we are not holding anything. Therefore, isValid needs to be false. So I'm going to create a branch, holding down B, clicking with left click, and I'm going to connect the boolean within here. This means that if there is something in here, it returns to true. If there is nothing, it returns to false. So let's connect this to the input action color picker, and the first condition we want to achieve in order to make sure that this other thing happen, so the line trace and the changing of colors and materials, before this happens, I want to make sure that I am not holding anything. Therefore, I want this to be false. Awesome. Now, I'm going to do another condition, which is, I don't know, so let's first create the condition and plug this to false, because we want to make sure we are not holding, that the color that we have is not valid. So another condition we want to do is that we want to make sure that the color that we are holding is white, because we want our hands to be empty. And we are saying that having the color white means that we are not holding anything. So in here, if we imagine this to be the player, so, and this is the, let's say, the color that we're holding. So in itself, we are checking for the condition where we don't have any color, we have the color white. If we have the color white, then we can pick up a color and change that white to the color that we are picking up. At the same time, if we are not holding anything at all, not even a color, then we can pick up the color that we have aimed to. So if the color is not valid, that means if the color is not valid, that means that we can pick up stuff. Awesome. Because again, if we don't have any color, that means that this color picked is not white as well. It's inherent within this. If the color we have picked doesn't exist, therefore our hands are empty, we can trace the line and we can set up the color that we have picked based on what we have hit. If the color that we have, the current color that we are holding exists, then we want to check that that color is white. If it is white, then we can pick up a color. To check if the color that we have picked is white, we check with an equal method if the color that we have picked is white. How do we do this? We go within here and we simply write down white instance. So we're checking if the color we have picked is equal to this variable, which is equal to the color white. So if this is true, that means that the color we have picked is white. If it is not true, that means that the color we have picked is not white. Therefore, that means that we are currently holding a color which is not white. And in that case, we cannot pick up any other colors. And this prevents it, because if that's false, then nothing really happens. Okay, so with this logic in mind that we have set up, we now are following what we have said before. So let's see if this works. I'm going to be setting up the color picked to something else. So let's say I'm setting this up to leaves color. So hypothetically speaking, if this is not white, because this is not, as you can actually guess, nothing should happen when I press right click. So I'll press play. I'll go over to this one. I right click And as you can actually see, nothing is happening. Nothing at all. Awesome. And this is exactly what we want. If the color I have picked is instead white, then I can pick this object up. And then because now the object I have is not white anymore, because we set it up in here to change, I now am holding green, and because of this, I cannot pick up any other color. Awesome. This is exactly what we wanted. Let's test this if statement as well. So if the color I have picked is not valid, so to make it so that this is not valid, I simply clear it. So if it is not valid, it should pick up a color. And it is doing it. Awesome. So this entire logic now works as we wanted it to work. Okay, so now that we have done this, let's move on to the input action logic. So for the input action, what we want to do is, again, if I am holding an object or a color, I want to be able to shoot at something, and I want to make sure that that something does not have a color, and if it does not have a color, let's give him my color. And that's kind of pretty much it. So let's first handle the idea of holding down a color. So I'm going to be going within the PP player character. So what we want to do here, if I am holding a color, therefore that means that we want to check if the color picked is valid. So if I'm holding a color, and preferably let's actually make sure that that color is not white, because you know, we don't want to color something white when we want to give something color. Otherwise what can happen is that I am not holding anything because my currently color picked is white. I left click the green, and then now the green is gone because it has become white, and we don't have green anymore in the scene. So let's make sure that the color I'm holding is not white. To do this, we can do it in two ways actually, using the logical things that we have. So first of all, let's make sure that our color is valid. And now we can either make sure that this is false, which is kind of, you know, very straightforward, or we could also use the method of not equal, which is written with an exclamative point and an equal, and it's pretty much the exact same of this, but returns the values pretty much inverted. So if this is not equal to this, then this is true. If this is equal to this, then this becomes false. To ease up things and not confuse you too much, I'm just gonna use this one instead. So if the color that we have picked is not equal to white, that means that we can put that color into the object that we currently have. Awesome. So this is the logic. There are a little bit more steps in here though that we have to follow. So we are currently setting the material with the color that we have picked, but once this process is done, we don't really have a material, a color picked anymore, because we have given it to the material that we have shot. So to make sure that this happens, we are going to be setting the color picked to nothing, really. So we leave this blank. We could have set this to white as well. It doesn't matter. We are treating white as an empty color. So in this way, we can actually test out if this works by going within the test level. And I'm going to delete this guy. I'm going to be going on the player once I press play. So BP player. And now we can observe the magic happening within the actual here. So the color I have picked currently is nothing. Meaning if I left click things, nothing is happening, which is exactly what we wanted. Now I'll pick up the orange trunk color. As you can see in color picked, it has changed to orange. So again, I've left clicked here. I'm just gonna pick it up again. Okay, so I have it in the color picked. So now if I try to put it on green, we don't want this to happen. So we need to change this. But apart from this, we see that we can pick it up, we can put it around, and it kind of feels like, you know, also if I pick up white and I try to put white on something else, it doesn't let me, which is exactly what we want. I pick this up, nothing happens. Awesome. So it's exactly what we want. The only thing we need to change now is the issue we have seen over here. If I right click this and I left click here, I overwrite the color, which is not what we want to do. Again, we are losing the green with this action. So we go in the BP player character. So we know this is happening after the line trace. So within this line trace, we want to check that the hit component, again, we want to check that the object that we are hitting has the color white on it. To do so, we go within hit component, we check his material. So we go here, we press get material. Awesome. Meaning this is a pure function, as I've shown you here. This takes in the target as the hit component, with the component that we have currently hit. That these are components, if you recall. So any of these can be checked. Oh, I have unplugged some stuff. Okay, my bad. And the element index, again, refers to the index within the material tab. If an object has multiple materials, we can literally see these different materials within here, and they'll be called element 0 for the first element 1 for the second element, and so on. So we are going to be going in here, okay. And the value that this one returns is the material of the object that has been hit at the position 0. So if we hit this object, the material, this output will be, this output will be equal to this exact color. If we hit this, the output will be this. So we are checking if the color that we are hitting is equal to white. Okay, level materials, white instance. So we're checking if this is white. If it is white, then this won't be happening, because we don't want to neither set the material to something different nor remove the color picked. So I'll create a branch, I'll connect this to this. So if we have hit something, let's check if that something that we have hit has the color white. If it is white, we want to change that white to the material of the color picked. If it is not white, then we don't want to change anything with it. So we are not going to be doing anything bad to it. Now, with this change in mind, let me order this down a bit. I'll press, clicked some stuff. Apologies. I'll press play. I'll go here. I'll pick up this color. I'll try to put this color on here, as you can see from the lines, but it's not happening. I'll put this color here. I'll pick this on. I'll try to put it here. It's not happening. Here, and I can change things around, but in the end, I cannot overwrite color with another color. In this way, I now can have something like this, where I am putting these two colors in the scene, and I'm telling the player, hey, look, there is a door over there. If you color the trees with that, with their specific color, then you can, the door will open. So of course we have more trees than we have more trees than the colors that we currently need for said trees to work. But that can be simply changed by going within the level and either removing some trees, because of course, why do we even bother about having those trees if there are not enough colors? And okay, awesome. And there is a little problem over here that we have. So we have removed all the trees. We can pick up stuff. Now there is enough colors to color up the tree. There is a little issue over here. As you can see, the leaves are set up in such a way that they don't accommodate for the leaves color to go on the leaves thing. So on all the leaves. So how do we change this? We can change this in two different ways. The first one is through scripting, which is going to be a little bit more complicated than we actually want it to be. We don't really want to, check if the player hits one of the leaves component, and if it does, if the hit gives the leaves a material, that means that that material needs to be given to all the leaves. This is extremely confusing, of course. Instead of doing all of this nuance, we are instead simply going to create a model for the leaves and using said model so that it can be used by the player to simply hit this model and the entire model will color. Because the problem we currently have now is that the leaves is formed by two models instead of one. So how do we do this? Because the leaves currently are static meshes, as you can see over here, we need simply to change the static mesh of said leaves to something else and remove completely the second leaf. So the idea would be to create one single model so that it can change the color easily. I'm going to introduce you to the BSP geometry.
Hi! Congratulations on getting this far. I hope you're enjoying the course and already starting to see awesome results. If you like what you're seeing and want to check out the extended version of the course, head to skillademia.com, where you will find our full Unreal Engine beginner to advanced course with more than 30 lectures and many more projects to complete. Now, let's continue.
Welcome everyone to this new Unreal tutorial video. Today we will talking about BSP brushes. So let's try to recap what we did last time. We have created this little system that lets us pick up a color and put this color on a specific object. And this way we can color up the world around us, and this will give us the possibility to create different type of puzzles and things that could be interesting to play. But the main issue right now that we have is that our tree, that is symbolized by this sort of T-shaped thing, actually is missing the leaves being done well. So at the moment the tree looks more like a T rather than a tree, and we had it looking like this last time. Like this. But we want to solve the issue of having two objects creating a single one, because of how our mechanic work, we want to associate one color to this entire structure and make it so that the entire structure changes the color itself. Of course, we could do this with programming, with blueprints, but it's more complex than it should be. We shouldn't really try to do something like this when we have BSP brushes in place. So I'm gonna delete this and let's go to BSP brushes. So how do we create a BSP brush? This is actually very simple. In the Place Actor tab, which you can bring down going within here in the window if you don't have it, you are going to go in Geometry and in the box, and you're just gonna drag in the scene box. So right now, I mean, you could choose any one of these shapes, but for now we're going to stick to the box because it's the simplest one, and this one is actually what we will require to fix this little issue that we are having with our tree. So right now, what we have done with this action is actually created a brush. So this box is currently a brush that we can modify in ways that we think are appropriate to what we are trying to achieve. To do so, we are going to go into modes and we are going into brush editing. Brush editing gives us the possibility to change the shape of the object that we have in front of us. So as you can see here, the editing happens within the faces of the object itself. If I want to change any sort of thing from this object, I can either click on the faces or I can click on the vertices, which let me change the object as I see fit. So it is usually very simple. If we want to recreate this, I'm going to start scaling this down. So I'm clicking on the top face and I'm going to scale it down. And by scaling it down, I want to, first of all, as you can see, the shape has changed. But most importantly, I want to underline something here. You see how the texture of this object has this kind of check pattern to it. So what's happening here is that each one of these cubes represents one unit on the object, and this unit is the equivalent of 10 units in Unreal. So what do I mean by this? If you see here on the snap grid, I have chosen 10 as the number. So what this means is that anytime I move an object, the object is going to move 10 units on the specific axes. I'm just gonna switch back to select. And so what's happening here is that what I can do, I can move the object of 10 units on the right or left right now. And as you can see, each one of these, each movement, each snapping that occurs is exactly 1 unit on the object itself. This means that the object currently has 200 units on the y-axis and 100 units on the z-axis. And this way we can much better gauge how big an object is, and we can change its size based on a specific structure that we are going to create ourselves. For another example, as you can see, this cube over here is exactly 100 units. So if I put it close to this, we can see that it fits perfectly the 100 unit statement I've said before. And in this way, we can actually move different objects one closer to each other without too much trouble, because we kind of know their sides in the first place. So always keep in mind what the size of your object needs to be in order to create a level. I'm gonna go back to brush editing. So let's try to recreate that cross static mesh that we saw that we need for our leaves as well. So I'm gonna change its size. I'm gonna move it so that this represents 300 units. I'm simply gonna follow the pattern over here. So I see that I have gone on the gray area, so I'm just gonna back down. So we know that now this is 300 units. So as you can see, this object pretty much represents the leaves that we currently have, which is this rectangle. But we were talking about having a cross instead of a simple rectangle. To do so, we actually are not going to simply move the faces and then trying to move the faces again, because as you can see, by doing so, the face changes its shape so that we cannot no longer try to create a cross. To create a cross, we are actually going to go back to the 100 unit cube, and I'm going to click on something called extrude that is in the top left. What extrude does, it's that whenever I press on a face and I move forward based on that face itself, what extrude is going to do is it's going to create another face that connects to the face that we had before, and it's going to act as its own thing. So meaning that if I now want to go back into face editing and, for example, press on this face and pull it up, it's actually going to modify the other faces based on this face alone that I've pulled up. This is literally just a way to create different faces that I can change and then give me much more control over the object that I am creating. So let's go back to extrude. I'm going to extrude one more time on the right, so that we have our object divided into 3 different sections. Remember, if you're... oh, I actually didn't check the sides of here. So extrude in itself sometimes actually just messes up the texture. This is something that you can really work around. We can simply count here, 3, 6, 9, 10, 11. We know we are 11. So let's go back to edit to the edit function, and let's go back 1 unit. Awesome. So 10 and 20. I'm gonna go on extrude again. I'm gonna pull extrude from here. I'm just gonna go a random distance, and then let's count again. 3, 6, 9. Okay, we just need 1 more face. I'm gonna go back to editing, pull this out, and awesome. Now we have a differentiation of 3 different faces for each cube that creates this object. So why am I switching back and forth between extrude? If I try to extrude something, so let's say I extrude this face over here, and I'm moving it all the way over here. I release, and then I try to, this is 7 units, therefore I need to add 3 more. Let me do 3 more things. Okay, awesome. Oh wait, it actually has created another face, which is something that we do not want, because this can create a lot of complexity within an object that we don't really... We want to make sure that the complexity of the faces and the number of faces are as little as possible for what we're trying to achieve. So make sure you don't overuse extrude too much. So after we have extruded from this face, what we are going to be doing is we now want to pull from here and here in order to create the cross static mesh that we are trying to do. So, but if I pull from here, again, it's going to create a weird shape that I don't think the leaves are going to be looking like this. To be honest, the leaves will actually look more nicely like this. So I'm just gonna stick to this. But first, if I wanted to create a cross face, I simply, again, extrude. So I'll extrude a little bit, I'll go back, and then I'll pull the face to make sure that 3, 6, 9, 10. It goes back to the 10 units that we're talking about. So 3, 6, yeah, 10. We can do the same over here, but again, I actually did like the shape that we created before, so I'm gonna go back, and I'm going to simply pull from here and create this little rhomboid figure. I'm gonna count the units, 3, 6, 9, it needs one more pull, and over here as well, 3, 6, 9, again, I'm gonna pull it again. Awesome. So we now know that everything is perfectly aligned with each other. So after we have created the figure that we actually like, we can transform this into a normal static mesh, because at the moment, this in itself cannot really work well in a video game scenario, because although you could use BSP brushes all over the place and then replace them afterwards, it is usually a good idea to transform this into a static mesh, so convert it into a static mesh. To do so, you simply have to go... Let's go back to select mode now, because it's much simpler. One little note I would like to add is that the pivot of the object that we have currently created is actually going to be in the last position you have changed it when you were into the static mesh object. When you were changing it, meaning that whenever I press on this, so you see if I press this, it goes into the center. If I go here and I press this, it goes into this weird angle, which we don't really want. I'm gonna fix this really quickly. So what you want to do here is that you want to hold Alt, you're going to hold down the the wheel scroll button. You're gonna press it, hold it down, and then you're going to move it in the position that you want your pivot to go. So right now, I'm just gonna follow the structure that we have. I'm going to move it 5 units on the left, and then 5 units on the right to make so that it is in the center. So I know that the height of this object is 10. So what I'm going to be doing, I'm going to snap this down 5 units. So 1, 2, 3, 4, 5. Awesome. So I do know now that this is exactly in the center of the object. To make sure that the pivot in itself is saved, because right now if I click on any other object in the scene, the pivot is going to disappear from this object, appear on the other object, and then when I click on this object again, I'm going to lose the modifications that I have done to the pivot itself. So I'm going to go into pivot, right click on the object in the world outliner, go into the pivot, and I'm going to set pivot, set as pivot offset. I'm gonna click this, and now the pivot is saved. So if I press on this object and I go back to this, awesome, I have it where I actually left it off. So if I'm gonna change it to a random position right now. So I've changed it without setting it in the box brush. I'm gonna click on this, click back on here, and here you go. I've lost my saved progression that I had beforehand. So in this way, we now have the pivot in the perfect position that we wanted it to be. To make sure that we now want to convert the object to the static mesh, what we want to do is we click on the object itself, we go back down in the detail panel, all the way down to, let's see, brush settings, So I'm gonna click on the arrow and I'm going to click on create static mesh. The static mesh that I'm going to be creating is going to be using the pivot that I've just set up. So this is exactly why we have done this before creating the static mesh. And now I'm going to go into, actually, let's go in content. Let's create another folder. Let's call this static meshes. I'm gonna double tap into it and I'm going to call this box brush static mesh SM, which means static mesh, underscore leaves. I'm gonna save this into the static meshes. And in this way, we have now created a static mesh. As you can see, we can move it around. We cannot change its its faces anymore. So if you're going brush settings and try to click on its faces, it's not working. And now with this, I can simply use this as a replace for the leaves that I have above here. So again, one simple thing I want to remind you. We have changed the pivot, meaning that anytime I bring something within the scene, the pivot is going to have that specific position for his pivot. If I did not do this before converting to a static mesh, what would have happened was this. I'm going to move this over here. I'm going to set its pivot as a pivot offset. So now this is its pivot. I'm going to click somewhere else. I'm going to click back to this. Okay, so we now know that this has its pivot set. Let's go back and look at this. The pivot is in the center, meaning that if I wanted to have the pivot in a specific location, after having converted it to a static mesh, I couldn't have done so by simply changing it for one single static mesh. In fact, if I just pull another static mesh from the prefab that we have created, as you can see, the pivot is again in the center. So make sure you always set the pivot before you convert something to a static mesh, so that that pivot that you are going to set up for that brush, it's going to carry over once it becomes a static mesh. So now that we have a little bit more understanding of BSB brushes, let's replace this weird looking thing with our leaves. So I'm going to simply go within here. I'm gonna click on cube. I'm gonna look for leaves. I'm gonna click this, and as you can see, simple as always, it has replaced our leaves. So one little thing, of course, anytime I replace an actor with another actor, the new actor that I have just put in the scene, it's going to follow the exact same transform of the actor that came before him. So in this, the rotation being this, which again we are fine with, but the scale on the epsilon is 3 instead of 1, meaning that the object that we are going to replace this with is going to have a sides on the epsilon of 3. And as you can see, it looks extremely weird. To fix this, simply just going here and give it its normal scale. So 1, 1, and 1. We can change its rotation as well, because we just want it to have its default rotation instead of being turned 90 degrees for no reason. Although that doesn't really affect us too much. And now that we have our tree, as we go back into the scene, we can see that the tree is actually following its being a tree very well. So if I duplicate this, as you can see, it's always going to follow the principles of actors, where the one actor inherits the components of another. And let's try to playtest this. I'm gonna pick this up. I'm gonna put it on the leaves. Ooh, this is another thing we have to change. This is always why you playtest. So I'm gonna pick this, put that back there. I'm gonna pick this up, put it here. Okay, awesome. So we know that the brown thingy is working on the trunk. We just need to fix this for the green part. Before I go into changing this and fix this up, because I want to make sure that there is a good structure to the overall flow of information, let's first analyze a little bit more closely the BSB brush geometry part of this video, and then I'm going to cover this fix into the next video that is going to be more towards the game itself. So let's create a little level for the things that we have around. Let's try to create a door instead of a simple level. I'm just gonna pick up the box again, and this time I'm going to move the object over here. all the way over here. I'm just gonna make sure that it's perfectly moved with the other object. I'm going to click on modes. I'm going to press on brush editing. I'm going to click on the faces. I'm gonna change this a little bit. There we go. And I'm going to do something that you are going to say, wait, can't we just extrude to make this simpler? So I'm going to do this, and then I'm going to do this. And I'm going to tell you that this now is a door, but it requires a little bit more changing to make sure that it is completely a door. So let's first make sure that the distance is good. Okay, so perfect. It is following the grid quite well. Maybe it's too big of a door. Let's check it out first. I would assume it's fine. It's as big as a door can get. Okay, so we want... Oh, this is a little bit off. So just gonna make this slightly smaller on the left and on the right. And what we want to do is we want to cut a hole in here. To do this, we can use the BSB brushes again with the additional option called subtract. So right now, whenever we add a brush to the scene, this brush is called an additive brush, meaning that it is going to add itself to any other object present or any other BSB brush present in the scene. As you can see here, it works exactly like static meshes. So I'm not gonna go too much into the detail explaining what is happening over here. But if I delete this, I press on subtract, and then I move the same exact box within the scene. Now you can see that it becomes this weird reddish color, and it now is a subtractive BSB brush. This means that whenever it tries to interact with any other BSB brushes in the scene, it's going to subtract itself from the other object. I'm going to show you this by simply putting this object very close to this one. I'm just gonna make sure that it is perfectly aligned with this one. And then I'm going to move this one a little bit with the inside of it. As you can see, it pretty much cut off the entirety of this object. I'm gonna pull this one back out again. And this object, it works exactly the same as the cube, the normal cube that we have seen before. You can go into the brush editing mode and press on its faces, and you can change its faces and change its overall shape exactly like the other object that we have seen before. So I'm just gonna go into select mode again. I'm gonna, of course, in the scene, this guy is very hard to see. So to make sure that you always know where they are while you're working, of course, because again, you want to transform these in a static mesh after you have completely done creating them. So I'm just gonna do a temporary folder, call it subtractive BSB brushes. I'm just simply gonna put this in here, and I'm going to move this guy all the way over here. I'm going to enter this object, and I'm going to select this other face. I've selected its face, so we see that the face has been selected. I'm gonna pull it all the way over here, and there you go. Now we kind of have a door, something that you can pass through. We can test this out by simply pressing play and playing around the scene. As you can see, there is collision over here. There is no collision over here. Awesome. So this is our door. Of course, we could do some more creative things with it. So if we want a little bit more of an arc, we would use a sphere instead of a box. Let's do that. So I'm gonna select the face, move it all the way down over here, and then I'm going to position inside of here a sphere. Is it a sphere? Maybe we just want the top side of the sphere here. Maybe we don't need the sphere itself, actually. One thing I would like to say, by the way, each one of these objects, maybe apart from the box, which I think yep, the box is very, it is missing a lot of options because it's a very simple object, therefore it doesn't need any. Any one of these objects has its own options that we can change that let us change a little bit better the overall size of the object in itself. So first of all, what you can see is that I can change back this object to any other object present here. So I can change it to a cone, I can change it to a cube, I can change it to stairs. I can also change it back to additive if I wanted that object to be back to be normal again, let's call it that. But most importantly, you can change the options of each one of these objects. So let's go back to the sphere, if I find it. Yes, tetrahedron. And let's change, for example, tessellation as 1. So as you can see, it has removed a lot of the faces that the sphere had. If I put the radius to be, let's say 160, of course, it becomes smaller. And mainly these, if I do 0, of course, the thing completely disappears. Oh, the engine doesn't even let me do that because, of course, the thing will entirely disappear. The more tessellation you give him, the more precise the object becomes. Of course, the more precise the object becomes, the more laggy your computer becomes as well, because there are a lot of things to compute. So we can leave this at 2. But for our overall task, we don't actually want a sphere. What I'm looking here is probably something a little bit more curve. So I'm gonna use a cylinder. Actually, let's do it from the sphere itself. Let's go to the box brush of the sphere, which I have lost because I'm just saying, hey, make sure that you don't lose them, and I'm just losing them. So let's remove this one. Let's put this one all the way up into subtractive BSP brushes, so we know that it's there. And let's simply change this from a sphere to a cylinder. Awesome. So let's make sure the cylinder is a little bit smaller. I'm gonna go into outer radius. I'm gonna write this to 100. I'm going to change the sides to be maybe 80, it's fine. And let's make sure that it's a little bit more small. So I'm gonna go into modes, brush editing, which I was already. Press on the face, and I'm going to pull the face down. So because the texture is missing, it's a little bit harder to gauge the actual the units of each one of my changes. But that shouldn't be a problem because we can simply put this close to the other object that we currently have and simply do what we need to do there. Oh, sorry, I'm gonna go back into modes and select. I'm going to rotate this guy like this, so 90 degrees. I'm gonna move it all the way over here. And as you can see, it's changing the brush that it is currently, it's changing the other part of the brush that we need to change. So I'm going to press back onto brush editing, go into here on the face behind. So I have made sure that this part is aligned, so I'm just gonna drag this all the way over here. And now we have a perfectly aligned object to our other object. And let's simply control and see the entirety of the object. So this is the entirety of our static mesh. Actually, let me change a little bit more the size of this. I feel like it should get to this. Let's see the distance overall, how big the door is. Maybe this is too big. Yes, let's put it back down to where it was. There we go. Awesome. Okay, so I've just pressed Ctrl Z right there. Okay, so we have this object done. So to create and make sure that this is a static mesh, you need to select all the objects that are currently being used by the object itself. And then you are going to be pressing on Create Static Mesh. So again, before we create into static mesh, really good thing to do, let's change the pivot of this object. So we know that we are 10 units. This is along the 10 units. I'm gonna go 1, 2, 3, 4, 5. I know it's in the center. And now let's just drag it all the way up to this. I think it's fine. We don't need to be precise with this. It's not needed. And now I'm gonna right click, pivot, set as pivot offset. This means that I've set the pivot for every single object in here. So this object has this pivot there, this object has the pivot there, and this object has the pivot there. So just gonna control click every single one of them, press on creating static mesh. I'm gonna go into static meshes. I'm gonna write down the name as door. Very simple. And bam, we now do have a door. And all the objects that we had into subtractive BSP brushes have gone completely. And they have become part of the object that we now have in front of us. I'm just gonna delete this folder because we currently don't need it. And awesome, we have now a door. There is a single issue with the door that I have actually remembered what the issue with this as well is. There is no collision. Why is that? Whenever we are creating a BSP brush object, the collision is simulated within the engine itself whenever we press play to let you see what the potential collision of the object would be. Now that we have created the static mesh, we need to reassign the collision to it because we need to specify what type of collision we want to have. Okay, so I'm gonna go double click on SM door. And now that we are inside the SM door tab, you can see there is a lot of different things in here. For now, we are not going to mind all of this too much because this is mainly for 3D modeling and exporting things from a 3D model software into Unreal. So these are not going to be covered in this course. But what we care to do here is add a collision to our object because currently it has none. To do so, we are going to go first of all into collision on the top. And we're going to add a box simplified collision. In this way, we now have a collision, which is the most simple type of collision that our object can have. We have decided to have as a normal shape the box. So if we press save and I go back into the level and press play, I can now see that I can, of course, collide with my object, as you can see. But the problem also arises because on the hole in our object that we can collide with the entirety of the object, therefore we cannot go through the wall. To fix this issue, we're going to use something called complex collision. So if I press on the complex collision tick by going into collision and complex collision, we can see that this is a representation of how the complex collision of our object looks like. To access this type of collision, we are going to be going down into the details panel all the way to collision and complexity. Pressing on the tab on the right brings down all of these options, and we're going to use complex collision as simple. This means that the complex collision that we see here right now, it's going to be used as a simple collision, therefore overriding the simple collision that we have used beforehand, the cube one. We press save, we go back into the level, we press play. I go forward to the door again, and now as you can see, I can pass through the hole. I cannot pass through the object itself. Awesome. So in this way, we have set up the collision for this static mesh. Overall, with this, you now know how to create a static mesh, how to modify said static mesh to your please, and also assign collision material to the static mesh. Let's go back to the tree that we have created beforehand. As you can see, whenever I press play and I pick up a color and I try to give it to the leaves, this is not happening. Why is this happening? The problem, as you can see with the lines as well, is that they are not colliding with the object over here. If I press this on this object instead, you can see that the line becomes green, meaning that there has been a hit, and there is also this little red square that indicates a hit. This is not happening, but if I do it here, it is happening. So what we need to do is simply assign a collision to our leaves static mesh. We go into the leaf static mesh, we open it up, and as we have done with the other guy before, we add a box collision, we see how it is. It is, of course, a box. We don't really want it to be like this. So we go down into project default, use complex collision as simple. Let's see how complex collision looks like. So, yep, this is how it looks like. Awesome. I'm gonna save. I'm gonna go back to the level. I'm gonna press play. And as we can see, it is coloring them of green. Perfect. So we now can actually color our tree in order to have it, colored. So let's try to create a little level from static meshes themselves. So to create a level, we kind of need a little bit of an idea beforehand. Remember to always follow a specific unit code. So you would want, for example, if the player can jump, and we are going to introduce jump soon, what we want to make sure of is how many units our player can jump, and make sure that we have different type of obstacles of different sizes made exactly for the player to be jumped on. We want a wall to be represented by, for example, something that has a 200 unit length, therefore the player cannot jump it. We want a jumpable surface instead to be, for example, 100 in unit, so that the player can jump it, and so on. So by simply respecting these sizes, we can create a level that the player can play without too many issues. I'm gonna do something rather quick, just to show off how a level can be created, but you feel free to do whatever you really want to do. Let's see. I can do this. I'm going to create a cylinder and put it right around the middle of the square itself. I'm going to go into the outer radius. I'm just gonna do this as 1000 just to see how big it becomes. Okay, that's good. Maybe a little bit bigger. So I'm gonna do 1500. That should be fine. And I'm going to pull this up a bit because it is kind of in the way. And I'm going to do this. I'm going to duplicate this. I'm gonna hold Alt, move the Z axis up, so it is being duplicated. I'm going to change this from a brush type additive to a subtractive. So now it is a subtractive. I'm going to change its outer radius to 1250 units, so it becomes smaller. And this is something I would like to briefly mention. Whenever you have one of these objects and you're trying to change their sides, make sure that you are not changing the sides by simply pressing R and let's do it on here by pressing R and by moving these little axes around. You do not want to do this because the texture itself is going to get stretched when you change the sides of an object. Therefore, by getting it stretched, sometimes you can mess up the UVs of said object, and meaning that it becomes harder to use for your artists, and it probably will need to be redone at some point. So, okay, make sure you're changing from the options that are available thanks to the detail panel. And now let's simply move this guy a little bit down. Let's make sure that it is perfectly aligned. My mouse is not helping me here. Okay, so perfectly aligned and awesome. So now that I have done this, I have some type of level setup in place. So first of all, the best thing to do is, instead of creating a huge cylinder like I have done in this way, it's usually really good when designing a level to divide everything into specific pieces, and you're reusing said pieces to create your level. Of course, I'm not gonna do this because it's gonna take quite some time to specifically go through the entire process. Therefore, I'm simply using this as camouflage, where I'm just simply creating a cylinder and doing it in this way. But if you are interested in spending a little bit more time on your level, feel free to pause the video right now and just go and create some pieces of static meshes, some 3D pieces that have different sizes, and try, for example, to create 4 or 5 different pieces and create a level with those. When I say pieces though, don't think about them as maybe a tree, maybe a door. Those are not exactly pieces that you can use for a level. Think about them as Lego pieces. So what you want to create is a Lego piece of a size of 1, another one, so like, let me see if I actually find it on the internet. So what you want to do is pretty much to create something like this. So imagine your pieces to be, each one of them, a different size of a specific shape. So you want, for example, to have a 1 by 1 shape that you can use for maybe corners. You want to have a 3 by 1 shape that you can use for maybe some walls, a 4 by 1 for longer walls, and try to create maybe 3, maybe 4 of these shapes. And once you've done this, feel free to create a level of your own. I'm just gonna give you an example of how I'm gonna do this. Let me firstly click this. So something you can do is something of this side. So I'm just gonna do this very quickly. Brush editing here. Put this down. It's really good when you are trying to follow specific measurements to change the grid snapping. 100 is usually really good if you want to specifically follow a specific type of grid. I'm just gonna delete this because I screwed it up. Go back, press modes, brush editing, write this down. So you can have one piece that can already be like this. Another piece that could be something along these lines instead. Let me go and select. Let me go here. So something along these lines. Editing. Okay. So a 3x3 piece. And then you may have, let's say, a 1x1 piece, which could be something like this. So this one can be used for whatever you really want to. And in this way, feel free to create a level by putting pieces together and, you know, creating something interesting. I'll see you back. I'm just gonna create mine as well and see you in a bit. Okay, just a quick note. Because creating weird pieces actually slows down the computer, I've decided I'm actually going to be using normal pieces as well, and I'm going to be recreating a level using said pieces so that if you want, you can follow along. Feel free to skip this part if you want to just simply work on your project by yourself. But in case you're interested in seeing how someone that knows the tools, how he uses them, you just want to see the process, then feel free to stick by. So what I'm going to be doing here, I want to make you understand that the mechanic we are using about changing color. So if you have let's say a land with grass, we would want to make sure that each area that can be changed the color of has some type of unification to it. What do I mean? As you can see over here, if I'm picking up a color and then I'm putting it down, I want to make sure that here everything that relates to that specific object changes color. So as you can see over here, if I put down that green, I would want the entire land to become green again. This means that by making the floor 4 pieces, I'm actually not doing something right over here. I want to make sure that each one of these, or each object is its own thing by itself. So first of all, let's recreate the floor. I'm going to be picking up this little object that I've shown you before. I'm just gonna put it around here. I feel like I should probably try to move it specifically to where the other floor was. So I'm gonna do this. So what you see here, just as a little side note, it's something that it's called a Z fighting or Z clipping. It's based the Z meaning the Z axis, and it is referring to the fact that the texture of our box brush is colliding with the texture of floor 3, therefore creating this weird effect where one is fighting against the other to show his own texture. Therefore, this is why this is happening. We don't mind this effect too much. It doesn't really affect the engine in any way apart from visually speaking for us. I know that everything is perfectly aligned because they are doing this weird effect. And after having done this, I'm going to go into brush editing, pressing on the faces, and I'm just gonna bring this all the way over here. And by doing so, I should have the length being done. So in this way, we now have the land. I would suggest, if you're having issues aligning things, to ump up the grid. And this way it's much simpler to position everything correctly. And now let's make sure that this entire effect stops, because it is hurting my eyes. And let's press on all the floors, and let's simply delete them. Awesome. Now that we have our floor, remember what we want to do. If I press play, the color cannot be applied to the surface simply because it is not white. The way we programmed it beforehand made it so that we need to make sure that the surface we are applying the color to is white. So to do this, we are simply going to press on this. For now, we are not going to change these to static mesh, because we may actually want to change some shapes into this object. So for now, let's keep it this way. Let's go into element 0 and let's simply put this as white. The instance, of course, if I now press play, I can put the color. Nope. The reason why this is not changing, first of all, I've just noticed we have changed only one phase instead of the entire object. I am assuming this is because we were actually aiming towards that specific phase. But in general, when you're using BSP brushes, there is this issue where things that you would want to work, that you would want them to work, are not really going to work for BSP brushes. As you can see here, we wanted to change the material and then change said material in the game of the BSP brush, but we were not able to do so. Another thing you cannot do with BSP brushes is moving them whenever you are inside the play mode. In play mode, you cannot move a BSP brush. They are kind of similar to a static mesh that it's set to static. That object cannot move. And there are probably a lot more things and issues that may arise when using BSP brushes in play mode. So just keep in mind that if you want to test around the level and how it feels, these are amazing. But once you're done using them, make sure to always convert them. So we have now this little landscape that we have created. Let's make sure that we do more. So let's first create the folder BSP brushes. And let's do more. Let's think about something else. Let's try to put some random geometry around just to see if we can change how this feels from a perspective of a player. So I'm just gonna put a cylinder over here. I'm just gonna move it here, trying to always make sure to always align it to some type of unit. So in this way, I'm aligning it with the length. So as you can see, it's taking out 1, 2, 3, and 4 squares. Same thing over here, 1, 2, 3, and 4. So yeah, this, and this. Okay, now that I've done this, I'm just simply going to select this in mode, brush editing. I'm just gonna pull this up, and I'm just simply creating some random objects within the scene. Whenever we press play, we can simply control it. Yep, it's there. Let's move them, one there and one here, another one here maybe. Why not? We have full control of what we are doing, so let's just play around with these things. So I'm just gonna copy paste this over here. And maybe over here as well. And I've just come up with a simple but yet intriguing idea. So what if, let me just put this here, always align them to make sure that you can change them much more easily afterwards. And one important thing I would like to say is whenever you are reusing an object often, like I'm doing here with this 3 cylinders, sorry, it is a good idea if you are actually going to use if you're sure that you're going to use this in your project, to convert these to static mesh. Because right now, the way they are set up, if I click on this and I convert it to a static mesh, this and this won't be converted to a static mesh. Meaning that if I want to then convert these to a static mesh, I would need to remove them and place the object, this one that I've converted to a static mesh, in their spot. This can be done quite easily in Unreal, and I actually think I've showed you this before. but you can simply, once you've created a static mesh, you can simply right click on the object that you want to change the static mesh of, and replace selected actor, and then you will decide which the static mesh that you have just created. I'm just gonna click on leaves just as an example, but as you can see, it's going to follow exactly its position. Of course, as the pivot is going to have the exact same pivot as the object beforehand. And yeah, so let's do something neat. Let's do something where, in order for the player to finish up this level, he will need to pick up the color of this cube that we're going to be putting right up here. And to do so, actually, let's put it up here. There we go. It doesn't really need to be centralized, but yeah. And to do so, he simply needs to jump on top of these cylinders. Of course, we don't really have the jump mechanic yet into the game, but again, let's play around with different ideas to see how the game feels overall. And why not? Let's just put the tree, instead of there, all the way up here, so that the player will need to reach this tree in some ways, which we are going to think about, of course. But this would make the gameplay more intriguing in a sense. So, let's bring the cylinder over here again. Let's align it to a specific grid. So I'm going to put it so that it's like this. Okay, it's aligned. And now I can amp up this cylinder, but again, because I don't know the height of the jump, this is not something I can simply do and be free about it. Because I know that we are going to be using the jump mechanic, I'm just gonna lower this down a little bit. I'm gonna click on the tree, bring it down, and it's fine. I feel like if we just give it a random size, it doesn't matter. I'm going to play around the idea of the fact that our mechanic can actually be, like, you can pick up all colors from a distance. So if you want to give the color to the tree, you can simply doing it by doing this. But in general, we would want to play a lot around the sides and the range of our game. So if I want the player to specifically need to jump on top of this, I will need to make sure that the range of our player is very small. If I go into blueprints and I go into the people player character, the range in it's here. Instead of 1000, I can do 100, and that would work with making such a level. But because for now, again, we are not really too sure what we're trying to do here, I'm just putting things randomly around to simply show you how BSP can be used. Because of this, we don't really want to do too much in here at the moment. So I'm just gonna leave these random elements around the place, simply these two, to just remind us that there are some things we want to do with the level once we have more mechanics set in place. But before setting any weird level formation, we always want to have the mechanics first. So let's close this up, this little level, by giving it some constraints on the walls. We don't want the player to fall. So I'm gonna make the map slightly bigger, because I feel like it's kind of small at the moment. Okay, always make sure, no. If you misclick anytime, you can simply press Ctrl Z and it will go back to your last selected thing, meaning that I don't need to re-click everything, I just simply press Ctrl Z. So we have this over here. I'm just gonna do something a little bit more simple but yet fun first, and then I'm going to move away from setting up the level. I just wanted to have the player, instead of starting here randomly in the center of the level, I wanted the player to start here on top of this cylinder. Just as a way for the player to check on the objects around the place. There we go. If I press play, I am starting on the cylinder, and I can see the other 2 cylinders, which kind of tell me what I kind of need to do in the game. You can play a lot with how the player starts and different view points within your game to make things more understandable for the player. But apart from that, awesome. So let's create some constraints for the map itself. I was thinking having a box could be a little bit boring because it's always not that interesting to have walls, especially when you want to have a level that kind of needs to simplify a forest, something opened. So instead of simply having borders, I'm going to have this as an angled area that cannot be reached by the player. The player will simply fall down once he tries to climb it. So to do so, we can create static mesh ourselves. I'm going to go into place actor, into the box. I'm going to enlarge this like this. Again, let me actually do this because I'm saying I want to do it, but I haven't done it so far. I'm gonna change the grid to 100, and I'm going to move this object. As you can see, it's much simpler to be precise with this. And there we go. It's not precise here, it's because I didn't align it here. Yep. So one other trick, interesting trick actually. Let me go and select. So imagine that you're in this situation. You want to move an object that is pretty big, but its pivot point is all the way over there. I've showed you already that you can move the pivot, but to simply put the pivot exactly where you're looking, what you can do is you can go here in this position, you can hold down Alt and you can click the mouse wheel button, and it will simply put the pivot as close as possible to the position of the mouse. It is putting it here even if I'm clicking it here because it is scaling based off the grid snap. So if I put it, for example, at 1, it will snap exactly where I'm clicking. If I put it at 5, it will snap pretty closely to where I'm clicking. If I put it at 10, it will snap to the closest cube unit, vertices of the cube unit. So if I'm pressing it here, it will snap here. If I'm pressing it on these 2 little cubes, it will snap there. So 10 is usually the best to actually go for the pivot. So again, I'm pressing the pivot here, and then I simply move this guy here, and bam, I have the entire object moved. Everything is aligned. Maybe I have gone too far. I'm not sure. Let's see. I am assuming that this is not all the way out. This is why this little space is left. You can do this as well as here. So you press here and then you simply drag out. Yep, that was the issue. Okay, so I go on select again. I press on my newly created object, and let's give it a little bit of a slide per se. So I'm going to change its face. Oh, not the foliage. All the way down. Make sure it's, let's do 50. And I'm going to be moving it like this. Let's not make this too big, doesn't require to be too big. And now I'm going to select this vertice. Okay, it's not following what I'm saying. Maybe, yep, I need to be in brush setting. Okay, we click in brush setting, we click on these vertices as well as this by holding down Control. I'm now highlighted both of them, and with this I can change these 2 vertices and I can simply move them up and have this sliding effect. I want to have it like this over here. I want to press on this vertices, and simply go down, and we have this this angled object. One last thing I want to do is make sure that it is not this deep, this angled. So to make sure it's not that angled, I simply choose both of these and I simply pull them like this. Maybe more. Okay, so like this. We can make sure that the player cannot walk on it by simply going into the play mode and simply trying to walk up on top of it. So we can see the player can do this quite simply, actually. So to fix this, there are different ways. I'm going to go for the simplest one, but if that's an issue later on, we're going to change it later on. I'm going to go into the BP player character. I'm going to go into the capsule component, character movement component. And by scrolling down here, we can see that there are different type of settings. General settings, walking, and what we are actually interested in is walking, because here there is a variable called walkable floor angle, and this is the angle at which our player can actually walk on top of something. So I'm assuming this angle is about 45 degrees, which our player can actually walk on top of. If we do 30, we compile and save and press play. I'm assuming our player cannot go on top of this. And as we can see, our player cannot even try to jump on top, to climb this object. Awesome, this is pretty much what we wanted to do. I am now going to, because this is going to be used for this area and this area as well, I'm going to convert this to a static mesh. So again, pressing on it, create static mesh. I'm going to call this slope. So sm_slope. It's going to go into the static meshes. Awesome. And I'll simply copy and paste this around. I forgot to change its pivot, but it's not essential because I don't actually mind this too much. I'm simply testing stuff around, so it's fine. Other little trick by using the elements I've shown you before. So let's make sure that this is exactly in the angle. Okay, what you can do here is this. So I'm gonna line these two together, and then you can press while you are inside an angle of an object, E, and then you can simply rotate, and the E rotates the entire object based on that angle itself. In this way, you can simply, as you can see, rotate the entire object. And I've also just realized that I may have needed another object. Again, this is why you will want to make sure that everything is specifically following a structure, because if I created this map using 3x3 pieces, I could possibly think, okay, I want this to be 9x3, so that it covers, let's say that the entire map is 9x9. We want this to be 3x9, and then this one would have been 3x9 as well, meaning that it would have covered perfectly all three parts of the map. It's not doing this because, as I said earlier, I've just created a random floor, which, to be honest, we can actually change here so that it does not cause issues. But again, we are trying to fix a mistake that we have done. We are not. It's not like we can, simply because we can fix it, we won't call it mistake. But okay, so I've changed the sides of the map to make sure that this fits correctly. I'm going to do the same trick I've done before. I'm going to, first of all, let's copy this object. I'm just gonna use the pivot thingy to make sure that I can pull it all the way over here. I'm going to bring down the snap sides to this, snap it into the angle, and then simply rotate it by 90 degrees. Awesome. So in this way, we kind of have some blockage happening on the map. Let's move the door slightly on the left, maybe. Maybe you want the level to be done over here. For the door part, we don't know what's gonna come next, so this is why I'm not really using a landslide. The slope is going to be kind of like customized for this, so for now, let's leave it like this. And let's just create a simple cube, pretty big cube, for the angles. So I'm going to position this over here. Okay, that looks perfect. Yep. I'm going to move it up. Sorry, move sides it around. Make sure that it fits these two guys. So modes, brush editing, pressing on this all the way over here. I should not be using the 5 grid snap sides, but it's okay. Again, I'm not changing these values because I'm trying to be as concise as possible. And if I try to change everything to my please, I'm gonna waste a lot of time, mainly because my computer at the moment is struggling to handle all this static mesh morphing. But make sure you always make it so that you're working at the most optimal conditions. So I've created this object. I'm going to now move, copy paste this over here. Thanks to the 50 snapping, I can be much more precise. I don't really need to check that this is perfect because I already know it is. And awesome. So I would pretty much call this a level in itself. Doesn't look too bad. We can put some decorations on top of these too. For example, some trees or maybe some bushes, sorry. And of course this part is not being done, but for now we're just gonna ignore it because we don't know what's gonna come next. So we are just simply going to leave this blank. And okay, so we kind of have something going on over here as a level. So this is pretty much done for BSP brushes for now. Of course, we are gonna use them throughout this course because these, as you can see, are very useful to create whatever we really want or need for our game. But for now, if you want, you can play around with different shapes, with different sizes of things, and try to create your own little thing. Apart from that, the BSP section is over. Next, we are going to be working on fully complete our game that we are currently doing. And by this, I mean having the door open and close based on some conditions that we're going to set up in the level. So remember, we want to make sure that this tree, for example, is colored. So to do so, we are going to program that within a system. And overall, we want to make sure that this game is pretty much finished. So we're going to go over all the different things that we may need in order for our game to be played from start to finish. So thank you for following through this lengthy BSP brush video, and I'll see you in the next one. Goodbye. Okay, welcome everyone to this new video tutorial on Unreal Engine. In these next videos, we are going to make sure that whatever we have created so far is going to actually become a fully fledged game. Let's do a quick recap of what we have done so far. So far, we have set up a game mode so that we have a player character. We can walk and look around with this player character. There's also a mechanic that we have introduced, which is picking up a color and assigning that color to white surfaces. And we have also created a little level in here that we are going to be using for a little demonstration or demo of what our actual game will be. So what we are missing now is the possibility to have a level and possibly finish that level so that there is a little bit of a gameplay loop going on. So that the player can enter the game, play the game, and then exit the game once he has finished playing. So the main thing we are currently missing right now is having a door which actually is closed so that there is a goal for the player to try and achieve, and having a condition within our level that the player needs to follow in order to open said door. Before we go any further, I just want to make sure that everything in here is a static mesh, because I want to have the possibility of coloring everything white, mainly because it's kind of what the overall concept of the game is. Everything should kind of look white-ish, a little bit like other games that have tried to recreate a little bit of a specific aesthetic for themselves. So let's first transform this, and these as a static mesh very quickly. So I'm just gonna click on here, go down into brush setting, create static mesh, going into static meshes. I'll call this land, sm_land. So we have that over there, and I'm going to create this. I'm just gonna call this corner So SM corner, and going to put this in static meshes. Okay, awesome. I'm just gonna delete this because, again, actually, I don't need to delete this. What I can do here, I can right click. I can, let me see if, oh, there you go, it's here. Replace actor with, and then I'm going to go here into static meshes. I'm going to highlight the SM corner one, right click, and then simply replace the SM corner with the corner I've currently highlighted over here. So in this way, it is now replaced. The object that was there, it's not there anymore, and now I have this object instead. I'm just gonna do something. I've talked about trying to block the possibility of having things behind door, but I feel like it's probably better if we just make it so that there is nothing. I'm just gonna make sure this is online. Nothing behind the door, so that there is the possibility of actually having something we can play around with. So if I do something like this, awesome. I'm just gonna cover these. I can probably use the cube itself and slightly stretch this. This is not really good practice, but I'm just gonna do this for the sake of. Actually, I can do this instead. Much simpler. Okay, awesome. So in this way, the door is currently in front of this place, and in order for the player to go over to the next level, he shall need to open the door first. Just gonna make sure everything is aligned. There is a slightly, oh, this one is not perfectly aligned. Oh, I see. I have to put it at 5. And there we go. Awesome. So this is perfectly aligned. There is no thing that we can see through. No little holes. Okay, awesome. And we can put a little bit of an extra land here, but that's for afterwards. So for now, we have our little level over here. I'll press play. I'll look around. I'll see things around me. Again, always remember to put collision on all your static meshes. So I'm just gonna do that really quickly. I apologize for the downtime. I just want to make sure that everything is perfect as we need it, so that we can continue with creating our little game. So into project default, use complete collision as simple, and then simply adding a simple collision will do the trick. Actually, this didn't even need complex collision. This is just a cube. So we can use the project default ones for this. And for this, the blend is probably the same. I don't know why it's positioned like this. It's probably because of the pivot. Yes. But basically, so if it's always a simple simple shape like this, what you can do is you can simply add the normal collision. So add a box simplified collision, as you can see, and in this way it auto adapts it to the static mesh that we currently have, and this way I don't really need to do anything because the collision is already applied, so no need to have the project change the project default one. Okay, so we have completed this little setup from the other level. These I'm just gonna leave like this for now because I don't even know if we're gonna use them. These were mainly just to show off the potential that BSP brushes gives us access to. I'm just gonna put this on the ground. Okay, so let's set everything for what we want to achieve. Again, we want to have it so that if the tree is colored exactly as it should be colored, then we want the door to open up. So I'm just gonna put the tree in a good spot. So probably in front or close to the door would be a good idea to have the tree there. So I'm just gonna align it to cubes. Have a cube over here. And the other cube over here. I can move it from the white as well, although it's going to move based on the pivot, so it's just going through the... Okay. Through the floor. Okay, awesome. So just wanna move this, be geometrical. kind of. Anyways, let's not waste too much time on this. Okay, so if I press play, I'm just gonna move the position of the player as well. I can pick up the color, I can put it on the leaves, I can pick up the trunk color, I can put it on the trunk, and now the tree has been completed, and through this, I would like the door to be opened. So let's first have a component for the door. So let's first create the actor for the door itself. So let's go in blueprints, let's right click, blueprint class, let's call this actor, and let's call this BP underscore door. Awesome, just gonna save everything first, just for ease. Going into BP door, I can simply, as soon as it loads up, I can simply add a static mesh in here, call this door static mesh, or simply door if we want to be faster, but it's whatever. And find the door static mesh in here. So I'm assuming it's this one. Yes. Is it? Why were there two of them? I don't know. Okay, so this is the one that we are currently using. Awesome. So the only thing I need to do now is I go into blueprints, I highlight the door, I right click on this, and I simply replace it with the door. So now this is an actor, it's not a static mesh anymore. This means that we can give him logic in order to have things function like we want them to. So in the event graph, actually, let's first create a... So I'm just gonna rename this as door arc. And I'm going to add a component, and I'm going to simply call this door. First static mesh, of course. And then I'm going to call this component door. And I'm going to make sure that this component is not a child of the door arc, because that's not what I intend this to be doing. I'm just gonna give him a cube static mesh for now, just for ease. Let's change it with the other one. And let's give him a white material. Awesome. Okay, I'm just gonna scale this a little bit, just to make sure that it's aligned with the door itself. Don't worry too much for now. We can create an actual door arch down the line. For now, just for simplistic use, I'm just gonna do it this way. So, okay, we have now a door that blocks the player from passing through the level. So as you can see, the changes have been carried on. So if I now try to go to the next level without finishing this one, of course I can't, because everything I'm colliding with this piece of door. So let's save. What do we want to do here? It's very simple. Because we want our code to always work with as many things as possible, we want to make sure that there is a underlying structure to things that make it so that the code is as generalistic as possible. What do I mean by this? This door is going to be the main actor that is going to control if the condition of a specific level are met. If those conditions are met, then the door is going to open up. The condition in a level could vary. It could be something along the lines of, okay, so we do know that we want the tree to be completed. So the tree is going to have a brown color on the trunk and a green color on the leaves. But we cannot have the door control every single object in the scene and make sure that the colors of said objects are right. What we can instead do is have the object tell the door if it is currently completed. So the tree knows that to be completed, his trunk needs to be of this color, and his leaves needs to be of this color. So let's go into the tree. Let's try to make this happen first. So let's create a boolean, and let's call this mi colored. So this boolean will apply to every single tree in the scene. So if I have three trees, this one is going to have a boolean called mi colored. This other one is going to have that boolean as well, and this one is going to have that boolean as well, but they are going to be independent one from the other. If I complete this tree, his boolean is going to become I am colored true, but this boolean will not be touched. So this tree will still be uncompleted, of course, as well as this. So let's go into the tree. Let's put the I am colored to public so that we can see it in game. So just as a quick, a fast way of showing you this. Oh, I'm just gonna delete this. That was a remnant of the other levels. So I'm going to press on this and I'm going to go into default. And as you can see, I am colored is currently false. If I set this to true, and then I go into this other tree, as you can see, this tree has still it as false, meaning that all these booleans are independent from one to another. So with this idea in mind, let's make sure that the tree itself knows whenever he is colored or not. Let's put this into the eventic for now, because we don't have a structure of the code that lets us control the state of the tree when we need it to be controlled. So instead of having a really complex structure, I'm going to instead check for the completion criteria inside the eventic, meaning that I'm checking every single frame that the tree in this case, every single tree, is colored. So let's go in the eventic and let's ask if the trunk and the leaves are of the specific color they need to be. So let's get their material. Let's access their material. And let's ask him if this material is equal to, and let's find the trunk material. Okay, so in this way we have a logical node that lets us know that if this condition is met, it's going to be true. If it's not met, it's going to be false. And this is the first one. Let's test this out, shall we? Let's create a print string. And let's feed into the print string this boolean variable. This means that now I'm going to, of course, link this to the eventic. This means that print string is going to be called every single frame. And I'm actually going to give him as the duration, the duration of the frame itself. So if the frame lasts for 0.0001 seconds, this means that the print string is going to last for that long. In terms of practicality, this means that instead of doing something like this, where the print string is going to last for 2 seconds and it's called every frame, meaning that it's going to clutter our left side, it's going to instead refresh every single frame, meaning that I only have it up there on the left, and that's it. You can see it's being called 3 times because, of course, we have 3 trees in the scene. Every single tree acts independently of the other, but they all share the same code, meaning that I need to make sure that whatever is happening within their code is generalized so that every single tree can act independently, but still follow a generalized structure to them. So we now see that it was saying false. So if we want to check to make sure that this is working, I can go into the game, I can pick up this object, I can give it to any of the trees, and as you can see in the top left, now it has become true, because one of the trees has become, his trunk has become true. But of course, that's not the solution to the puzzle. We want the puzzle to say, oh, we want to check that all the trees are colored. So we go back into the tree. We have asked him if the trunk is colored. We are now also going to ask him if the trees are of the right color. So I'm just gonna simply copy this with the Ctrl+C and Ctrl+V, paste them here. And I'm going to change, so we're getting the material of the leaves. I'm going to change the equal material to the one of the leaves instead, so that we are checking if the material of the leaves is the same as the material that we input here, which is the one that of the leaves, the green one. And now I'm going to go into the print string. I'm just gonna, actually, let's remove this. We know that the trunk isn't working. Let's make sure that the leaves are working as well. Okay, so let's check the material really quickly. Let's make sure the clutter is not there because, you know, it's pretty annoying. And now let's pick up the green color and let's put it on a tree. And yep, as we can see, it becomes true. If I put it on here, it becomes true over here. And if I put it here, it becomes true there. Awesome. So we know that to make sure that the tree is colored, both of these need to be true. So let's create an operator called AND. So the way this works is that if the first input that we give him here is true, and the second is true as well, then the output is going to be true. If any of these two are false, then the output is going to be false. If both are false, of course, the output is going to be false. And we're going to put this into a branch. And after this, I'm simply just going to print a string just to let you see that everything is working correctly. Save. And let's press play and go back into the scene. So what's gonna happen here is that as soon as one of these three is going to become true, it's going to have both of its color right on himself, then we are going to have the true appear in the top left. Let's test that out. I'm going to put the leaves color there. I'm going to pick up the trunk. I'm going to put the trunk there, and yep, it's saying, it's saying hello because we told him to say hello over here. So we know that this is working. Now, if I remove the colors, it goes back away. It's not there anymore. If I put the trunk there, nothing happens. If I swap colors, nothing happens. But if I put the right colors on here, for example, it says hello. If I put them here, it says hello again. So it is working exactly as we want him to work. Awesome. So instead of printing a string, the only thing we want him to do is setting the IAmColored variable to true. This means that we now have a variable that constantly checks if any of the trees in the scene are colored. Now, let's first remove these two because for simple ease, I'm just going to remove them and then we can later on try to add more of them. For now, because we only have two colors in the scene, I would probably think it's better if we remove the other two because we are never going to be able to color all of them. And now let's go into the door and let's create the logic in here that what it needs to do is it wants to find the tree that it is inside the scene and check if that tree is colored. If that tree is colored, then the door can open. If it is not colored, then the door closes. Okay, so let's go into here. Let's create a variable. Let's call this tree reference. And I'm going to show you a new type of variable, which kind of links to Unreal in itself. If I go in here and I look for the BP underscore actor, no, sorry, not actor, tree, I can choose as a variable the tree itself. This means that in this way, I can store a reference to any BP3 actor that I'm going to put within this variable itself. What does this mean? Very simple. If I put this to public, I save and I go back to my level. If I press on the door, you can now see that the door has this variable, the tree reference variable. To populate this variable, we can do it in different ways. We can do it through code by assigning to this variable the tree reference itself. So the way you would probably do this is you would try to set it, and you would, for example, find the actor in the scene, or we can even use the line trace that we have created beforehand and use the hit actor reference. So this hit actor reference is going to give us a reference to the actor that we have hit. For now, we don't need this. I'm simply going to do it in the simplest way, which is we click on the actor that we want to change the tree reference variable of. I'm going to click on this weird looking tool, the one next to the magnifying glass, and this is the picker. And as you can see, if I aim it anywhere apart from a tree actor, it's not going to let us click it because the variable is specifically a BP3 variable. So no other variable apart from a BP3 variable can be set within it. So I'm going to hold, I'm not holding anything, I'm simply going to click on the tree itself. And as you can see now here, I have the cube variable within my door. This means that now the door has a reference to this tree, and anything that happens to this tree, the door will know about it. Therefore, if I ask the door to make sure that the tree needs to be colored to open it, I can now do so. Let's do that really quickly. So let's have a reference to the door. Let's first understand how the door opens and closes. Let's put two states to the door. So if the door is opened, that means that it should kind of disappear. So it should not be there anymore. To do this, we can do it in different ways. Let me, hidden in game would probably work. So let's use the set hidden in game function. The collision may go through. This is something I need to check first, but for now, let's stick to this idea. So think about this method as something that hides something in the game. In this case, the thing that we are trying to hide is the door itself. And let's simply put this into the eventic and put on new hidden true because we want to hide it, and propagate to children to true because, I mean, why not? If the door has any children, we want to make sure that they are hidden as well because, you know, they are probably part of the door. So for example, the handle, we want that to be false. So we see that the door is now currently getting set to false. We cannot see it, but we can still collide with it. So this method works in the sense of hiding the door, but it doesn't work on blocking the door in itself. Let's think about a different method that can completely remove an object from the game. So let me think. Maybe we have a... We could of course remove the collision from the door, which is another solution, but I'm mainly trying to think of different methods that we could use in order to achieve such a thing. So if we want to remove the collision, we could probably simply go on set collision enabled and set the collision of the door to no collision, meaning that if I now press play and I go within this, now I can pass through. But of course we are using two methods, which could arguably be a little bit more convoluted than it needs to be. I would suppose for now it's fine, so let's leave them like this. Let's actually do something much simpler, much cooler, which is creating a method for both of these methods. So I'm going to highlight both of them with my mouse, right click and press on collapse to function. I'm going to call this function open door, and in here, as you can see, it has simply created a node, a function of the other two methods that we were using. In this way, anytime this gets called, this two gets called. It's just a visually way of putting it. It's kind of like anytime the node goes within here, the execute pin goes within here, it goes in here, and then this opens up, they go from here to here, and then they return as well. Let's put a return node just for ease of visuals. So in this way, we now know that after it has gone through the set collision enabled, it goes out of this. Okay, so awesome. Now this method lets us open the door. Let's create another method to close the door as well. To do so, we simply copy paste these two. We go in here. I'm going to copy, sorry, I don't need to copy paste, sorry. You simply go press on open door and you do Control W, and Control W, what it does is literally duplicates things. So we have duplicated the method. I'm gonna call this close door, and what we want to do is that whenever the door is closed, it's not hidden and its collision is collision enabled. So the collision exists and the object is visible. So if we want to test this out, we can simply do it here. Close door, compile, save, play, and the door is closed. If we want to open the door is opened. Let's make sure that the collision works whenever the door is closed. So I'm closing the door. I'm going to this. And yep, I cannot go through it. Awesome. So after this, what we want to actually do is the thing I'm actually doing with my mouse itself. So I'm currently switching between closed door and open door, but we want to switch this based on a condition. So let's move this a little bit on the side. Let's create a branch, and let's connect this to the branch and put, if it is true, then we open the door. If whatever the condition is false, we close the door. And now, as the condition, we are going to simply use the, as you can guess, the one within the tree for reference itself. So remember, if this tree has the IAmColored variable to false, then that means that it is not colored correctly. If it is to true, that means it is colored correctly, as it's shown within here. So let's access this variable from the door. I'm picking up the tree reference that we have set up here. This is equals to this one. I'm going to drag this out, and I'm going to access the IAmColored boolean. And this way, I am accessing the boolean that is now currently within this tree. So I'm accessing this boolean over here. And I simply need to link this to the branch that I have created beforehand. And in this way, anytime the IAmColored variable is true, the door will open. If it is false, the door will close. So let's see this in game. I'm going to press play. I'm not gonna try to color the tree first. I'm just gonna show you visually how it looks like. I'm gonna press on the tree. I'm going to manually change the variable IAmColored. Now it is false, so the door is closed. But if I put it to true, the door is opened. Of course, this is done manually. So let's do this again within the game as it's supposed to be played. So I pick up the green, I put it here. I pick up the orange, I put it there. Oh, it did not open because the colors are wrong. So let's pick up the color again. I'll put the color there because why not? It's white. I'll pick up the green color, put it in the leaves, pick up that color, put it on the trunk, and as you can see, the door has been opened. And now we can go through and die in the void that is beneath us. Okay, so as we can see, we pretty much have a little bit of a gameplay going on here that the player can follow in order to open doors and overall try to finish the game. So I'm gonna end the video now here, and in the next video we're actually going to go through a lot more interesting stuff that we can do in order to create a finished game. So I'll see you in the next video, and feel free to play around with some of these variables. If you want to create more tree, feel free to do so. Maybe you can understand how they work differently, because just as a quick example, if you create different trees, the door will still open every time I complete this one. If I complete this one instead, the door will not do anything about it, because you know it doesn't really like doesn't really care about this tree. Also, one thing I've noticed, which I really want to address quickly, is this kind of a bug where if I is it me or I cannot pick things up anymore? Oh, I picked up this color. Okay, I see. We need to remove this color. It is screwing with my head. Let's put it there for now. We need to create a little bit more things to polish this up. But for now, so if I color this tree, the door opens. But if this tree is not colored anymore, then the door still remains open. Why is this? If I go into BP tree, actually, let's go first in the BB tour. We say that the code here is fine because it is asking to the IAmColored boolean if it is false or true. If it is false, it should close the door, which we know works as a script. So the issue, it's of course within the tree blueprint, specifically the one that controls the IAmColored function. So why is this happening? Because we simply forgot to put the false function here. Whenever this is false, this logical construct, we want the IAmColored function to become false as well. Just simply gonna do this really quickly. So if I pick this up and I put them there, it is open. If I remove them, it is closed again. Oh, I did the other thing as well. Because what's happening is that I'm picking up the default material color, which is extremely weird to do. This one is still a brush that we haven't put the collision of, so there is a little bit of stuff going on. Let's go fix this really quickly. I said I was gonna end the video, but I want to address these really quickly before going through anything else. This has a weird shape, so I'm just gonna add a complex collision to it in this way. Use complex collision and saving this, so in this way now it should work. To simply test if it is working, yep, I can just simply pick up his color, and yep, it is, everything is working correctly. Okay, so what are we going to do in the next video? I'm going to finalize a little bit of the scripts so that they can be put within a normal build, and we're actually going to build the game itself. As a brief introduction to what a build is, we are going to make sure that the game can be run not in the engine, but instead from a simple, like a normal software, where you simply click on the execution file and it opens up the game for us. So we are going to prepare our game to make sure that we can create a build of it, and we are going to leave everything as it is for now, and anything else, any bugs that we may encounter, we can try to fix together. So thank you for having followed the course so far, and I'll see you in the next video. Welcome everyone to this new video. As I've said previously in the last video, what we are going to do now is mainly prepare our game for the builds, for being actually played by a user. So without further ado, let's address some little issues that we want to fix within our game. Let's add some more features possibly, and overall let's finish this up. So right now, as we can see, we have the possibility to pick up colors to put them in place, and by putting them in place the door opens. This is perfect. There is a little issue where if I pick up a color and then let's say I walk around for a little bit, then I will probably forget what type of color I'm currently holding, which could be slightly annoying based on different factors. So let's try to fix this at this moment. Let's go within the BP player character and let's think of what we want to do. So the idea here is that whenever I press play, I would like to have some type of reference in my screen that constantly shows me what I'm holding. We can do this by simply maybe going to the player character, add a component, let's put a static mesh, and let's call this picked color. Let's compile it, save, and then let's put this as a cube. Okay, let's use the smaller ones, awesome. Let's move this forward a little bit up, and then let's use the white distance. Awesome. So I'll briefly try to explain what I'm doing here. So I'll compile, let's save, and then I'll press play, and as you can see, there is this weird white cube that is following me around. I want to make sure that it is a parent of the camera, so that it rotates with the camera itself. So this means I have this little guy moving in this way. And now I want to move this a little bit here, maybe on the side, and a little bit down. There we go. Compile, save, and okay, so maybe it's a little too big. Let's make this guy smaller, move it a little slightly on the right. And okay, so I'm positioning this in such a way that anytime we pick a color, I'm thinking of changing the color of this cube to the one I have currently picked. In this way, the player has a better understanding of picking colors overall, and has an understanding of the cube, you know, what color he has currently picked. We could do this with a UI, but that's something I would like to leave for later, because it requires a setup of its own. For now, let's use this cube. So the cube currently is white. Let's go into the event graph and try to understand what we need to do in order for this color to change based on the color picked. Well, this is quite simple actually. We already have our variable over here called color picked, which will contain any color that we are currently holding. We simply need to use this variable and link it to our picked color static mesh, and change the color of picked color static mesh with the color picked. without further ado, let's do this. Let's think when this should be called. So anytime I shoot, let's see where we change the color picked. It's happening here, and it's happening here. Okay, so this is a good way to show you how to better optimize your code, how to make it more efficient and cleaner. So we see that we are currently setting up the variable in here and in here. If you're not sure if this is happening anywhere else, we can simply click on find result, right here color picked, press enter, and this shows us every single instance of the color picked itself. We only care about the set, so let's write down set. So there are two instances in the, not simply in this blueprint, but every single blueprint in the engine. So if I double click here, we can see this is the first instance, and if I double click here, this is the second instance. Awesome. So we do know now that we are setting color picked in here and in here. So let's create a function which is going to contain the color picked, the set color picked, but it's also going to change the picked color, static mesh color, anytime we set the color picked as well. In this way, we avoid completely the issue of having a code that has holes in it. You know, if for example we had set color picked somewhere else, we would have and we would have only done it maybe here and here, we would have encountered issues that later down the line would have been troublesome for us. So let's right click this and let's collapse this to a function. Let's call this function set color picked. And as you can see, because the get material was inputting inside the color picked his own reference, when we right clicked and collapsed to a function, he actually remembered that we were giving him this variable, and it created for us a variable in this way that is now connected to color picked. If we want to do this manually, all we can do is we can do it like this. So I'll just remove the variable for now, compile and save. I'll go within color picked, and there are different ways we can do this. I can simply drag any variable that I care to input in our method and simply release it here. But another way to also do it is by simply clicking on the purple method node. And in inputs, I can simply click on new parameter, and from here I can decide the parameter that I want to have as an input. These parameters are pretty much just a continuation. These are inputs that we are giving to the method in itself. The outputs are these other parameters that we see on the right. So if I create an output, which can be created within the return node. So let's create the return node. And we press plus. So this is an output parameter, and this is how it looks like within our function. So as you can see, this is the output and this is the input. Let's remove these two because we don't need them, and let's simply put this here. So it has been set. I can even unlink them. It's not an issue. For now, this means that as an input, we can give him specifically a material interface object reference. And the material in itself is going to be this. So I'm passing it to the set color picked function. Now, in the set color picked function, of course, we want to set the color picked to the one that we are passing But as well as this, we want to change the picked color material. My bad. The picked color material to the one that we're currently giving the color picked. So to do this, we'd go on picked color, we write down set material. Awesome. We connect this to this node, we connect this to return, and now the material that we're passing him is this. As simple as that. Now we can use this method that we have created here as well. So basically what's happening here is that instead of simply doing this, what we are doing is this entire thing, which is going to set the color picked material to the one that we're passing him. So if we're not passing any material, then that's completely fine. As well as we are giving him we're changing the picked color static mesh, which is this, to the color of the material that color picked is. Let's delete this because it's already being called inside set color picked. And because we know that this is whenever we are giving away our color, we do know that the color picked is going to be null. Because we don't want the color to completely be null, because in that way that means this guy is not going to have a material, which is going to look like this. Because we don't want that to happen, we are going to set the color to white instead. So let's go in here. And after the set material has been done here, we want to set the material of the color picked to white. Which, as if you remember, is not going to be an issue because we are still checking if the color is white or not. And if it isn't, then we do our code. If it is white, then it's simply going to ignore it. So it's pretty much going to be the same thing for us. So color picked, it's going to be white, as shown in here. Making sure I've clicked it. And in here instead, we are going to have the color picked being the one that we have hit the object with. So if you recall, this is the color picker action. So let's test this out. We currently have this cube on the right. I'm going to change these positions soon because it kind of looks out of position. I'm going to right click and bam, it has become green. Now I can give it back to him and now the cube is white again. I can do this with this as well, and so on and so forth. Oh, we now can also see that we have eaten the color of this column. Again, this column cannot change color. It did not become white simply because currently it is a brush, and brushes, as you recall, most things of them don't really change within our game. So I've picked this color now. I'm just gonna give it to the door because why not? So if I right click this, as you can see, it becomes white. And awesome, so bam. In this way, we can open the door and go through it. Okay, I'm just gonna change the cube slightly because I don't really like how it's positioned. Maybe I can fake this being some sort of pistol or gun of some type. There we go. Maybe this can be cool. Nice. So we are shooting and picking up color in this way. Slightly to here, slightly forward. Just playing around with position so I have something I'm quite satisfied with. I feel like this is a good position for now. Let's leave it at that. Okay, so awesome. So now we know we have this thing going on where we know now what type of color we have in our ends. What else do we want to do? Let's see. So maybe we do want to remove these colors. We want this to be white. So let's make sure that that's white as well. So the door arc. Okay, let's change this to a white. Okay, perfect. And let's also create a static mesh, which completely engulfs this. One thing I would like to say is that we can do something neat here. Okay, so let's create a static mesh for the door. So if you recall, the way we created it beforehand was we had a cube like this, and then we added on top of a cube, I think it was a cylinder. Yep, I think that was the case. We just need to make sure that the sizes are the same so that they are perfectly aligned one with each other. Don't remember the outer radius of which one I set up. I think it was 120. I may be wrong. In any case, we simply need to follow the sides of the door. So maybe let's say 60. Too little. 100. Yep, it was 100. So perfect. So now I am going to go into the brush editing mode. I'm going to press on the different faces. So, you know, by simply holding down Control, I can decide multiple faces from different objects. And I'm simply going to scale this down like this. Going back into select mode. I'm going to move this around a little bit so I can make sure that it is perfectly fitting, and it is. And then I wanted to do something slightly cool, slightly cooler, let's say, not completely awesome or anything like that. But so what I was thinking was that because everything is white, I would like to have some slight differentiation between the door and the arc itself. This, I thought of doing it with changing the sides of the door itself to be slightly thinner than the hole it needs to fit in, so not completely perfect. Let's see how to do this. So I feel like we should probably simply just change the faces if it selects the one I need. Okay, awesome. 1 and 2. Awesome. Then 1 and 2. Let's make sure. 1, 2. Awesome. And then 1 and 2. Okay, so these two now are slightly thinner than the door. So if I try to press them together, they kind of leave a little bit of a hole. We can see this better by simply hiding the door here. So if I go into the detail panel and I search for visible, that untick that, it simply makes the door not visible anymore. And as you can see, there is a little bit of a hole to the entire thing, which arguably some people may not like. I feel like it's fine, so I'm just gonna leave it like this, just to indicate to the player that these are two entities, one different from the other. And okay, now that this is done, always remember to make sure that the pivot is correctly where you want it to be. Let me just make sure. Yep, as I was actually seeing, this is slightly up. Let's fix this way. Awesome. And let's change the pivot to make sure that the pivot is the same as the door arc, which is arguably in the center of this thing here. So I'm just gonna go. So we remember that these are 10. I'm gonna pick the 10 one, and then 1, 2, 3, 4, and 5. So this should be in the center. Okay, awesome. I'm gonna right click, pivot, set as pivot offset. So this is now set. And now, while selecting both the brushes, I'm going to go into create static mesh, and I'm going to call this SM door. I'm going to go in static meshes. I was hoping you would have made me redone it. Substitute it, but it's not working. So I'm just going to do SM door _1. I'm going to go in static mesh and create static mesh. It's already a process you've seen, but the more you see this process going on, the much it enters in your head much better. Like, the more you do it, the more you will remember about it. Something that you need to do several times to remember exactly how it works. I feel like the simple applied box collision is completely fine with this, because the player is not really going to reach this part anyways whenever he's in the game. So blocking it's completely fine by me. So I'm not gonna give him the complex collision. One thing to remember is that complex collision uses more faces in order to calculate collision, which arguably can become much more heavy on the CPU and GPU. So you probably want to make sure that the collision itself is as simple as it can get. It has as many little faces as possible, because this makes the processing of the collision much more quicker for the engine, meaning that you will have a much more stable FPSs in your game. Of course, with some objects this is fine, but the more object you use that have complex collision, the bigger the issue becomes later down the line. Okay, so now that this is a static mesh, the only thing we need to do, I can simply delete this. Let's go into the BP door. Let's put this back to visible, and I simply need to change the static mesh of the door itself to be the one that I've currently created. So let's go in SMM door. Let's put the 1. And of course, as you can see again, it's having the sizes are the one that of the cube that we were using before. We simply put this to default, and we put this slightly down so that it is aligned perfectly with the ground. And awesome. So we have the sort of block edge for our door archway. Okay, perfect. If we press play, of course the player cannot go through it. We're just checking for collision. Awesome. Everything is working. The player can even color it if he feels like it, but that doesn't really matter. And then if I pick these guys and put them on the tree, this opens up. Okay, perfect. Let's remove these two trees for now, because are not needed, really. And what else? Let's have the player being able to jump. I'm gonna close all of this. So, if you recall how we created the inputs for the movement and the oh, I named these wrongs. Mouse nodes. This is for the mouse and this is for the movement. So if you recall how I've created the inputs last time, we wanted to make sure that every action has its own event associated with it, and jump is no exception. Let's go back into test level, edit, project settings, and let's go into the input. We do know that jumping is going to work very much in a very simple fashion. Anytime you press the spacebar, it's simply going to jump. So having a method that lets the player jump. So we go into action mapping, we press plus, we call this new action jump action. And then I'm going to assign as the key for this action the spacebar. Okay, now I can close it. I can now call this into my project. Let me remove this random nodes. Jump action. Awesome. And Unreal is very nice when it comes to these simple things, because would you know, he actually has a method called jump, which we can simply connect to the jump action and have it execute that event. We also have a jump stop, a stop jumping event that we want to have called whenever we release the jump button. So if I press spacebar, it's going to jump. If I release it, it's gonna stop jumping. This is not really needed. This is mainly to stop the character from jumping again in the next frame, which arguably, because it has already happened in the frame we press it, whenever we release and we stop it from jumping, it doesn't really do anything. But I just wanted to show you that there was the possibility to also stop the jump method in the case you're calling this multiple times, for example. So, of course, whenever we press jump, it's going to jump, but the jump feels very underwhelming and there is little control on the jump itself. To fix this, we can simply go within the character movement component and check here for jumping and falling. The jump at Z velocity is the actual force that pushes us up. The bigger this force is, the stronger and the higher our jump will get. So I'm just gonna put this to 600 and then test it out. And that's a pretty big jump. I feel like that's cool. And the air control is the control that we have of our jump while we are in the air. I usually like to put this at 0.45, kind of, depending on the game. But 0.35 usually feels like enough air control to change a little bit of your jump, but not too much to actually give us issues. Also, let's do something a little bit much simple. As currently the body of the player actually is giving me a little bit of issues to check what's underneath me. And I want to kind of fix this. There are two ways of doing this. We can simply push the body back so that anytime I jump, I can see my body, but it's not blocking my vision. Or another way I could do this, it's also by going into the search details and using the hidden in-game function. Sorry, not function, variable. Hidden in-game means that the body in itself still exists normally. If I put player BP here, we can see it existing. But whenever I press play, the body becomes hidden. So anytime I'm in play mode, the body is not there anymore, which some people may like, some people may not. In this case, I would personally prefer to have the body being seen by the player, just not as much as one could imagine. So I would like to have the body slightly behind the player, the camera still being where it should be, and by pressing play, now if I look down, oh, sorry, hidden in game is false. Then if I look down, I can see my body being there. It's not really giving me issues to see what's beneath me. And overall, it is still casting shadows, so I still feel like I exist within the game. Although casting shadow may actually be something you do not want. Well, there is also the option of hiding the shadow of the object itself, because as we can see, it's actually giving us a little bit of issues to check and see the object and the color of our color picker. So let's change that as well. Let's put the head and camera hidden shadow to true. So compiling and saving, cast shadow, I suppose it's the one we want to untick. So cast shadow is untrue, and now whenever we go in game, we cannot see ourselves anymore. We also want to do this for the pick at the color, because having that floating thing in the air, it's a little bit weird, arguably. And yep, now we don't have a shadow anymore, but we can still see our body, so we know we exist. We can go around, we can pick colors, and overall we can have a little bit of gameplay going on, where we pick the colors and the door opens, and we can go through it. Last thing we want to probably do is have it so that the game finishes whenever we go through the door. To do this, let's create first a little bit of an ending point to this level. I'm just gonna use a simple cube because I don't mind too much this last area for now. It's of course going to be changed whenever we create new levels and so on. So another really interesting trick, I'm gonna hold Alt and the mouse button. I'm gonna pull this back down, and I'm going to make sure that it is perfectly aligned with the base of the cube on the left. And now, if I press the scale tool and I simply scale this up, it's going to scale it only on the right, based on the axis that I'm holding, meaning that it's scaling it in that way, but it's not scaling it in this way. Doing this, it makes the scaling of this object much more simpler, and I can check and control perfectly its overall size. Okay, and now let's create a cube here. Actually, let's not do this. Let's instead create a final actor. Let's call this ending level, of course with the BP at the start. Wait, not in that way. BP ending level. And let's have this be a static mesh. Let's leave this a static mesh for now. Let's give him the cube. Not this one, this other one. No, it was the right one, never mind. So it's this second cube. Okay, let's give him another material. Let's create a new material, and let's give that material to him. Level material, let's create a new level material. M_level material. Level materials, I would say. Oh wait, I remember. The way we did this was apologies. We have white, we have the tree material. So we are going to create an instance from this, and I'm going to call this ending material. Let's give him a weird name, but this should work for now. I'm gonna leave this at black because I was actually firstly imagining this to be black. So if you recall, I'm simply creating a material instance from the level material, which gives us the possibility to change this specific instance of the material we have just created. So I'm going to give this material to this cube. So level materials, ending material, awesome. And I'm simply going to scale this to be big enough, like a door. So let's put this into the scene first of all. It's not completely aligned, but that's fine. So using the same trick as I've done before, I'm gonna do the 50 grid scale. So I need to move it only once down, because remember, this is the cube. The default cube is 100 by 100 units. So scaling this on the left and on the right. This should do, I suppose. Let's give this 6. It's fine. We don't really care too much about being precise here. And again, on the let's scale this up. This should be fine. Okay, so the idea here is that once the player finishes the level and goes through the door, there is this black sort of object. The player doesn't know really what to do. It will go into this black object, and the game will pretty much end here for now. So let's create the logic for ending the level within this blueprint. Let's go within the BP ending level, and let's go in the event graph. And in here, there is simply a one function that we're gonna call end the level. And what this function will do will simply quit the game. So the player will enter this, will click on this, and the game will simply end. So to do this, there is a thing called application quit. No, let's see, quit game. Okay, much simpler than I originally remembered. And as we can see, we can specify a player, give us a preference of what we want it to be doing, in this case quit, and ignore platform restriction, which we don't care too much what it is right now. Let's put a return node, because it's always useful to see the entire logic. Again, the return node is not needed. It will still fire after something has happened. After it has been called, it will always follow up with the node on his right. But return node is just a better way of setting this up, just so that we can see what's going on in the method itself. And we want this to be called whenever we end the game. So when do we end the game? Well, we know that the game is finished whenever we hit this object. So whenever the player hits this object. So how do we do this? Very, very simple. We go in BP ending level. We click on static mesh, and then we go all the way down the detail panel. In here, there is this event tab, which shows us every single event that can be called based on the thing we have highlighted. In this case, the thing we have highlighted is a static mesh, and a static mesh has all these events associated to it. We are interested in the begin overlap event, which if we press the green button, gives us this event, and this event will pretty much be called every single time the static mesh collides with something. So what we want this something to be, very simple, we want it to be the player. So to do this, we are going to go use the execution pin of the onComponent begin. Oh, sorry, not overlap. Just give me a moment. OnComponent hit, apologies. The overlap is anytime a collider overlaps with another collider. The overlap happens whenever any of the two colliders are a trigger. A trigger means that the collider has no collisions, but it works as a trigger in itself. I'll give you a simple demonstration in another later down the line. Overall, it's not that different from what we are currently doing, which arguably I can show you both ways. So I'm just gonna leave both of these right here. There is not going to be a difference, but anyways, let's use the home component hit. So anytime the static mesh hits another component. In this case, we want the other component, or as we can see here, the other actor to be the player. We want to end the level. So we are going to use something called casting. I'm going to write cast to BP player character, and I'm going to give him as the object that I'm casting it to, the other actor. So what is casting? Casting is a way in programming to actually access a specific class or specific class from another object, and by accessing this class we can then modify things that are based from this class itself. In this case, we are using casting to make sure that the object we are hitting with our static mesh, it's a BP player character, or at least it is associated with the BP player character class. Because we know that the actor BP player character derives from, I mean, it doesn't even derive, it is the BP player character class. Whenever we cast and the component that we have hit is a BP player character, this cast will become true, therefore the ending level will happen. If it wasn't a BP player character in the first place, the object that we have hit, then the cast will fail. And by failing, it will kind of act similar to a branch, where if the condition is true, then it does something. If it's false, then it does something else. Of course, the output here is the object that we have currently hit. So you remember how with the trees that I've showed you last time, I was talking how each one of these trees is independent in terms of code, but they all share the same generalized code. Well, this happens in the same exact way here. So whenever I can have 5 different players in the scene, and each one of them may collide or not collide with this onComponent hit static mesh. This output is a variable, a reference to the player that has hit the static mesh that I'm currently working with. So we can change and do things within the player that we have just hit, but of course this is not going to be needed for us. Casting is a very, very powerful tool, which we are going to be using much more later down the line. This is going to be essential for a lot of things we are going to be doing. But for now, because we don't mind this too much, I'm just gonna simply using this for a check to make sure that the actor that we are hitting is from the class BP player character. So if the actor that we have hit is a player, then we want to end the level. Okay, so already in this way, it should work. To make sure that this works, we can simply pick this start player, put it all the way over here so that the puzzle is already completed. We press play. We are here. I click this and it kicks us out of the game. So that's exactly what we wanted. Awesome. So it is working. I'm gonna Ctrl Z the player back to its original position. Let's put the player in front of the 2 colors, because that position kind of looks weird from someone that has already started the game for the first time. Let's put the player right in front of the tree so that he has a little bit of a better understanding of what's happening. And let's move these, maybe this one here and maybe this one a little bit more here. So they clutter the scene, but not too much, just to make it feel more populated, as not having these will probably make it feel like it's completely empty. I'm gonna leave their color to this for now, just because why not, to be honest. Although these do break the principle we were talking about earlier, where they are pretty much duplicating colors. As you can see, I wanted this to become white again, but it didn't. Instead, I picked it up. It stayed the color I picked. It stayed the same color, and now I can pretty much kind of like change the color of everything to this, which is not what we want. But that doesn't really matter for now. We are going to change these soon, and let's test the level in itself to see if we can actually complete it. So I start the game. I'm amazed by the amazingness of the art within the game itself. I'm gonna click on the right green I'm gonna put it in the leaves, the orange on the trunk. It opens up the door. Awesome, I can go through. I'm going to do black, and then the game ends. So we have a little bit of a start and ending to our game. Awesome. Let's save everything so that everything works perfectly. Let's now think about what else we want to put within our game. Okay, so I think the main thing we're missing currently is simply having these cylinders being white, so we won't have this issue of picking up their colors, but they still will retain their normal color, so we cannot like override every color in the scene. So to do this, I'm simply going to create these as static meshes, and afterwards we may call it an end to our game, and I'll show you how to finalize anything else that we may be missing. So, simply going to call this SM_cylinder, maybe? I suppose that's a good name for it. And I'm simply going to copy paste this on the same place of this other one. To do this, I'm simply going to click on this one, delete, and move this in the same place. And I suppose we can, instead of having this long one, we can simply delete this one and move this onto the side here as well. I'm gonna highlight all of them and simply change the material to white. So in this way, we can simply pick up a color and put it on these guys. Of course, always make sure they have collision. So I'm simply going to go within the cylinder and change their collision. Adding a box simplified, making sure that, yep, it needs to be a bit complex. So we see the complex shape, and that's perfect. And by pressing play, I can now give colors to these people. Of course, not to the other that are already colored. Can change the color of different things as well. So, perfect. One thing I would like to say, it's probably the idea of maybe having, instead of these cubes that are a little bit out of place, we can actually leave the colors on these two of these guys. So let's put the green on here. Oh, that's not the green. Oh, I called it leaves. And let's remove this cube. And let's put the orange on, actually let's put it on the trunk itself. Okay, so this is something interesting that we can do. If you want to change the parameters of a specific object within our scene, so I'll duplicate just to show you that it is independent. I can simply go on, for example, the trunk, change its material to the tree trunk, and as you can see, I've changed the material of this tree, but this other tree, which is the same actor as this other one, stays unchanged, meaning that we can change things based on our needs. I can simply delete this cube, and now if I go into the scene, we can clearly see that this has the color. I can pick it up, I can move it around, and by completing the tree, I can go through the door. By going in through the door, I can simply finish the game. Awesome. So I would say let's call this a completed project. Let me give the player a little bit of a platform to start in, just for, you know, the sake of having a starting point represented by something concrete within the level. I'm just gonna give him this little platform over here. Let's make sure that the collision is fine. Yep, it is fine. Pressing play, let us start the game. And okay, so this is perfect. How do we finalize something? How do we create a build of our game? This is extremely simple to do in Unreal. So what you need to do is you go into File. Once you have sure of your level, you can save everything just in case that you want to make sure all your changes are gone through. You go into Package Project within the File tab, and you go into Windows 64-bit. You press on it, and then you decide specifically a folder. In this case, I'm just gonna put a folder in here, a different one from our project folder, remember that. I'm gonna create a new folder, call this Unreal Course Builds. And I'm going to create another folder in here. This is simply done because we made different games or newer games in the other sections. Or we may improve upon this one. In any case, it's really good to just have different versions of your build. Once you are inside the folder you want your build to be in, you simply press on select that folder, and it will start the packaging process. The packaging progress usually takes some time, so don't worry if it's taking too long, even if it's such a simple game. There is also one problem by doing this, the thing I've already done, which I just realized when after pressed it. Whenever you are packaging for a game, I'm just gonna cancel this. Whenever you're packaging a game, you need to make sure you decide and you choose the levels that the game will start in. To understand what levels your game is starting in, you simply go within File, Edit, Project Settings, and you go into Project Maps and Modes, and in here you can exactly see within the default maps the one in which your editor starts up. So every time you load up your level, your editor, this is the level that he will choose. And anytime we create a build, this is the starting level of our build. So of course, right now we have done it in the good way. So we know that our test level, which is this map, is currently the starting level of our build. But if this was not the case, then all you would need to do is simply go within the game default map. That was not intentional, don't mind it. We go into game default map and we change the test level to the map that our game is currently in. Usually what you would like to do is have a menu, and this menu would contain start game, an option text, an exit button, and all of these are going to manage the different levels within your game. You could have in the starting game button different levels being shown, and by pressing on one of any of these levels, it will open up them. For now, we're not going to do this yet. This is going to be done later down the line in the next sections. So simply we are going to go into game default map, leave the test level as it is, and close this, and then File, Package Project, Windows 64 bits. We are going to choose the Section A build folder that we have created before, and we are simply going to select that and wait for this process to finish. Okay, so now that the build is complete, the only thing we need to do is go within the folder that we have created our build into. So I'm going to go in Unreal Projects, and I'm looking for the Unreal Course build, Section A. And this is the name of any build you will make in Unreal. Windows No Editor. By double clicking on it, we see these files, and by simply pressing on the X file, it will open up our game. And here you go. So currently we are actually playing our game. We can jump, we can move around, and overall this is what we have built. There is no editor in here. It's actually how your game will be played by a normal user. And as you can see, I have my colors. I cannot go through the door. And if I pick up this color and then I put it on the tree, the door opens. And in this way, I can go through the door and finish the game. So here you have it. This is actually a very simple yet intriguing idea for a video game in Unreal. We will expand upon this in the next section of this course, where we will be looking into more advanced things. So as a quick preview, we'll be moving the door itself with scripts. We're going to use things like timelines. We're going to use things like timers. We are going to insert some sounds within our scene. We're also going to create new levels and have these levels interject with one another through script. So we're going to create a menu that give us the possibility to access different levels, and have these different levels all being set up so that we can access one another if we want them to. So there is a lot of things still that we can test and create. We could also expand upon the main mechanic, which, for example, if I put a color on an object, that object gets animated, meaning that if there is a platform which is currently stuck or not moving, you can put a color onto it, and if the color that you've put on it is the right color, the platform will move, and that movement can lead to more interesting and advanced gameplay options for the player. So having a platform moving so that the player can go somewhere else and pick up a color, and then bring that color back to finish up a level, for example. So there is still a little bit of things we can do with this initial idea that we have created. So I'll salute you here. This is mainly everything we have done so far is mainly based on the build, and I'll see you in the next session. Have a good continuation of your day. Okay, welcome everyone to section B of this course tutorial for Unreal. So what we are going to talk about is mainly some more advanced blueprints that we can use to our advantage to create different situations within our level. Without further ado, I'm just gonna create a new level so I can show you more different things that we can do within blueprints. So I'm just gonna file, create a new level. I'm gonna save this level. I'm gonna call this second level for now. Saved within maps. Okay. All right, let's set everything first. Let's go into game mode and oh, he already has the game mode that he needs to be. Awesome. Let's remove this and instead let's give him the static meshes that we have created for the floor. Okay. Pretty big chunk of land that we have done. And let's start with something called timelines. Let's first create a blueprint actor. And I'm gonna call this BP underscore moving platform. And then we're gonna drag this into the area. I'm gonna double click it. And let's just populate this thing really quickly. Let's stick for something simple for now, and then we can create a static mesh for him later on. So I'm just gonna give him a cube. We are gonna change the sides of this cube within the scene itself. Again, this is the wrong way of doing it, but it doesn't matter for now. It's just to show a little bit of a proof concept. Okay, awesome. Just gonna change the snapping sides, put it down a bit. And in this way, we now have this actor. So we want to make sure that this actor can be moved. To move this actor, there are different ways of doing it within the script. I'm going to show you the main ways you can move an actor within scripts, starting off with something called a timeline. So let's right click, write timeline in here, and let's select the add timeline, and then let's call this moving platform. Or maybe move the platform, which makes more sense, I would suppose. So how does a timeline work? The timeline is a set of values, usually, that you can input within some, thanks to an execution pin. And his outputs are mainly just, usually they're used as float values, but of course there is more to it. If we double click into the timeline, we see that there are different type of variables that the timeline itself can output. So we have a float track, a vector track, an event track, and a color track. For now, we will stick with float track. So what this means is that in here, in the new track 0, the values coming from here are all going to be floats. These floats will vary based on the way we set up the timeline. So in here, we are actually inside the timeline itself. Here on the top, we can see the length, which we are going to set as 1. And by right-clicking anywhere within our timeline and pressing add key to curve float, this creates a point, which we can change the value of time and value itself to 0 and 0. And by creating another point, we set this to 1 and 1. So this is just a little bit of a setup. Just follow me through and I'll explain everything that's going on afterwards. So now we have a point that indicates the 0, 0 value. So 0 at time 0, it has a value of 0. And this point that at time of 1, it has a value of 1. Now, after having done this, we are going to create movement. So I'm going to go in the begin event, begin play execution event, and I'm going to plug this to play from start. Actually, before this, I'm going to use a node called delay. delay literally has states its name. It will delay whatever his input is by the duration. So for example, if the event begin play gets called at the start of the game, literally the first frame the game starts, this will be called. And when this is called, it will go into the delay function. It will wait 1 second, and then it will, after this has been completed, it will go through whatever else there is on his right. In this case, the timeline itself. And let's put a string in the update that is connected to the track, to the new track itself. So I'm gonna compile, save, press play. Then after a second passes, let's put 3, maybe it's better. So after 3 seconds passes, our timeline gets triggered, and it then outputs a value that goes from 0 to 1, which is exactly how we set it up in here. Perfect. Now, what do we use this for? Well, it's actually quite simple yet intriguing. What we can do with the timeline is actually move objects within our scene. How do we do that? Always remember that a specific object always has a location, a rotation, and a scale. All of these values, a location, for example, is in fact a vector tree, and the vector tree is the unison of 3 floats. The float on the X, the float on the Y, and the float on the Z. This track gives us as an output the output of a float. This means that if we can manipulate the location of an object through a timeline by changing its coordinates on the X, Y, or Z through the float output that the timeline gives us. How do we do this? First of all, let's use the method that can change the position of something, which is called setWorldLocation. And let's put this into update. The difference between update and finished is that this update gets called every time the timeline moves into a different time. So at time 0, it will have done 1 cycle. At time 0.11, and it will have a value at 0.11, and that's maybe the second cycle. And it will cycle through all of its points until it gets to 1. Update gets called every time there is a new cycle. Finished instead gets called when the timeline has finished. So if we want to move something, of course, you want to link it to the update execution pin, simply because in this way we can constantly change the position of our object. And after we have done so, we now want to get the static mesh of this object, get its world location, because this will be useful for later. And we're going to use something called a lerp. Now, what is a lerp? A lerp is technically a very simple concept. This function, what it will do is that given point A, a given point B, it will change between A and B and all its values in between based on its alpha. So if the alpha is 0, it will give us the position A as an output. If the value is 1, it will give us B. So the lerp goes from 0 to 1 in terms of alpha. If you input any other values that are bigger than 1 or smaller than 0, it will count them as respectively 1 or 0. I'll show you really quickly the output itself so that it's much more understandable for you. So let's promote this to a variable. Let's make this variable public. I'm just gonna leave it as it is in terms of names. And I'm going to right click, split struct pin, so that remember the vector is always formed by 3 values and each one of these values are float. So I'm going to use the X value to just demonstrate you this, but to be honest, it can be done with any of these. It won't really matter. And let's change the final position to be 500 and the start position to be 000. I'm going to connect the X to the string, and I'm going to connect to make sure that this to to avoid having repetition in the print string, where you know how on the left there are a lot of numbers being printed onto the screen. Last time we used the event tick output float, which is this one. But because we don't really have access to the event tick, nor we want to use it in any way, we are going to use something called get world delta seconds, which is exactly the same as this. So in this way, it will only be repeated on the screen on one single line. So we are outputting into this print string the value that goes from 0 to 5 based on our alpha, which currently is 0. Let's set this to 0. Okay, the timeline in here does not mean anything. So let's actually remove this because we are not currently using the timeline. I'm explaining the lerp currently. And let's connect this to the event tick, which actually makes this get world data seconds useless. But we'll just keep it there because it's the same thing as doing this, so it doesn't really matter. Okay, so I'll compile, I'll save, and then by going back into the level and pressing play, in the top left, you can see that the time that it is currently displaying is 0. I'm gonna eject myself from my body, I'm gonna click on the platform, because this is where we have created this variable, and I'm going to change this variable to a value of 0.2. As you can see, now the value that it is displaying us is 1. Why is this? Because it is cycling through the values that are going from 0 to 1 based on a percentage of said values. So if we are at 0.2, the value that it is displaying us is 1. If we go to 0.4, you can guess that it is probably going to be 2. If we go to 0.6, of course 3. 0.8, it's gonna be 4. And when it is 1, it is going to be 5. Meaning that at 1, the output of this function will be the vector, or rather the float value that we are showing in here. Okay, so now that we have this thing a little bit more clear, let's go back to the timeline itself. Let's connect everything back together. And let's go here. I'm just gonna put this aside for now. And in here, we now know that we can change, thanks to the lerp, the vector A to vector B based on an alpha that goes from 0 to 1. The way we have set up the timeline is exactly to go from 0 to 1, and the values that the timeline outputs to us are going in a constant way forward. So 0, but then at 0.03 and then 0.011. We saw it earlier. So those are all values that go from 0 to 1. We are going to use these values as the alpha of the lerp itself. And then we are going to use the set world location to be the method that we're currently using. I'm going to recombine this struct bin, connect it to the set world location, which again, the only thing this set world location does is simply set the vector of an object, so the location here, to the value that is represented in here. So as soon as this one gets called, it will set the location based on the values that we have input him. And then we are going to connect the lerp, and then we are going to feed to the lerp these two values. So which one is going to be the starting position? That's fairly simple. The starting position is going to be the current position of our static mesh, which we can access by simply using the getWorldLocation function. The ending position, instead, is going to be a position that we are going to now create, and in which the platform that we're currently looking at, we want that platform to move into that position. So let's create this really quickly. There are a lot of ways we can do this. I'm just gonna do it the simplest way. I'm just gonna go in add component, add a scene component. The scene component is literally just an empty component. It doesn't really have anything apart from a location, a rotation, and a scale, and some little values which are arguably every object has these values that we don't really mind. And I'm going to just, leave this as it is. And the idea here is to use this scene component as the ending value of our platform. So I'm going to bring this guy into the blueprint, pick up his world location, and connect it to the end of our lerp. I'm just gonna tick teleport here for the set world location, because in this way the physics are not going to... If a platform is going up, then once it stops moving, it will launch the player up. If we put teleport, that means that the physics states of the platform moving won't add forces to whatever object is on top of it. So that means that the player won't be launched in case it's on the platform itself. So just using the teleport function. So we have set up the lerp. This is going to happen after 3 seconds we press the play. And one final thing, let's go in here and let's set the scene component to be a little bit slightly up. So here. So in this way, this is the starting position and this is the ending position. Let's press play and see what happens. So after 3 seconds, the platform has moved from this position to this position. Perfect. If we want to test this out in game as well, we can jump on top of the platform. And as you can see, it has elevated us to a higher ground. Okay, so in this way, we now have an understanding of timelines and how to use them in order to move things around the scene. Now, before I go into the other methods, let's try to connect this to our mechanic that we have created beforehand of colors. So what do I want to do here? I want to make it so that whenever the platform in here changes the color to a color that we have decided for it. So let's say that currently this platform is going to be white. So I'm just gonna do that really quickly. So it's going to be white. So the platform currently is white. Let's say that if it changes color to, let's say, red, then it will go up. If any other color is put on the platform, then it will not do anything. Okay, so we have this idea in mind that the platform needs to change elevation based on an action from our player. Let's go back into the player. Let's go into the event graph. Let's try to understand what triggers the changing of things within our code. So we know that the changing happens after there has been this condition set. So after these two conditions are met, then we are doing an action. In this case, the action is to set the material to something that's called color picked and set the color picked to what arguably is the white color. Okay. So we want the action to happen in here. We don't mind the right click for now because remember the logic. If I give him a color, I want to go up. If I remove the color, actually, I want it to go down, I suppose. So let's indeed actually have it happening on both of these ends. Okay, so I'm going to introduce you to a new concept, which is called interfaces, and we are going to use these interfaces in order to achieve what we are currently trying to achieve. I'll first of all, to make sure that this is more clear, I'm gonna first of all save everything. So why arguably it could be simpler to just have an event in here which calls the moving platform, and that once it calls the said moving platform, it will move the object. It will be, of course, simpler, and I will actually show you how to do that straight away. But after we have done this, I'll show you how to optimize the code using said interfaces. So, before the use on the interface, let's make sure that we do this the simple way. Let's use something called a cast. Okay, so what are the other methods we can use in order to move something? Timelines in themselves have the good thing of making sure that a lerp can happen quite simply. As you can see, the track itself can be set to work with lerps almost perfectly, where we can put the value to 0 and 1, and have, of course, the lerp working only with 0 and 1 as its main values. Will greatly appreciate that. But it is not necessarily the most easy one to actually change whenever we need changes to happen. Instead of a timeline, we can also use something called a timer in order to create this same exact movement. So let's go back into the event begin play. Let's unplug this. Another important thing that I need to mention is timelines cannot be put inside functions. I'll show you this really quickly. I'll right click on the timeline itself. I'll click on collapse the function, and it will actually give me an error. Why is this? Timelines, because they are something that is based around time and around durations, they won't work well with functions, because the main idea of a function is to be something that gets called one single time. And because of this, and because timelines gets called for a specific period of time, they are incompatible with one another. Arguably, and if you guessed right, delays as well cannot be put inside a function for this same exact reason. A function needs to execute its entire code from start to finish without any interruptions based on time. You can create those interruptions yourself outside of a function, but the function itself needs to work in a single frame. So let's delete this one. The timeline, because they cannot go into a function, they are much harder to copy. Let's say copy paste, but actually they are much harder to simply use multiple times, because whenever you need to create a movement, you will need to create a new timeline for said movement. While if you have created the movement once in a function, then you can copy and paste that function around so that that movement can be used in different ways much faster, because you already have the code written. So, timers. This is how you use them. They usually are set within the event begin play, because they need to be set first. We are going to use the set timer by function name, but the event is pretty much the same. Just instead of having as an input the function name, it will have as an input an event. So I'll show you very quickly how this other one looks like. So it will have as an input the event, so this little string on top of the event itself. And by simply moving the event and put it into the event, it will let you connect them. Of course, this cannot work with tick because it happens every single frame. The event needs to be set once, so event begin play would work well, but of course this won't make really a lot of sense, because you're connecting the event begin play, which is calling the set timer by event, to its event. This means that everything gets a little bit messed up. But anyways, let's ignore the set timer by event for now. So we are setting this timer by function name, giving him the function name of, create a new function. Let's call this move the platform func, which means function, because we already had the same name into in the timeline. And let's give him into the function name the name of the function that we have just created. Let's press on looping, and let's give him as the time. We don't mind these two variables. Let's give him as the time the 0.02. Also, initial start delay variants are a simple way of starting a delay within this timer, which, don't worry, we are not going to use them. These are not really necessarily needed. Depends on how you're going to use timers. Once we have finished using timers, this will become much more clear on what they will do. So we have now this timer set in place. We are now going to right click here, promote this to a variable, and we're going to call this move platform timer. In this way, we now have this variable that exists exclusively as a reference to this timer. And we are going to use the function called pause timer by handle. This will pause, as you can actually guess from the name, will pause the timer that we give him based on his handle input. So the handle in here is this variable that we have just created. And the timer that it will be pausing is this one. Okay, so after we have done this, let's now go into the move platform function. And let's give this a print string that says hello. Let's give him as the duration the get world delta seconds so that it won't get repeated on our left. So the idea behind timer is this. We are here setting a timer within our blueprints, and the time of the timer to execute, so how much time it needs to wait before executing something, we have put as the timer here 0.02, which means that every 0.02 seconds it will execute himself. We have saved his reference in here, and thanks to its reference, we have paused this timer. Now I'm going to create a custom event, and I'm going to call this test just because of originality, and I'm going to use the unpause timer by handle function, and I'm going to give him this timer, and I'm going to also give him a delay of 3 seconds. So what's gonna happen in here is that at the start of the game we are going to create a timer based off of the function called move the platform function. The timer is going to be called every 0.02 seconds, and it is going to loop, meaning that every 0.02 seconds that this timer is not stopped, it will constantly call the move the platform function. We have set his reference to be this. You have stopped actually the timer, meaning that as soon as a game gets started, the timer is created and then it gets paused immediately, meaning that nothing happens. We've just created the variable. After 3 seconds have passed, we then are going to unpause our timer. And I also, to make sure that test gets called, I actually need to make sure that test gets called. So there we go. So after the game started, we do this, and then test gets called. This is test. Once we wait for 3 seconds, it will unpause our timer. Okay, now we save everything, we compile, we go back into the level, press play. We wait for a bit, and after 3 seconds have passed, you can see on the screen, hello is flashing on the screen itself. Why is it flashing? Very simple. Simply because we are calling the timer every 0.02 seconds, but the get world delta second is instead having a value that is less than 0.02, meaning that this will last for less time then the timer gets called, meaning that hello appears, it will disappear, and after 0.02 seconds have been passed, it will appear again. So that's why it was flashing. Nothing too scary to be to happen. So now we know that the way this is working is very, very similar to the timelines, in which the timeline gets called quite frequently every frame, and that by getting called so many times, we can actually create a movement out of it, thanks to the lerp. Let's do the same exact thing within the timers, using the timers, within the move the platform function, so in here. So, because we cannot use a timeline, we are actually going to be doing something else. We are going to create this float point that is in new track ourselves, and then after having done so, we are going to make sure that this gets from 0 to 1 thanks to the function itself. So, how do we do this? We already have a variable in here. I'm just going to delete this for to not confuse you too much. I'm going to create a new variable. I'm going to call this variable timer. or actually move platform. Let's call this timer, and let's call this handler, because it's probably a better way of calling them. I'm gonna change this to a float. We don't need this to be public. I'm going to set it every time the platform gets called based on an expression. The expression is going to be move platform timer plus 0.02. And I'm going to connect this to this. So what this actually means is that every single time move the platform function gets called, then it will add to move platform timer 0.02 as a value. This means that every time you call this is going to go from 0, 0.02, 0.04, 0.06, and so on. Let's check this really quickly to make sure that it's actually what's happening. So compile, save, I'll press play, we wait 3 seconds. So as we can see, it is actually working the same exact way the values of the timer were, where it's going from 0 to 1 in a very steady fashion. Awesome. So we can actually create a lerp simply by using this. I'm going to go back to the event graph. I'm going to copy these two because these are exactly the things that we need at the moment. Copy and paste them here. We can use the move platform timer as the alpha. And I then can use the set world location as its method at the end. So arguably, already by writing this, it should already work. We can test this simply, but there are a little bit more things that we need to do that I'm going to be showing you now. Before, let's make sure that it works. So after 3 seconds, it moves the platforms up. What's the issue here that we need to make sure that are fixed? First of all, the move platform timer keeps going up even though this has already reached its maximum location. Also, the timer is still getting called even after the platform has moved up, which is not something we want to happen. So to fix this, we are going to use a condition after having moved the platform, which is going to ask if move platform timer is bigger or equal to 1. Because if it is 1, that means that the platform has moved up where it was supposed to move. We're going to use this as a condition. And if the move platform timer has actually reached 1, that means that we want to move platform timer to 0 again, so that we can reset the timer in case we want to use it again. And then we are going to pause completely the timer. Pause timer by handle. And the handle that we are going to give him is, of course, the timer that we have created at the start. So let's check this. Let's make sure that we know the value of moving platform always. Actually, for this, I'm going to have a print string in the tick event, because once we pause the timer of the function in here, if we had any print string here, it won't print anything anymore, because this entire function will not be called anymore. Therefore, I'm going to put 1 into tick. I'm just gonna do this here, and then move platform timer in hello. Okay, so let's compile, let's save, let's press play, let's wait. So 0, 0 in the top, then it got to 0.1, and then once it reached 0.1, it went back to 0 again. There was something weird though that happened, in which it actually reached the top before the 0.01 has actually finished. I imagine this is happening because of possibly because we are using in the lerp a variable that is constantly changing. So what do I mean by this? Scene is not going to change its position throughout the movement, because in here, if static mesh, if scene is in the top here, If static mesh moves up, scene stays where it is, meaning that for the entire duration of this function, scene stays where it should be. Static mesh, on the other hand, changes while the action is happening. This means that it's actually acting weirdly with the lerp. Because if we tell the lerp that it needs to move something from A to B, and then we change A constantly, that means that the percentage that it is doing is not going to be the one we were taught we were thinking we were doing. To put it simply, to fix this issue, we need to set the static mesh position before we go into the lerp. To do this, we can simply go into the event graph, and we want this to happen at the start, because if we do it anywhere else, it's probably going to change the position of whatever we are trying to change eventually. Or arguably, we can even do it before we unpause the timer, because we know that whenever we unpause the timer, we want the position of the lerp to be not changing. So even if he has changed beforehand in any way, maybe before moving the timer, before turning on that timer, we moved the platform anywhere else, like with other movements or other scripts, who knows. But after the timer has started, we want this position to be static. So we can actually set this position over here instead of in the beginning. So to set the position is very simple. We go into static mesh. We go on get world location, so that we can take the current position of the static mesh object. Then we create a new variable. We call this platform initial pos. We give this variable the variable type of vector, and then we set this variable to be the current position of the static mesh. And once we have done this process, we unpause the timer that we have created. Now we go into the function, and instead of having this, I'm going to delete it, and I'm going to use this one instead. So whenever we press play, I now check the platform, and it goes exactly from 0 to 1, where 1 is the final position, and in this way it follows exactly what we wanted to do. So whenever this becomes 1, we know for sure that the platform has reached the final position. And we can stop everything else. Perfect. So let's save everything. The cool thing about this code is that it can be very flexible. So if I move the platform, let's say here, and the scene is over there, like if we put it anywhere and we press play, it doesn't matter where the position is. It will go from point A to point B nonetheless. It is also, this method is much better than simply using a timeline, because with this method we have, because it is a function in itself, we actually have a lot more flexibility with this than what we had beforehand with the timeline. Because using a function let us create a lot of different possibilities that, flexibly speaking, give a much cleaner code in the end. So overall, it's a much better method of timelines. Okay, so these are the main two methods that you could arguably use within an engine, within specifically Unreal Engine, in order to move things around. There are ways of creating a much cooler movement in terms of animation, which are also going to be called VLERP, FLERP, and RLERP. And many more. Each one of these lerps are created and they exist to lerp specifically between different... Oh, wait, sorry. Yeah, they're called interpolation. There we go, sorry. So there is a thing in Unreal Engine which is called FInterp2, which basically is a different version of the lerp, and that its main way of being used is for something that doesn't necessarily goes from A to B. So instead of using simply the A to B function, this instead will know its current position and will know its target position and will move to that target position with a specific speed. So you know how I've told you that we were using the scene world location and this was causing issues to the lerp? This issue does not occur within the F interpolation too. And there is also F stands for float. Interpolation is simply a way of moving things and way to interpolate from one value to another. The V interp is the one we're probably going to be using for vectors. So if we want to redo this entire code, but this time using the V interp instead of the normal lerp, we can do so. And the differences are specifically based on the fact that the lerp is static in terms of positions, while the V interp is dynamic in terms of positions. I'll show you this in the engine once we have implemented this, the main differences. So let's get the static mesh, get world location, and let's feed this to the current. Let's give him the scene as the target. The interpolation, I'm just gonna set as 1 for now, the speed, and the delta time is going to be the move platform timer. I may be wrong on this one. I'll check this. We can check this afterwards. And after having done this, instead of plugging into the set world location the lerp, we are going to plug instead the vinterp. Again, we are simply changing the method that we are using for the movement. We are not changing anything about the movement code. So I'm gonna save everything. I'm gonna press play. After 3 seconds, let's see what happens. It moves from this position to that position. We don't know how much time it takes, nor we have something that we can use in order to specifically track the position. So this actually will be called, but one won't be representing the ending of movement anymore. As you saw, before this reached 1, the platform was already at the end. So we cannot use this condition to check for this. What we can use instead is we can check if the position of the static mesh is the same as scene, the scene static mesh. Meaning that if it is the same, then it reached the end. To do so, we simply use an equal. This is a near equal vector because vectors are made of floats and they have a lot of decimals. Most of the time, you cannot be super precise with their value. So in here, we're simply going to put a value of 0.1 as the roundabouts of when we want this statement to be true. And then we can fit this into this. By compile, pressing save and press play, as soon as that platform reaches the top, then the script finishes. As you can see in the top left, it's 0.00 instantly. If I go back into the other condition and I press play, you can see the value on the top left. It has not reached 1 and the platform is already there. So this is why we are doing this other change here. Let me show you something cool about the main difference between these two. Actually, I'll show you the difference visually. So let's put an interpolation speed of 5. In here, the interpolation speed actually works weirdly. The higher the number... Oh no, it actually moved faster. Never mind. So let's put 0.1 so that it is very slow. Excellent. So you see how much smoother it is, first of all. This is because the values are given based on a curve instead of a static increase, the float values. And we can also do something much neater with this. I'm gonna put the position to 0.01 so that it's extremely slow. Let me check that first. Perfect. I'm going to change the condition. Okay, no, the condition are already met. And now, what I'll show you, this is actually something really neat with the interpolations. So if I go in here, I press play, I pause the game for a second, I eject myself. and I'll go into here and press on the scene. I want to have control over the scene. Okay, here you go. This is where the scene is. So this is the ending point of our platform. If I now resume and I wait for the platform to move, I can change the scene location at any time, and the platform will follow the scene location constantly. It's quite amusing to see. Oh, of course, it's not doing it now anymore because, again, once it has reached this condition, which is to be at the same position of the scene, then it will pause himself. Okay, so perfect. If I try to do the same exact thing with the lerp position, this is what happens instead. I'll resume. As you can see, it will still follow the scene, but it will do so in a very static fashion. It's probably a good way of saying it. The lerp in itself is not necessarily constructed to work on moving objects. As you can see, by moving the platform, it is actually by moving the scene, it is actually moving the platform itself, because the platform is trying to find that exact spot it needs to be when a specific percentage has been reached. So I'll show you again. I want to explain this very thoroughly because it's a very important method to know how to use. So again, if we are at 0, this is for lerps, and there is 1, this is our platform. And this is our scene. If the platform is at 0, it will stay this exact length from the scene, which is this position here. If our value, which again is the move platform timer value, gets to 0.5, the platform will actually be, no matter where the scene exactly is, it will be in the center between this point, which is the start, and this point, which is the end. Meaning that even if we move the scene over here, the platform, what it will do, it will calculate the distance between these 2 points, and then it will set its position in the middle of these two. This is why whenever we were moving the scene, the platform was exactly positioning in that space, was moving itself, trying to position itself in that space. Hopefully it is much clearer now. So for ease, we are going to use the vinterp, but remember that lerp is perfectly fine to use as well, since it's a very useful method. Just keep in mind that lerp requires the two initial and ending position to be static, which means you will need to initialize these positions in the code yourself. And sometimes it can get a little bit chaotic in the way you are setting these positions, because if you're trying to move not simply the location, but also the rotation of an object, this would not have only been the platform location, it would also have been the rotation, which can become arguably a little bit chaotic in the code if you have a lot of lerps going on and a lot of objects. So I'm simply going to put the interp conditions, and I'm gonna remove these guys. I'm gonna set this back to 0.02. And in this way, we have now a much better understanding of timelines and timers. When would you use one over the other and vice versa? So, my take on here, it's mainly based on opinion. Personally, I always prefer to use timers because they are much more manageable than timelines. If I want to stop a timeline from anywhere within my code, I need to have a specific event connected to the stop execution pin of the timeline to stop the timeline. If I want to stop the movement of an object that is being moved with the timer, the only thing I need is this guy over here. And I can call this anywhere in my code, which makes the timers extremely flexible in terms of things they can do. And the best part is that whenever I unpause a timer, I can actually have a function here which actually resets this move the platform function So what I can do is that I can, in the true event, I can have a reset move the platform function. And what this does is that it sets back all the variables that it needs to set back, in which case we only have move platform timer now, but arguably there could be more. And then you can call this event as well. And I can then call that function anywhere, and that would pretty much reset back my movement, and I can call the movement again if I need to do that. So it's extremely flexible whenever you need to do a lot of different operations one after the other in your code. So awesome. We know that these two are set in place. Now, let's go to something called a construction script, which is the thing in here that you see close to the event graph. I'm going to be talking about the construction script in the next video, so stick around. I'll see you in the next video, and have a good one. Let's talk about the construction script. So, what exactly is the construction script? Simply put, the construction script is another tab which exists pretty much on every actor that can contain script in it. So for example, the moving platform. And it is a way of creating changes within our level in the editor itself. Let's look at an example of this. Right now, the platform is of color white. If I want to change the color of the platform within my within the editor itself, instead of going into the play function, I will do this through the construction script. Let's do this really quickly. So everything works pretty much the same and exact as the normal event graph blueprints. So we can pick up a static mesh. We can use set material function in here without too much trouble. And then I can create a variable in here, which is a public variable. And I'll call this platform material. And by doing this in this way, now what can happen is that I can go back into my level. I can click on my platform. And now in here, you see that there is this new variable called platform material. Because it was put to public, we can see here in the expector. Now, if I change the material of this platform in here to white, it will change the material of the platform itself. So construction scripts are extremely powerful when it comes down to creating tools or to create things that lets you decide within the editor itself different variables that you want to assign to your things. In here, we can create so much more. In general, the construction script exists on every object. Therefore, for each one of these objects, there will be a call to their own construction scripts, meaning that if I use a print string in here that simply says hello, and I compile and I save, you can see here appearing those hello are appearing. Multiple of them have appeared because the object in itself was called multiple times in that span of time. And the construction script usually doesn't work in the same fashion as the normal event work. In here, we have the tick event, which gets called every frame of the game. We have the begin event, which gets called at the start of each game. And we have the custom events, which gets called every time we, call them. For the construction script, it usually gets called at the first time you compile and save an object. So, for example, in here, if I were to compile the script again, you can see hello appearing. But it also gets called for different action that can happen on the object itself. We have the construction script on this guy. So if I move this object around, you will see that the construction script will get called every single time, which is not happening now. I'm not sure why. I suppose because there are no changes that are happening, the construction script is not getting called. Let's see, can I trigger some changes? I wonder. Oh, okay. Now he has decided to call itself. So it seems like anytime I press on any of these variables, it seems like they are calling the construction script. In general, the idea behind the construction script is that You don't know exactly when it gets called in the editor, apart from when you compile it. This is probably the most reliable one. So always stick to the idea of compiling everything when you want things to go through. And in general, you will do this for any object in your scene. Let's try to check of a way to actually use the construction script to our advantage within our game. You recall the main idea behind our mechanic is about the colors, right? So let's do something neat. So whenever you are in the editor, it will actually show you what colors an object needs to have in order to be completed. But whenever you press play, those objects turn back to white, meaning that generally speaking, those objects are white, but their completion color needs to be a specific color. So let's go into the other map, test level. Let's save everything. Let's put our moving platform. As you can see, whenever I'm putting into the game, again, it's calling the construction script whenever I scale it, but usually it's not consistent as you saw, so it's not something we can trust. So I'm moving my platform over here. I'm just doing it so that this platform actually can be used in some ways, maybe to get up here. So if we quickly press play, I look on the left, the platform should go up. Yep, it is going up. So for now, let's just ignore that. So what we want to do in here is that we want it so that we know that to have such an action happen, the one of moving up, our platform needs to be of a specific color. Currently it is white, but it is still moving. Let's block the movement by unplugging the timer we've set up in the last video. And let's show the color of the platform that it needs to have in order to be complete, to be working. So, platform material, let's call this instead platform completed material, I would say. Kind of a clunky name, but we'll work with it for now. And let's set this material to something new. So let's go into materials. Let's go into level materials. Let's create a new level material. It's level material, yes. And let's call this m_level material _ oh wait, did it change? Wait, let's do this again. Just making sure that I'm not renaming it too many times. So right click, create material instance, and instead of inst, I'm gonna write down moving platform. Okay. And this color, let's decide it to be red. Okay, awesome. Let's save everything. Close this. Now, I'm going to go into the construction script, and I'm going to set the material of our current material to be the same as platform completed material. In this case, this means that we can now go here, set this material to red. I think I called it moving platform instead. Moving. Okie dokie. Yes, awesome. So thanks to the construction script, now we have changed the material of this platform to red. But this is a material that we can only see in the editor ourselves. To know that that platform to be completed needs the color red. But whenever you go into the game, the material of the platform will instead be white, which we are setting now in the event begin play, meaning that at the start of the game this will happen. The construction script does not get called in the play mode, therefore any changes in here will be saved, of course. So if I were to press now play, the platform will be red, therefore I can pick up his color. But if I do any changes within the code to whatever the construction script has set before, the construction script won't be called within the play mode. Therefore, if I now press play, the platform will be white, which is exactly what we want. In this way, we that created the game, like us developers, know that the material to be the material that this platform needs to be completed is red, because we can see it in the editor. Whenever we are going to have a lot of objects in the scene, we can see that the completed material of this object will be red. But the player, of course, will not know this. He will need to experiment and test things out. Of course, we currently don't really have the red material within our scene, so this cannot be done yet. But it's something that we can change for sure later down the line. So this is a very small example what the construction material can do. Throughout this project, there are probably going to be more applications done thanks to the construction script itself. But for now, we are just gonna stick to something simple, because it's very scary to work with the construction script itself, because if you do something within here that the engine does not like, it will actually crash your entire engine. So always be careful about what you do within the construction script. My advice is to treat the construction script as a function where you do not want things like delays, you do not want things like timelines, you do not want things that would not work in a function that usually can only get called once. So always stick to something simple for the construction script itself. So this was a very brief attention to the construction script. I'm going to end this video here. The only thing I would like to point out is that in the next videos, we are going to look into a little bit more into the structure of the code itself, how to structure things in a much more interesting way. I'm going to introduce you to the concept of hereditary. And overall, we are also going to look into blueprint interfaces, as well as some other little mechanics for our game that we're currently making. So see you in the next video.
Hi again! Congratulations on completing this free 6-hour Unreal Engine course. It's a big achievement, and I hope that you have enjoyed it. You are now ready to start creating great stuff. If you would like to uncover all the hidden tricks, tips, and unique styles of working with Unreal Engine, go check it out on skillademia.com. The beginner to advanced course consists of many more hours of exercises, turning you into a pro in no time. You'll be able to learn everything you need to know about improving your games and complete many more projects, making you into an Unreal Engine Games Master. If this sounds like something you want, check us out. Thanks for watching and see you soon.